Welcome to this course on Java from in 28 minutes. I am Ranga Karanam. I have more than 20 years of Java programming experience. I've been using Java from Java 4. I've worked with Java 5, 6, 7, 8, and now I'm using Java 9 as well. At in 28 minutes, we ask ourselves one question every day. How do we create more effective courses? The success we had on a variety of platforms, including Udemy, with more than 100,000 learners, is a result of this pursuit of excellence. We love programming and we would want to help you develop a love for programming as well. In this awesome course, with more than 250 steps, you will learn the basics of programming with Java. You will discover how to solve a variety of problems. More importantly, you would learn how to think as a programmer. This will be a hands-on course with hundreds of code examples using the best tools to learn Java 9. Eclipse, which is the most popular Java IDE, and JShell, an awesome tool to learn programming. In this course, we would start with the basics of programming, how to get started, and also talk about variables, methods, conditionals like if, switch, and a lot of other stuff, loops, for loop, while loop, do while, and do a lot of examples with each one of them. We would talk about object-oriented programming in depth. We would talk about a variety of inbuilt Java types like string, big decimal, wrapper classes, dates. We would also talk about complex topics like collections, threads, concurrency, functional programming, and exception handling. We would also talk about a wide variety of best practices, programming standards, and give you tips on how to become an excellent programmer. Inside the course, you can also download a free PDF. This PDF has more than 175 pages. For each of the sections of the course, you would discuss what are the different steps which we would talk about, what are the different exercises that you would do, and the code examples that are used as part of that specific section. This PDF would serve as a companion guide helping you to debug and solve problems as you face them. The GitHub repository associated with the course also has all the code and the step-by-step details. I'm excited to bring this course to you. If you are as excited as I am, go ahead and click the enroll button. Or you can take a test drive by using the free preview feature. Good luck, and I will see you in the course. Welcome back. In this video, we would help you understand how to make the best use of the course guide. If you hover over to the resources section or the description, you should find this PDF linked. The course guide contains the details of all the sections which are present in this course. Each of the sections has the step-by-step details. What exactly do we do in that section? It contains the description of each of the exercises that are assigned to you in those sections. So if you are looking at an exercise on the screen and you would want the text of it, you can come to this PDF guide and copy it. You can also find all the code snippets and the programs that we write in the course in this PDF. So if you are actually trying to write a line of code and you see that you get a compilation error, then you can try and come to the guide, find that specific line and see how it is done in here. You can copy the line from here. You can also use the course guide when you would want to revise the concepts. So you can go into the collections, look at all the things that we have learned, all the code that we have executed, and try to recollect all the things that we have done around it. There you go. Whenever you face a problem, just try and find the corresponding piece of code in the course guide and compare against what you are doing differently. I hope you are having a lot of fun, and I'll see you in the next step. Until then, bye-bye. Welcome to this guide where we would help you install Java 9 and Eclipse. In this video, let's start with installing Java 9. What we would want to install is the JDK, Java Development Kit. We would want to write programs, compile them, and do a lot of things with them, so we would need a JDK. We have created this awesome PDF to help you install Java 9 and Eclipse very easily. This contains instructions on how to install Java 9, how to verify your Java installation, how to troubleshoot it, and also sometimes you need to set something called a path variable in Windows. So it helps you do that, as well as it has instructions on how to install Eclipse as well. Just hold over to the resources or the description of the video and you should be able to find this specific PDF. Now, let's get started with installing Java 9. All that you need to do is to go to Google and search for Java 9 JDK download. One of the first links you should see should be a link from oracle.com and it should read something like Java SC Development Kit 9 downloads. So you just need to click the link and that would take you to the Oracle JDK download site. You'd be able to see at the bottom a list of downloadables for different operating systems. Before you'd be able to download, you need to accept the license agreement. Accept license agreement as it is shown in here. And once you do that, you can go ahead and download the JDK for your specific operating system. So if you're on Linux, then use this. If you're on Mac, download the DMG file. If you're on Windows, download the exe file. Once you click the exe, it would take a little while for the whole thing to download. The download size, as you can see in here, is about 200 to 400 MB based on the operating system. So this would take a little while to download. Once the download completes, all that you need to do is to locate your download file. Double click it. So this screenshot shows it on Windows. So on Windows, this is in my downloads folder and I just need to launch it by double clicking it. And similarly, the same is the case with either Mac or Linux. You just need to double click the downloaded file and it would launch up the installation screens for Java. The installation of Java is very simple process. All that you need to do is take the defaults and click next, next, next on all the further screens. You should see a screen like this, which is the first one where it's trying to prepare the installation wizard. Next screen you would see is the installation wizard is ready. You can click next again, and after that you'd be going to a place where you'd be able to choose the development tools, the source code and public JRE and all that kind of stuff. At this point, don't worry about what all those are about. Take the defaults, make sure that you take a copy of this folder location. Take a notepad or something and copy the thing into there and click next. The Java JDK installation will take a little while, so be patient. You'd see that the installation of Java would start, and after a little while you'd see this message: congratulations, Java SC development successfully installed. Congratulations on installing Java 9. If you have any problems, just go to the resources section and download the PDF and you should be able to find help in it on how to resolve the problem. I'll see you on the other side where we would verify the Java installation. Until then, bye-bye. Welcome back. In the previous step, we installed JDK 9. In this step, let's verify our installation. We would check for two things. One is Java and the other one is JShell. JShell is one of the important tools in Java which is introduced in Java 9, which makes learning programming very, very easy. We'll check if Java and JShell are properly installed in this video. One of the first steps that we would need to do is to launch up terminal or command prompt. If you are familiar with your operating system, then you would know how to launch it up. So if you are on Windows, all that you need to do is press the start button and type in CMD. This would bring up CMD and you can double click to launch it up. The other way you can launch up command prompt on Windows is by clicking the start button, selecting all programs, accessories and command prompt. However, if you're on Mac, then it's easy, right? So all that you need to do is press command space and type in terminal. Once you launch up the terminal or command prompt, you can type in Java-version. So it's Java followed by a space followed by -version. And you should see something similar to this printed. So here you can see that it's Java version 9.0.1. Any version which is greater than 9 should be fine for us. If you do not see this happening, I would recommend you to move to the troubleshooting video and see how you can troubleshoot this. But if it's all fine and Java is working fine, then all that you need to do is type in JShell version. You can see that it's showing JShell 9.0.1. So the command is very simple, right? So JShell space hyphen version. If you are on Windows and Java is working for you and JShell is not working, in that situation, you need to do something called adding a path variable. We'll have a video after this where we would talk about how to add a path variable in Windows. If you have the JShell hyphen version working, then you can launch up JShell. And now you can see something called JShell come up. So it says welcome to JShell version 9.0.1. Over here, I'll try and do a simple calculation to check if it's fine. 6 into 8, 48. Don't worry about what is this and all that stuff. We'll discuss this a little later. Now you can type in /exit to get out of JShell. This is how you can verify if you have Java and JShell working. If you have both the Java and JShell working, then you can skip the next video on troubleshooting, and also you can skip the video after that on setting the path variable. If Java hyphen version was not really working for you, or if you're seeing a version which is less than 9, something like 8, then you need to look at the troubleshooting video. I'll see you in the next video. Until then, bye-bye. Welcome back. In this video, we would want to help you troubleshoot your Java installation. If Java hyphen version is working properly for you and you see a version greater than 9, you can skip this video. One of the first things that you need to do is to uninstall any of the pre-existing Java installs. So if you're seeing something like Java 7 or Java 8, one of the first things you need to do is to uninstall them. In the PDF, we have links on how you can do installation on Windows, Mac and Linux. And over there, you'll also find instructions on how to uninstall an earlier JDK. So follow those instructions and try and uninstall any pre-existing installs. The other problems which would typically be there will be due to firewalls or antivirus software. So try and temporarily turn them off and install Java and see if it works out fine. The other thing which might be a problem is your download. The file for installing Java is downloaded from internet and there's a chance that it is corrupt. So one of the things you can try and do is to download the whole thing again and try and do the installation again. The fourth thing that you can check is if you're on Windows, Java 9 only supports a 64-bit Windows. It no longer supports 32-bit Windows. So make sure that you're using a 64-bit Windows operating system. The last thing you can check is the path variable. We'll look at the path variable in the next video and how to set it for Windows. In summary, one of the things I would recommend you to do is to try and go to these URLs and try and look at the installation instructions. These are detailed instructions which are provided by Oracle Java, and you can check them to see if they would help you to solve the problem. I'll see you in the next video. Until then, bye-bye. Welcome back. If you're on Windows and Java hyphen version is working for you and JShell hyphen version is not working for you, then that means the path variable for you is not really set. In this video, let's try and learn why you need to set the path variable and how to set it. The first question might be, why do we need a path variable? The thing what we are doing is on your local machine, once you install Java, there is a folder created of this kind where there is something called JShell. So you can see here is something called JShell. When we type in JShell, we would want to launch the JShell which is present in here up. How does the operating system know where JShell is present? How does the operating system know that JShell is present in this specific folder? For other operating systems like Linux and Mac, this setting is done automatically when we install. However, in Windows, we have to manually do this setting. One important thing you need to always remember is it's not the path which you are seeing on the screen. It should be the path which you see on your local machine. So what I would recommend you to do is to go to C Program Files Java. So try and go to the folder C Program Files Java on your local machine. You should see a number of folders like this. Try and locate the folder JDK9. So it should start with JDK, that stands for Java Development Kit, and it should have version 9 present in it. So JDK9, don't worry about the minor versions after that. It can be 9.1, 9.2, 9.3 or whatever. It does not really matter. So the important thing is take the folder JDK 9. Whatever, double click it. You can see that in my machine, it's C program files Java JDK 9.0.4. If you go inside 9.0.4, there is a folder called bin. So double click the bin folder, bin. So once you double click the bin folder, you can copy the path. So you can copy the path. So over here it's C program files Java JDK 9.0.4/bin. It might be 9.1 point something for you or whatever. So this is the path you need to copy. What you would want to be able to do is to add that path to your path variable. Path is an environment variable. So to be able to add path to the environment variable, you need to launch the environment variables up. So there are two ways actually. First one is to press Ctrl Escape. Once you press Ctrl Escape and type in env. So type in env. So you can see that on the screen, bottom of your screen right now. And you have to choose the second option. That's important. Not the first one, the second one, which says edit the system environment variables. So click that. That's the shortcut way of launching up the environment variables. The long option is to go click start, select control panel, then go to system, advanced, and then go to environment variables. I hope you are taking the short route and clicking the edit the system environment variables. Once you do this, you should see something like this launch up. So this is what you should see. Over here, we have to click environment variables. Once you launch up environment variables, you should see something like this coming up. In the bottom is where the system variables are. You might need to use the scroll bar a little bit to locate the path variable. It would be in alphabetical order. So M, N, O, P, P is where we need to edit. So path is in here, PATH is what you'd see right now over here. What we need to do is edit the value of the path variable. Before you do anything, folder that you have copied earlier of Java JDK bin, copy that into a notepad or something. And now what I can do is also take the backup of the content of your path. This value, variable value which you see in here inside the path is very, very important. You should not lose it. So just take it and copy it and put it into this file over here. What we have in here is the location of the bin folder, that's one. And the second one which we have in here is the old value, or actually I can say current value of path variable. So what I would recommend you to do is save this file and have it in a place where you can retrieve it little later. If something goes wrong with what we are doing, you might need this a little later. Now, how do you form the new value or the future value of the path variable that we would want to set? So we would want to set the future value for the path variable. What you can do is copy the bin folder, put a semicolon. So follow the bin folder with a semicolon, copy the current value of the path, and this would become the value that we would want to set into the path variable. Over here I only have 3 folders present. Typically the path variable might contain 15-20 folders. So be careful with that. You need to include all of them in the future value of the path variable. Now all that you need to do is take this and paste it into the path value. So into the variable value, paste that and click OK. So make sure that you click OK here, OK on the environment variables as well as on the system properties screen. What you can do now is go ahead and close the terminal which you have launched. So either click the close button or type in exit to get out of the terminal or the command prompt, and now you can launch the command prompt again. If you type in java-version, you should see 9.0.1, and if you type in JShell-version, you should be able to see JShell. You can also try and launch up JShell by typing JShell, and this would bring up the JShell for us. Over here I can try and type in a command. 5 into 5 is 25, right? 5 into 5 is 25. That's cool. And you can type in /exit to get out of JShell. If JShell is still not working for you, then I would recommend you to try and find the troubleshooting section of the PDF and follow the instructions which are present in there. I hope you had fun setting the path variable and getting the JShell up and running. The fun behind this course is about to start now. I'm excited to bring all this to you, and I'll see you in the next video. Until then, bye-bye. Welcome back. Why do you think I love programming? I love programming because I think programming is cool. It is a lot of fun, and I love solving problems. The combination of solving challenges while having a lot of fun is awesome. In this course, we would want to help you to develop a love for programming. If you had bad experiences in learning programming earlier, forget about them. Start afresh, and I promise this will be an awesome roller coaster ride. Let's take a step back and think, what are the important things you would need to learn to be a great programmer? As a programmer, you'd want to solve problems. You want to get the computer to do things for you. To be able to do that, you need to have problem solving skills. You need to be able to look at a problem and identify the important programming concepts that are important to solve the problem. And then you need to be able to use the language specific syntax to be able to express your solution in a specific programming language like Java or Python or Scala. While all this looks complex, we would make it very easy for you. We would take you through these steps for a variety of programming challenges. We will start with simple challenges like multiplication table and gradually increase the difficulty level over the duration of the course. One important thing you need to remember is that learning to program is a lot like learning to ride a bicycle. The first steps are the most difficult ones. Once you get over these initial steps, it becomes a lot of pure fun, just like riding a bicycle. Are you ready for your first programming challenge? Let's get going now. I'll see you in the next step where we would start with our first programming challenge. Congratulations and good luck. Welcome back. In this video, we would want to introduce you to the first challenge that we would be solving as a part of this course. The first problem that would be solving is a multiplication table. So we would want to print the multiplication table for 5. So this is the format that we would want to print the output in. So we would want to print 5 into 1 is equal to 5 and so on up to 5 into 10 is equal to 50. So this is the challenge, and what are the important concepts that we would need to solve this? Here are some of the important concepts that we would be using to solve this specific problem. We would be using JShell, which is a Java REPL. We'll talk about JShell a little later when we are introducing it to you. We'll learn about JShell, we would learn about what is a statement, expression, we would learn about variables, and we would also learn about if statement, for loop, methods, or functions. So those are all the concepts that you would learn while we are attempting to solve the multiplication table problem. All these concepts would be introduced to you one by one as we go step by step solving the challenge. I'll see you in the next step where we would start with launching up JShell. I'll see you in the next step. Welcome back. In this step, we would want to launch up JShell. Before launching up JShell, let's get a quick introduction to what JShell is. You can almost read JShell as Java Shell. So what is JShell all about? It's about a concept called REPL, R-E-P-L. It stands for read, eval, print, loop. Read, evaluate, print, and loop. Basically, it's all about, you can type in just one line of Java code. So you can type one statement or one expression, one line of Java code, and it would immediately show you what is the output. So what is the result of execution of that line of code would be immediately shown to you. The thing is, JShell was introduced in Java 9, and that's the reason why we would want you to have at least Java 9 for following this course. JShell makes learning fun because it gives you immediate feedback. You type in a statement, if there's an error in the statement, then it would tell you, hey, you're doing something wrong. If it's working fine, then it would show you the output of that statement. I think from Java 9, learning Java becomes even more easier because of JShell. And that's the reason why JShell is one of the first things related to Java that we are introducing to you. Let's now launch up JShell. Launching up JShell is actually very simple, right? If you're on Mac, all that you need to do is press Command space and launch up terminal. So if you are doing a lot of stuff on the Mac, you know where your terminal is, right? So you can launch up terminal. If you are on Windows, then all that you need to do is to launch up your command prompt. So press Control and Escape. So press Control and Escape together and type in command or type in CMD. Press enter. Your command prompt would be launched up. Once your command prompt or the terminal is launched up, you should see a prompt something similar to this. It does not really matter what it says in here. So it should start something up, and over there you can type in Java-version. So the Java version that I am making use of in here is 9.0.1. The minimum version of Java that we would need to follow this course is Java 9. So this is good. So we have already installed Java and this is version 9. That's cool. The next step is to launch up JShell. Can you try and guess what the command would be to launch up JShell? Yep, you are right. It's very simple. It's just JShell. So just type in JShell. That's it, and press enter. That's as simple as it goes. So in JShell, you can see what it says. It says, okay, the version of JShell is 9.0.1, and here it's the same 9.0.1. The other thing you can see in here is the prompt has changed. Earlier there was a different prompt in here, but now it says JShell. So that's a good thing that you can check for. So JShell is what is in here. And if you really want to get an introduction to JShell, you can type in the command which is present in here. So it's /help followed by intro. And it gives you introduction to the JShell tool. It says the JShell tool allows you to execute Java code and get immediate results. Now, once you are in JShell, you can type in a few commands. So I can say something like 3 plus 4. It's saying 3 plus 4 is 7. Don't worry about this specific thing right now. So the important thing is when you type in 3 plus 4, it's giving you a result of 7. So this is cool. This means that your JShell is working fine. You have Java 9 installed and you have launched up JShell. The way to get out of JShell is to type in /exit. So /exit is to exit the JShell, and it says goodbye and it goes out. And the way you can launch JShell again is just typing in JShell. You can see the $prompt and yep, you are inside now, and /exit would actually take you out. This is something you need to remember because this is something which you would be doing a number of times during this course. We'll be using JShell. So you need to remember the command. It's JShell, and to get out of JShell, what is it? It's /exit. So in this video, what we learned is how to launch up JShell and how to exit out of it. So try it a few times, get comfortable with it, and in the next step, we would start focusing on the program that we would want to write. Until then, bye-bye. Welcome back. The challenge which we set ourselves is to print the multiplication table. So we would want to print a multiplication table of this kind. In this video, let's discuss how to break this problem up and where do we start. So what do we start with? That's what we would want to discover in this short video. Typically when we do programming, we have problems. Solving the problem typically needs a step-by-step approach. You identify sub-problems to solve and then go about solving them. So think about this. What would be the sub-problems that you would want to solve when you would want to print a multiplication table? How do we break it down and where do we really start? Here are a few things that I have identified. One of the first things that we can do is get the computer to calculate 5 into 5 or 5 into 6. The second thing that we can do is to try and print this entire thing. So I would want to print 5 into 5 is equal to the calculated value. So whatever value is calculated from here, I would want to use it and print it in here. So we would want to first calculate, then print, and what we want to do is not just print 5 into 5 is equal to 25, right? So we would want to print from 5 into 1 to 5 into 10. And to be able to do that, we would want to do something similar to this 10 times. Not exactly the same thing because we don't want to print 5 into 5 is equal to 25 10 times. We want to print the entire table with different values over here. So 1, 2, 3, 4, 5, so on. Let's start with that kind of a game plan and let's see where it takes us. I'll see you in the next step. We would focus on calculating 5 into 5. Welcome back. As we discussed in the previous step, in this video, we would want to focus on getting the computer to do this calculation 5 into 5. And the first thing that we would need to do is to log in into JShell. If you are already logged into JShell, that's cool. So I'm launching up JShell, just typing up JShell at here. If you have questions about how to launch up JShell, I would recommend you to watch the launching JShell video, which should be 3 or 4 steps about this. Now, we are already into JShell and we would want to calculate 5 into 5. What would happen? 5 into 5, it says error. The thing is, in Java, there are a few predefined operators. So when I would want to multiply 5 with 5, the operator is star. So 5 star 5. That's the multiplication operator. When I print 5 into 5 or 5 star 5, I can see that 25 is printed in here. There is a $1 and there is an arrow in here. Let's not worry about what it is for now. For now, you can see the value, the calculated value of this calculation. So 5 star 5, the calculated value is 25. This is called an expression. An expression typically has operands and operator. The star here is an operator. This is a multiplication operator. And these two, 5 and 5 in here, are called operands. These are also called literals. Literals in computers stand for values that don't change. So 5 here represents a number 5, an integer number 5. Don't worry about the terminology. If you are not able to get it first time, we will revise that multiple times during the course of this course. So what we are doing in here is we are typing in a simple expression. Let me type in another expression, 5 into 10. 5 star 10. And now you can see the value of it being printed in here. You have a variety of operations supported. So let's try a few. So 5 plus 10, 15. 5 minus 10 minus 5. Let's do a division as well. 10 by 2, 5. That's cool, right? So it's doing all the calculations for us. Integer numbers are basically whole numbers. So 1, 2, 3 and the negative numbers as well. So minus 5, minus 15, 0, million, billion, minus billion. All these are integer numbers. So on integer numbers, we looked at 4 different operations until now. Multiplication, addition, subtraction and division. The other interesting operator which is supported by Java is 9 mod 2. This is called modulus. This is basically your percentage sign. So 9 mod 2. When I'm doing an operation 9 mod 2, I'm getting a value of 1.
What do you think it is? It's basically the remainder when 9 is divided by 2. So when 9 is divided by 2, you have 2 4s are 8 and you have a remainder of 1, which is 9 minus 8. So that's basically what is being printed in here. Let's try 8 mod 2. This should print 0. Yep, that's basically what you'd see in here. So there are a few operations that we looked at on integer numbers until now: multiplication, division, addition, subtraction, and modulus. Now let's take a step back and look at the terminology again, right? So we did 5 star 5. This is multiplication and this is called an expression. So 5 star 5 is an expression, 5 star 10 is an expression, 5 plus 10 is an expression, 5 minus 10 is also an expression. And in these expressions, star, plus, minus, division operator and the modulus are called operators. So these are all operators and the operations are performed on operands, which are 5, 10, 10 to 9 over here. These constants in here are also called literals. So these numbers here are literals. So until now, what we looked at are numbers, integer numbers, and the operations that can be performed on them. I would recommend you to stop the video in here and try and play around with these operators. Try and type in a few expressions and see if the results are as per your expectation. Now let's move ahead. Until now we looked at basic expressions. Actually, expressions can get much more complex than this. So let's say I want to do 5 plus 5 plus 5. You can have expressions like this as well. So 5 plus 5 plus 5, it prints 15. So we are using two operators in here. Actually, you can even have different operators. So 5 plus 10 minus 15. So we have two different operators, plus and minus in here, and we get the result which is printed in here, which is 0. So these are expressions using multiple operators. We can try a few more expressions. 5 into 5 plus 5. 5 5s are 25 plus 5 is 30. So that's cool. 5 into 15 divided by 3. It's 5 into 15, 75 divided by 3 is 25. So you can go ahead, try and play around with these expressions. I'll end this video with a few exercises for you to try. So the expressions over here are used to calculate something, right? So let's do a few exercises where we calculate something really specific. The first exercise is to write an expression. So you'd want to write an expression to calculate number of minutes in a day. So you want to calculate how many minutes are there in a day. That's exercise number 1. And the next one is calculate number of seconds in a day. Think about it. So I would want to find out number of minutes in a day. How do I do that? And how I want to calculate number of seconds in a day as well. So how do I do that? So those are the two exercises I would leave you with. We will discuss solutions for these exercises in this video. But one of the most important things that you need to understand is you need to try to solve these problems by yourself. So try and see how you can do it by yourself. If you are able to work it out, that's fantastic. But if you are not able to work it out, that's part of the learning process. So the best way to learn is to try to solve it yourself and see how I do it. So that's the best way to learn. I would recommend you to try spending some time trying to do this exercise, and I'll see you in the next video. Until then, bye-bye. Welcome back. In this video, let's solve the exercises that we talked about in the previous video. So we would want to calculate the number of minutes in a day. So how do I find out? How do I find out the number of minutes in a day? So let's start with the number of hours in a day. So number of hours in a day is 24, and the number of minutes in every hour is 60. So 24 into 60, that's 1440. So that's the number of minutes in a day. Now you can pause this video and try and solve the next exercise, which is to calculate number of seconds in a day. So we already have the number of minutes. How do I now calculate the the number of seconds. If you use up arrow and down arrow, you can actually navigate through the previous expressions you have typed in. So up arrow and down arrow would be really useful in doing that. So let's type it from 0. So 24 hours in a day, each hour has 60 minutes, and each minute has how many seconds? It's 60. So 24 into 60 into 60. That's 86,400. That's the number of seconds in a specific day. I hope you had a lot of fun doing this exercise. Think about other things that you might want to calculate, and I'll see you in the next video. Welcome back. One of the important things that you need to understand is that this is a course meant for beginners, and that's why we make sure that there are a lot of problems that we are trying to solve, and also there are a lot of exercises and puzzles. We kind of take it a little slow at the start of the course to make sure that you are having fun while you are learning. In this video, let's try a few puzzles with expressions. So until now, we saw these expressions, right? So this is an expression, star and plus are operators, fives here are all literal values. So those are the things which we saw until now. Let's have even more fun with a few puzzles. So we saw 5 into 6 prints 30. But what would happen if I say something like this, 5 star star 6? What would happen? Think about it. Illegal expression. So this is what is your JShell complaining that something is wrong with your expression. It says this expression is invalid. I have no idea what star star is. We are doing programming, and programming languages have a specific syntax and a predefined set of operators. So you need to adhere to them. If you don't follow them, then programming languages start to complain, and this is called an error. So the complaining of programming language is what is called an error. It says illegal start of expression. So try and do things like that, right? So $5. What happens? It says it's an error. I have no idea what you're trying to do. I would do 5 star slash 5. It says illegal start of expression. So you can try a few invalid expressions like this. It's important to understand that if you try and type in something which the programming language does not understand, they need to throw an error. Now let's move on to the next puzzle. Think about this. So 5 slash 2. So slash is what? Slash is division operator, right? So 5 divided by 2. What should be the result? Think about it, calculate it. What should be the result? It says 2. So it says 5 slash 2 is equal to 2. 5 divided by 2 is should be 2 and half, 2.5, right? But it's printing 2. Why is it printing 2? Think about it. So basically, the way programming languages work, this is true for most of the programming languages, including Java, is 5 is a integer number. It does not have any decimals. And same is the case with 2. 2 is also an integer number. So when you divide 5 by 2, the result is also an integer. So when you divide an integer by an integer, the result is also a integer. So 5 divided by 2 is 2. It's not 2.5. If you really want to get 2.5 as the result, then you need to divide a floating point value, a decimal value. So 5.0 is a decimal value. When I do 5.0 by 2.0, then you would get the value 2.5. So 5 is an integer constant, 5.0 is a decimal constant. It's a floating point constant. You talk about floating point constants and the fact that this is a double a little later. Don't worry about it. For now, the important thing to understand is when you are performing an operation, the data type of the operands is important. Here 5 is an integer, 2 is an integer. When I divide 5 by 2, I get an integer. When I divide a floating point, divided by another floating point, you get the result as a floating point value. And even when you try and divide a floating point, you're performing an operation with floating point and a integer. So 5.0 is a floating point number, it has a decimal, and 2 is a integer number. So when I divide a floating point by a integer value, you get a floating point. So floating point and integer, the result is always floating point. So this is something you can remember. We'll discuss multiple variations of these as we go on in this course. Let's move on to another operation. So 5 plus 5 into 6. So think about this. What should be the result of this? So will it be calculated as 5 plus 5 and then the result is multiplied by 6? So that would mean 5 plus 5 is 10, 10 multiplied by 6 is 60. Or would it be 5 plus 5 into 6? So 5 into 6 is 30, 30 plus 5 is 35. So which one of them is true? It's printing 35. The way you need to think about this is in programming languages, there is something called precedence. So there is a precedence which is set, and the precedence typically in all programming languages is that multiplication, division, and modulus operators have greater precedence than plus and minus. So these three operators typically have greater precedence compared to plus and minus. So if you have any operation with these operators, first these operators get executed. So 5 into 6 gets executed first, and then 5 plus 5 into 6 is done. So 5 into 6 is 30, 30 plus 5 is 35, and that's the result which is printed in here. Let's now try a couple of other expressions. So you can say 5 minus 2 into 2. 2 into 2 has higher priority, star has higher precedence. So 2 into 2 is 4, 5 minus 4, 1. So you can think about what would be the result of this. So 5 minus 2 by 2, it's 4. So 2 by 2 is 1, and 5 minus 2 by 2 is 5 minus 1, which is 4. So now you might ask, what should I do if I would want to do this first? So if I have to do 5 minus 2 first and then divide it by 2, or if I want to do 5 minus 2 first and then multiply by 2, how do I do that? In programming languages, we have something called brackets. So you use these brackets and you put your expression between these. So if I want to do 5 minus 2 first and then multiply by 2, then I would put them in brackets. So over here we have a couple of brackets, and then you can see that it prints the value 6. So it does 5 minus 2 first and multiplies 8 by 2. One of the good practices to follow in programming is always use brackets to indicate what you would want to happen. So if some new programmer comes in and sees 5 into 5 minus 2 star 2, it becomes confusing for him. So even though this expression, the previous expression is same as this, if you want to do 5 minus 2 into 2, you want to first do the multiplication and then do the subtraction, even then you can add a bracket in just to make it clear for the programmer who is going to look at your code later. I hope you are having a lot of fun with this course until now. I hope you are having a lot of fun with this course. Some of the course platforms ask for a review very early. So if you see a request for a review very soon in the course and you're not ready for it, feel free to click the skip review button. Now that we have played with expressions a lot, let's move into the other subproblems. I'll see you in the next step. Welcome back. In the previous two steps, we understood how to calculate 5 into 5 using an expression. We dug in depth into expressions and looked at a few puzzles and exercises related to it as well. And now let's move on to the next subproblem. We want to be able to print 5 into 5 is equal to 25, and this 25 is not really directly 25, but we would want to actually calculate the value of 5 into 5 and put it in here. So we would want to print this to the console. So we would want to print this on the JShell console. How do we do that? That's basically the focus of this video. Let's start with a small tip before we go any further. If the speed at which I'm talking is too slow or too fast for you, you can adjust the playback speed. Look at the interface you are using for playing the video and you'd be able to adjust the speed of playback. Make use of this feature, so whenever you feel I'm talking slowly and you want to go faster, increase the speed, and if I'm going too fast for you, you can actually decrease the speed as well. So this is an excellent feature which almost all video UIs provide, so do make use of it. Okay, the tip aside, let's get back to the problem at hand. So until now, what we were doing is 3 into 4, right? So when we did 3 into 4, JShell is actually showing something which is happening in the background. It's saying that something is created and it was assigned a value of 12. So what we want to do is we would want to actually print just 12. To print 12 to the output, there are some predefined methods in Java. So let's look at them and see what they are all about. Typically, in all programming languages, you have different methods. In Java, the method to print something to the console is system.out.println, and I can print in 3 into 4. Now you'd see that the only thing which is printed now is 12. So this all thing about the background stuff which JShell is showing, it's not shown anymore. If you're not seeing 12 in here, then there might be a problem. So make sure that you're in JShell. So you should have been logged into JShell. So you would have opened up the command prompt or terminal and typed in JShell. And at the JShell prompt is where we are typing in this. And make sure that the case exactly matches. S here is capital. So it's system with a capital S followed by a dot, followed by out, followed by dot, followed by println. So this is exactly what it should be. And the other thing which should match is the open bracket and the close bracket in here. So make sure that you are in the JShell prompt, make sure that you're using the right case, make sure that you're putting 3 into 4 between the brackets, and you should see 12 being printed in here. Now, what's happening in here? What is system.out.println? Why should I use brackets? Why should I use a closing bracket in here? Let's find that right now. One of the most important things that you need to understand is computers don't really understand human language. At least as of now, they don't really understand human language. They have their own languages with very strict rules, and we are using one of them, right? Java. So that's what we are learning right now. For computers to understand you, we need to understand those rules. These rules are called syntax. Computers don't really like it when you don't use the right syntax. For example, if I am removing the opening bracket in here, so I'm removing it and I'm typing it, it says, hey, what are you doing? I don't understand you. You're not giving me the right instruction. Programming languages are like my strict Dutch instructor. I was living in Netherlands for a while and I was trying to learn Dutch. The instructor was really awesome. After a couple of classes, she only responded to questions in Dutch. So if I went ahead and asked a question in English, I would get a blank stare. And I had to ask the question in Dutch. That really helped me to learn Dutch fast. Programming languages are very similar. They are very, very strict about syntax. If you make a mistake in the syntax, then they would throw you an error. Having said that, let's look at the syntax for this specific thing that we are doing in here. Whatever we are doing in here is called a statement. A statement is nothing but an instruction to the computer to do something. Over here, what we are telling the computer to do is to calculate 3 into 4 and print it to the output. So the way we are telling computer to calculate 3 into 4 is by using an expression. And what we are doing is we are passing this expression. This is called passing. So in the brackets, we are passing this expression to a predefined function or a method, to a predefined method in Java. So system.out.println is a predefined method in Java. We are saying, okay, take this 3 into 4, send it to this function or method. And what does this method do? This method prints it out to the console. So system.out.println is printing the calculated value out to the console. The statement we are executing in here is a method call, and system.out.println is how to refer to that particular method. The name of the method is println, println is a shortcut of println. So println, and there is system.out. System is one of the classes in Java which contains a variable called out, which contains a method called println. Don't worry about all these details right now. We'll talk about variables, classes, and all that kind of stuff a little later. For now, you can think of it like this is the way I refer to a method. So the method is system.out.println. So this is the path to a method, or for now you can call it the method name, and I am passing a value to it. The value which is being passed to a method is called a parameter. So I am passing 3 into 4, which is 12, an expression. The calculated value will be passed to the method system.out.println. The syntax of a method call is something of this kind. So method path followed by open brace and your parameter. So parameter followed by a closing bracket. So this is the syntax. Over here in our example, the method path is kind of system.out.println. The parameter is 3 into 4. If this conversation about method calls, parameters, syntax is sounding a little too confusing for you, do not worry about it. We'll get back to this in the puzzles and the exercises after this specific video. For now, the important thing is system.out.println, when you are passing it a value of 3 into 4, the 3 into 4 is calculated and 12 is printed to the console, right? What we would want to do is print something of this kind. 5 into 2 is equal to 10. That's what we would want to print in the output, right? So let's try what would happen if I do that with system.out.println. So I'm saying 5 into 2 is equal to 10 and close bracket. So it's name of the method followed by bracket, open bracket, close bracket, and between that is what I would want to print. Would this work? Aha, it says unexpected type, found variable, found value. Something is wrong. That's basically what it's saying, right? So this 5 into 2 is an expression, but 5 into 2 is equal to 10 is not really an expression. So what Java is telling me, what the JShell is telling me is, okay, this is not the way you have to do that. So if you want to print some string like this, so this is what we are doing in here is we are printing the calculated value 3 into 4. What we are trying to do in here is we would want to print this as it is. So we would want to print 5 into 2 is equal to 10 as it is for now. We'll try and worry about how to get the calculated value in here a little later. But for now, let's focus on how to get the 5 into 2 is equal to 10 to the output. How do I do that? The way you need to do that is to use something called a string. So in programming languages, we use strings to represent text. So whenever you put something between double quotes, so typically most programming languages either use double quotes or single quotes to represent text. So now if I press enter, you'd see that 5 into 2 is equal to 10 is printed out to the console. Here what we are sending in is a integer value. Here what we are sending in is a string value. We'll talk about primitives and string class later in the course. For now, the important thing is whenever you want to create a string value, you put it in double quotes. Here 3 is a integer literal. We also looked at floating point literals, 3.0 by 2, where 3.0 is the floating point literal. And now we are introducing the string literal to you. So if you want to type something between double quotes, that becomes a string. So if you do anything with it, so if I do system.out.println 5 into 2 between double quotes, it will not calculate the value, it just prints 5 into 2. However, if I'm trying to do 5 into 2 like this, what it does? It calculates the value. In this step, we introduce the system.out.println method. Whatever value is passed to it, whether it's a string literal or whether it's an expression that needs to be calculated, it would be calculated and printed out to the console. That's what system.out.println does. I would recommend you to try playing around with system.out.println and print a few other values. I'll see you in the next step where we would talk about different exercises that you can try and do. Welcome back. In the previous step, we executed our first statement with a method call. We executed system.out.println and passed a numeric expression to it as well as a string literal to it as well. Now, let's try a few exercises to make sure that we understood it completely. The first exercise is I would want you to print hello world to the output, and we would want to use system.out.println. The next exercise, the second one, is to print 5 into 3 as it is. So I don't want to see 15 in the output. I would want to see 5 into 3 as it is in the output. The third one is to print the calculated value of 5 into 3. So I would want to see 15 printed in the output. Having done all these, now you can think about how to print the entire mathematical table of 5 now. In the previous step, we saw how to print something to the output. If you have to do the entire mathematical table of 5 right now, how would you do that? The next one is to print the number of seconds in a day using system.out.println. And the last exercise is to revise the syntax. So we executed 5 exercises. We would have executed 5 exercises by then. So make sure that you understand every bit of the syntax for all the 5 of them. You can solve these exercises and I would see you in the next step where you would try and solve them. The first exercise is to print hello world. How do I do that? It should be easy. Up arrow, I would want to print hello world as it is. So if I do system.out.println hello world, will it work? Nope. It gives you an error. If I say hello world, does it work? Nope, that doesn't work as well. The thing is, this is a string that we would want to print to the output. So I would need to create a string literal. So I'm creating a string literal and typing in hello world. And now you can see hello world printed out. That's cool, isn't it? Let's move on to the next exercise. The next exercise is to print 5 into 3 as is. So if I do something of this kind, let's say if I do system.out.println 5 into 3, what would be printed is the value. If I want to print 5 into 3 as is, I would need to print 5 space into space 3. That's exactly what is printed out to the output. That's cool, isn't it? So we have done this. This is done. Print calculated value of 5 into 3. Aha, I have done that earlier. So it's system.out.println 5 into 3, 15. That's cool. So let's tick this off as well. Now, how to print the mathematical table of 5 as nerf? Think about it. I think the best way based on whatever we have learned until now would be to say 5 into 1 is equal to 5. So I'm putting it as a string literal and now I can change all others. 5 into 2 is equal to 5. 5 into 3 is equal to 5. This is not very good. This is almost a dumb way of doing it, but based on the concepts that we have learned until now, this is the best possible way. We'll learn a lot of more efficient ways of doing this a little later. Now, let's check this off. Number of seconds in a day using system.out.println. Up arrow again. And what I would want to print is a calculated value. So if I put it in double quotes, what would happen? So I would want to find out number of seconds in a day. So let's start with our 24 hours, 60 minutes in an hour, followed by 60 seconds, right? So what would be printed? It would be printed as is. We should not use double quotes. We need to put directly the expression in system.out.println, and now I would be able to see 86,400. That's the number of seconds in a day. That's cool. And now let's look at the syntax again. So in the syntax, the most important thing to understand is this is how you refer to a method. Whatever you're passing in here is called a parameter. Here we are passing one parameter, which is an expression. This gets evaluated and passed to this method. Whatever we have in here are literals, which constitute the operands of the expression, and we have operators star in here as well. Over here, what we are sending in is a string literal. So we are sending a string value. So to the system.out.println, the string value is sent, and that is printed as it is. This is very similar to what we did when we sent hello world. So there is no difference except that here the string value is 24 into 60 into 60. Here it's hello world. Okay, that's all there is to syntax revision as well. So in this quick video, we looked at all the stuff related to system.out.println. I hope you are having fun with it. I'll see you in the next video. We would talk about a few more puzzles related to this. Welcome back. In this video, let's look at some of the puzzles related to system.out.println. So let's start with a basic one, right? So I'm printing hello world with two spaces, three spaces, four spaces. What would happen? It would print the hello world with those many spaces between. So earlier, when we talked about expressions, we said the spaces do not matter, right? So here I can give as many spaces as I can, and it does not really matter for the most part because it would print the value, the computed value of this expression. But inside a string literal, space does matter, because if I want to print hello world with a space, it's like this. If I don't want space in here, then it's hello world as a single word. So here it's two words, here it's one word. So space does matter inside string literal. So inside the string constant values, space does matter. The next thing is case of the method, right? So here we have system.out.println. So if I say system.out.println, what would happen? Think about it. I'm changing s to small. It says an error. It says package does not exist. We'll learn about packages a little later, but the most important thing for you is right now it's an error. So it's not just the system, but any of the things which is present in here. So O caps error. Even if you make P caps, it's an error. The only thing in here which you can change the case without breaking the whole thing is the case inside the string. So inside the string, whatever case you make use of, that's exactly what is printed out. In summary, all the Java class names, method names, all the things that are part of the syntax are case sensitive. So if you give a small case instead of a uppercase, or if you use a uppercase where lowercase has to be used, you'll get an error. However, inside the string literals, it does not really matter, right? It's exactly what you would want to see in the output. Now, let's say I would want to print double quote in the output. So I would want to print this in the output. What would happen? It says error. So if I want to print double quote in the output, how do I do that? The way you can do that is by using something called an escape character. So you need to put a slash before it. So if you put a slash before it, then the double quote would be printed as is. So if you have just the double quote, the thing is Java thinks the entire string has ended in here. It does not know what to do with this. So that's what it's complaining about, because string ends starts with a double quote and ends with a double quote. So as soon as it sees a double quote, it thinks the string has ended. It says, okay, the string hello is there, but what is this world thing there? So that's the reason why we have to escape the double quote. So we'll escape the double quote by putting a slash before it, and hello world. That's what is now being printed to the output. The next thing I would want to do is I would want to split hello and world into two lines. I would want to print hello on one line and world on another line. How do I do that? The way I can do that is by using a new line character, that is /n. So if I just type in n, hello n world. However, if I type in hello /n world, hello and followed by /n, that's a new line character followed by world. There's a space between the /n and the world, that's why you'd see a space in here as well. But if I actually remove that space, then it's hello world, one below the another. And if you don't really want a space after hello, then you can do this. It almost looks the same, but there's an additional space which is printed in here, which is not in here. These are escape characters. There is another escape character called /t, which is to print a tab. So there is a tab which is printed in here. And the last escape character is to print slash itself. So if I want to print slash itself, then I would need to do this. So what would be the output? Think about it. So if I do a hello / world, what would be the output? It's single slash. If I want to get two slashes, what should I do? Yep, I should do 4. So hello / world. So all these slash things are called escape characters. We looked at /n, which is a new line character, // which is to print a slash. We looked at /double quote, which prints a double quote out. And we looked at /t, which prints a tab like this. Try and play around with these escape characters. I'm so sure you'll have a lot of fun with them. The last thing we would want to look at is a couple of other inbuilt methods in Java. So we looked at one of these inbuilt methods, right? System.out.println. There are a lot of other inbuilt methods which are present in Java. Let's start with one of them which is used to do mathematical calculations, that is math.random. So math.random generates a random value, and the thing is math.random does not expect any parameter. So the name of the method is math.random and it does not expect any parameter. How do I execute it? Would this be good? Nope, that's not sufficient. So math.random, if you would want to execute it, the way you would want to execute it is you're missing the open brackets. If you want to execute a method or call a method, you need to use the brackets. So it's math.random followed by the brackets. So this would execute the method and return a value back. So this is a value between 0 and 1. This is kind of a random value. So every time you execute this method, you will get a different value. But the most important thing as far as you are concerned is the syntax to call a method. So the syntax is very simple. Math.random followed by open bracket, close bracket. That's it. So this math.random does not accept any parameters. In the previous examples that we saw until now, we were using hello world as the parameter, right? So this is the parameter. We pass a string literal as a parameter to system.println. The other thing that you can do is you can pass multiple parameters. So let's say there's a method called math.min and I would want to find out the minimum between 23 and 45. How do I do that? Will this work? Nope. Let's try this. 23 for space 45. Will this work? Nope, this doesn't work. The way you can pass multiple parameters is to separate them by a comma. So math.min 23 comma 45. So now it says the minimum of 23 and 45 is 23. So similar to that, if let's say this is 23 comma 4, it would say the minimum is 4. The last thing which we would want to look at is the math.max method. This would print the maximum, so it says 23. So I hope you had a lot of fun doing the different puzzles which are present in this exercise. I'll see you in the next video. Until then, bye bye. Welcome back. In this video, let's look at an interesting feature in JShell. The ability to allow you to type multiple lines of code. Let's say int I is equal to 5, right? So I can type it in one line, or if I say int j is equal to, so this is an incomplete statement. When I press enter,
JShell asks, you have not really completely entered everything, just try and enter the remaining part. And then it would take that specific thing. So the same thing works even with, let's say, system dot, let's say, out dot println. And after that, what it's trying to do is it's trying to print a variable called println. In these kind of situations, you need to actually try and say system.out.println. Nope, I'm not searching for a variable, I'm searching for a method. And then JShell would go ahead and say, okay, give me what you would want to print. I'll say test and press enter, and then it says, okay, you have not really entered the closing parenthesis yet, go ahead and enter. And then it would execute that specific statement in. The other interesting thing is in JShell, you can actually have multiple statements on the same line. So I can say I is equal to 10 and j is equal to 12 separated by semicolons. JShell does exactly this even when you type in a if statement. So if, let's say, true, and let's say I did not enter anything, it would say, okay, enter what you want to do. If I press a block, open brace, then it says, okay, tell me what to do. I is equal to 11. As long as you keep entering stuff without entering a closing brace, it would say, okay, keep entering more stuff, keep entering more stuff. And when I press the close brace is when it starts executing. And then you would see that I has the value of 12. I hope you are having an interesting time in the course and you are excited to learn more. I'll see you in the next video. Until then, bye-bye. Welcome back. In the previous video, we looked at how to print something out to the console, right? So if I wanted to print 5 into 2 is equal to 5, oops, that's not right. If I want to print 5 into 2 is equal to 10, this is how we would want to print it. The important thing about this is here, the value of 10 is not being calculated. I am actually hard coding the value of 10 in here. I would want to be able to calculate the value of 5 into 2 like it in here. So I would want to be able to do 5 into 2 is 10, and I would want to say 5 into 2 in here, and I would want the computer to calculate the value for us. How do we do that? That's basically what we would want to focus on in this specific video. One of the important things is system.out.println only supports printing out text to the output. It does not allow replacing values. And to be able to replace values, we would look at a new method. The new method we would be looking at is, instead of println, it's printf. You can see that printf is doing a lot of stuff. It's actually printing out 5 into 2 is equal to 10, and it also returns something called a print stream. You don't really need to worry about the print stream right now. The important thing for you to note is the fact that even though it's printed, this print stream is getting printed as well, and that's not cool. What we can do is to call another method on this. So I'm saying system.out.printf 5 into 2 is equal to 10 dot println. So now when I press enter, this would actually be the same output as earlier. So 5 into 2 is equal to 10, 5 into 2 into is equal to 10. So what we are doing in here is doing exactly the same thing as println. So now we are able to use printf and do exactly the same thing as println. But the fun thing about printf is that you can print calculated values with it as well. So system.out.printf, you're passing a string literal right now. It's not really a calculated value. This is just a literal for now. There are no calculated values in it. And we are calling a dot println method on it. So what we are doing in here is on the result from this method. So whatever result this method is returning, whatever result the printf is returning, which is a print stream, we are calling another method on it. The method which we are calling is println. The println makes sure that there is a new line character which is printed after it. So that's why you are seeing the new line character here. If you see it in here, there is no new line. So 5 into 10, 2 is equal to 10 is printed, and $45 is printed right after that. Now we would want to print a calculated value using system.out.printf. How do we do that? In system.out.printf, you can
use a modifier. So the modifier is percentage followed by a character. For integer values, the modifier is d. So we want to do 5 into 2 is equal to 10, percentage d, comma, the value you would want to print. So let's say I would want to print 5 into 2. So what we are doing is we are now sending in two parameters. One is a string literal, 5 into 2 is equal to 10 percentage d followed by 5 into 2. What would happen? It's printing 10 twice because one is the 10 that we are passing, the other one is the calculated value. What I'll do now is I'll remove the 10 that we printed in. So 5 into 2 is equal to percentage d and 5 into 2. So 5 into 2 is equal to 10. So now what we are able to do is we are able to calculate the value for 5 into 2 and print it in here. So 5 into 2 is equal to 10 is being printed with a calculated value. This is the reason why we are using printf instead of println. Println does not support formatting of this kind. Let's look at another example of system.out.printf. So over here, what I would want to do is I would want to print three different values: percentage d, and you can pass in three parameters now. So 5, 7, and 5 into 7. So let's see what is printed now. 5, 7, 35. So instead of this 5 is printed, instead of this 7 is printed, and the calculated value is printed instead of percentage d in here. So that's cool, right? 5, 7, 35. I can actually now modify this to say 5 into 7 is equal to percentage d. 5 into 7 is equal to 35, and all the things are picked up from here. So none of the values are hard coded in the string literal. We are actually replacing it by passing them as parameters. This is one of the first times we are passing in 4 parameters. So here we are passing in 4 different parameters to printf, and it's able to use them to generate the string that needs to be printed out, which is 5 into 7 is equal to 35. That's cool, right? In this step, what we have learned is how to print calculated values to the console. In the previous exercises, we were actually directly printing something of this kind. 5 into 2 is equal to 10. Now, we are actually doing the calculation and printing the calculated values out. The exercise I would want to leave you with is to generate 5 plus 6 plus 7 is equal to the value of 5 plus 6, 7, 18. However, I would want you to use system.out.printf, and inside the string literal, I would want to use the expression using percentage d's. You are not allowed to use direct values in there. So you need to do something of this kind to print this 5 plus 6 plus 7 is equal to 18. I think you need to pass in 5 parameters. I'm sure you'll be able to work that out and print this similar to this. I'll see you in the next video. Until then, bye bye. Welcome back. In the previous video, we looked at how to use system.out.printf to print a calculated value to the console. So we calculated 5 into 7 and put it into the output by passing it as part of the string literal in here. The exercise we left you with was to calculate the value for 5 plus 6 plus 7, which is 18, and print it using system.out.printf. So how do we do that? Let's see that right now. So we want to print 5 plus 6 plus 7. So 5, 6, 7. The expression which we want to use is 5 plus 6 plus 7. And over here, it's into star d. Actually, it should not be into, it should be plus. So let's change that quickly. So this is what we were looking for. So percentage d, percentage d, percentage d, percentage d. So there are 4 arguments which are passed in to replace those things in here. That's cool, right? 5 plus 6 plus 7 is equal to 18. It was a very simple exercise to do. I hope you had fun doing that exercise, and let's now get into the puzzles directly for this specific topic. So system.out.printf,
let's say I'm not passing in sufficient number of parameters. What would it do? You can see that it throws an exception. So it's saying there is a format specifier %d, but you are not passing in sufficient number of arguments. If you remove the percentage is equal to %d, it would succeed because then the number of arguments matches. If I remove 7, it would again complain because there are 3 format arguments in here, 1, 2, 3, but number of parameters that we are passing in having values is only 2. That is the reason why it starts failing. However, let's do the reverse. So if I say %d plus %d plus %d and I pass in 5, 6, 7, 8, you can see that it ignores the last parameter. So here there are 3 modifiers. However, I'm passing 4 values. What it does is it takes the first 3 and uses them. So that's an interesting tidbit about system.out.printf and how it works. The other thing is you can use system.printf to print strings as well. And how do you do that? The way you do that is by saying %s. So system.out.printf %s, and I can pass in a string literal testing print %s comma testing. So now this %s is a string. So I'm saying print testing as a string. %d is for integers, %s is for string. The other kind of values you can print are floating points. So let's try a simple example. So 5, let's say I'm printing 5.5, 6.5, 7.5. What would happen? It says it's an illegal format conversion exception. It says I'm trying to pass in a floating point value and you are trying to print it using %d. Don't do that. The way you need to do that is by passing in %f. Now you can see that all the values are printed in here. In this and the previous step, we looked at system.out.printf and how you can print a calculated value using it. In the next step, we would start using that and apply it to our multiplication table problem. I'll see you in the next step. Welcome back. Before the previous step, this is how we printed the multiplication table. And in the previous step, we learned how to use expressions to calculate values and put the values into the output that is being printed. So instead of println, we started using printf function. And now we print the same thing, however, using calculated values. In this video, we'll introduce variables to you and we'll try and figure out how variables would help make our problem easier to solve. Now, let's get back to the big picture. We would want to print the 5 table. So we would want to print the 5 multiplication table. So right now, if you are given a chance, how do we do that? So 5 ones are 1, 5 twos are 2, 5 threes are 5 twos are 10 and 5 threes are 15. So all that we are doing is changing this value. So 1 over here, it's 2 over here, it's 3 over here, it's 4 over here. The value is changing from one statement to another. Is there any concept in programming that can represent a changing value? That's where variables come in. Let's look at a very simple example of a variable. I'm saying int number is equal to 10. So I'm saying int number is equal to 10. Now number has a value 10. We'll discuss about the syntax, we'll discuss what is int, and we'll discuss the specific format in which we have written this. And now I can say number is equal to 11. The value of number now changes to 11. So if I print number now, it says number has a value 11. I can say number is equal to 12. And now number has a value of 12. So I can try and print number, it prints a value of 12. You can see that this thing called number at different points has different values. The value of number is changing. So here this is a constant. So 4 is a constant, 3 is a constant. It's a literal. The number here has a value of 10 and we are changing it to 11 here and we are changing it to 12 here. This is what is called a variable. A variable is something whose value can change over the lifetime of the program. So in the program at different stages, these variables have different values. Let's quickly look at the syntax. The syntax to declare a variable is very simple. So the type of the variable followed by the name of the variable. So type followed by name is equal to your value, the initial value that you would want to assign. That's the syntax. The type which we are using in here is int. Int stands for integer. Integer can hold a huge range of integer numbers. So it can store integer numbers. So 1, 2, 3, 4 or 15, 20, minus 15, minus 20 and things like that. The name which we are giving to the variable is number. So number is the name that we are giving to a variable. Once we give the variable a name, we can use that name to refer to the variable at multiple places. So here it's number is equal to 11. Here we are saying number is equal to 12. So it's simple. It's type. First is the type. Then is name of the variable. So I'll say number 2 is equal to 25. So the second number is 25. And now I can change the value of number 2. So number 2 is equal to 100. This statement is called a declaration. The declaration of the variable declares what type it is and what is the name of the variable. So the declaration says the type of this variable is int and the name is number 2, and it also includes here the initial value. So this is called declaration, and this statement in here number 2 is equal to 100. This is called assignment. You should not confuse this with a is equal to operations which are done in mathematics. It's not number 2 is equal to 100 doesn't mean both are equal. It means that the value 100 is copied into number 2. We'll discuss about assignment operator in detail a little later, but for now you can kind of think that the 100 is copied into number 2. So number 2 holds a value of 100. Now we have a variable. How does it help with our problem? Earlier we were using this to print our multiplication table. Now what I would do is I would create a variable called int I is equal to 1. What I would now need to do is to change this statement to use I instead of 4. So over here wherever there is 4 I'll replace it with I. So instead of 4 I'm using I. You can see what would happen now. What is happening? It's printing 5 into 1 is equal to 5 into 1, which is 5, because I has a value of 1. So what is the value in I? I has a value of 1 and it is being used to print it. You can see that the I can be now used in expression. So 5 into I is 5 because I has a value of 1. 5 into I is 5. Now what I can do now is I can say I is equal to 2, and now the same statement that we executed earlier, this is the exact same statement as we have executed in here, and this statement now would say 5 into 2 is equal to 10. And if I say I is equal to 3 and execute the same statement again, it would say 5 into 3 is equal to 15. You can see the magic unfolding right now, right? So based on the value of I, this statement prints different values because I is a variable. So now I'm changing the value of I, and this statement can now print different multiples of 5. So let's take I is equal to 10. What would happen? This would now print 5 into 10 is equal to 50. Congratulations! You have defined your first variables and also you have used variables in the system.out.printf statement to print the 5 multiple. Now, this makes the whole problem much more simpler is because now if I am able to execute this statement for different values of I. So if I can execute this statement for I is equal to 1, I is equal to 2, to I is equal to 10, then I am done. Before we go there, let's have an exercise. The exercise which we would recommend you to do is to create 3 integer variables. So create 3 integer variables A, B and C. So to create 3 integer variables and create a statement, you can use system.out.printf to print the sum of these 3 variables. So you'd want to print the sum of these 3 variables, that's A plus B plus C. And after that, modify value of A and print the value of A plus B plus C. Modify value of B and print the value of A plus B plus C. I'll see you in the next video where we would do this exercise as well as talk about a lot of different puzzles related to variables. Until then, bye-bye. Welcome back. In this video, let's discuss a few exercises and puzzles related to variables. Let's start with the exercise that we talked about. We would want to create 3 variables int A, B and C. So how do I create 3 variables? Int A, and let's assign a few values as well. Int A is equal to 10, int B is equal to 20, int C is equal to 30. And what we would want to do is we would want to create a statement for printing the sum of these 3 variables. So how can I do that? So I can say system dot out dot printf. I can say A plus B plus C is equal to A plus B plus C, right? No, because it would just print as it is. So if I do this dot println, as we discussed earlier, this would just print A plus B plus C. What we would want to print is the values. So I would need to say A, B, C and A plus B plus C and replace all these with percentage D, percentage D, percentage D and percentage D here as well. You can see that now I'm printing the values of ABC and A plus B plus C. So 10 plus 20 plus 30 is equal to 60. That's cool, right? So now let's change the value of A. How do I change the value of A? Think about it. How do I change the value of A? I can type in A is equal to 50. And now if I print the same statement again, 50 plus 20 plus 30. Next, I would change the value of B, 60. Same statement again, 50 plus 60 plus 30 is equal to 140. You can try changing the value of C and printing the value of A plus B plus C, and you would see that the value of the variable would be changed and the statement would be updated reflecting that specific thing. That's cool, right? So that's why we use variables. Variables have different values. Those programs are executed based on the current value of that specific variable. Now, let's get to a few puzzles related to variables. Let's say I have a variable which I have not really declared yet. So typically the way we declare a variable is int I is equal to 10. So I'm assigning a value of 10, right? So let's say I would want to create a new variable. So I'm saying int new variable and I would press enter. You can see that the new variable is automatically created with a value of 0. This is something which is JShell specific. When we really get into our IDE and try and run the programs there, you would see that when we create a variable, it's not really initialized. But in JShell, the value is being initialized to 0. So if I try and print new variable, it gets a value of 0. Let's now try and use an undeclared variable. So let's say I'm not really declared a variable and I'm trying to use it. It says variable undeclared variable cannot find symbol. So if you have not defined the variable,
then it will not be available at all. So if you want to use the int undeclared variable, then you would actually first declare it. So the way we would declare it is int undeclared variable. It's now initialized to a value of 0. Now I can go ahead and print undeclared variable or use undeclared variable in expressions. Now I can do that, right? So 5 into undeclared variable is 5 into 0 is 0. If you don't initialize the variable in JShell, a value of 0 is being assigned. And if you don't declare a variable, you cannot use it. You can use a variable only after you declare it. And now I would try and store int number is equal to 5.5. So 5.5 is a floating point value. It's having a decimal. Can I store it into number? Think about it. It's error. It says incompatible types. Possible lossy conversion from double to int. Double is one of the floating point formats. We'll talk about it a little later. But for now, what it's saying is you cannot take a floating point value and put it into a integer value. So Java is strongly typed language. By that, it means that you have to define a type for all variables. So all variables need to say, I am an integer, I am a string, I am a floating point value. And you can only store that kind of values in there. I cannot say number is an int and try and store a string value in it. So if I try and do this, it says, nope, you cannot store a string into an integer. This is because Java is a strongly typed language. However, if you have a previously declared value, let's say int number is equal to 5, I can use number to create another variable. So I can say number 2 is equal to number. What would happen? The value of number gets copied into number 2, and number 2 has a value of 5. In this step, we looked at the basic exercises and puzzles related to variables. Especially during the puzzles, we understood that Java is a strongly typed language. You have to declare a variable before using it. You have to tell what type it is before you would use it. And you cannot store values of other type in the variable. You can only store the values of the type it is declared. So number is an int, so it can only store integer values. Until the next video, bye-bye. To be a great programmer, you need to understand variables very well. And that's the reason why we are creating 4 videos to give different perspectives around variables. We will start off looking at how variables are stored in memory. We would look at the different practices, good practices in naming a variable, as well as the rules. What can a variable name be? What should a variable name not be? And all that kind of stuff. We'll also look at the different variable types, the primitive variable types which are present in Java. And after that, we would look at a few important assignment related operators. So this sequence of 4 videos would help you to understand variables in depth. In the next video, we would start with how variables are stored in memory. Until the next video, bye-bye. Welcome back. In the previous step, we looked at variables and a few exercises and puzzles related to them. In this step, we will try to understand variables and how they are stored in memory. One of the important things is once you are able to visualize how variables are stored in memory, it makes it very easy for you to understand them. The thing which we discussed until now is a variable is something whose value can change over a period of time. So let's say I'm declaring a variable int a is equal to 5 and int b is equal to 10. So how do they get stored in memory? Let's see that right now. So a is equal to 5, b is equal to 10. Let's open up a spreadsheet and see how it would be stored. So let's say a gets stored in the memory location 5008 and b gets stored in here, right? So your computer memory is just like a set of boxes, right? So you have a number of memory locations based on the size of your computer memory. We have simplified it just to have a set of 10 cells, and let's say all the variables are being stored in your computer main memory. As soon as you define int a is equal to 5, what would happen is a name is a and value is 5. Any variable has a name, it has a value, and it also has a specific location in memory where it is stored. When we say int b is equal to 10, now a new value is created 10 and we have a name of b for it. So the name is what we use in our program to refer to this memory location. So we are using a name a to refer to the location 5008. We are using a name b to refer to the memory location 5012. So when we say a is equal to 100, what would happen? A is equal to 100. So 100 value gets copied into the memory location referenced by A. So A is referring to a memory location. Which one? This one. So the value of 100 gets copied into this. Now let's say I go here and I say int C is equal to A plus B. So what I'm saying is C is equal to A plus B. So A plus B gets calculated. A plus B is 100 plus 10, 110, and the value gets stored into C. So a new variable would be created somewhere on memory, 110, and the value is C. Now I can do something like A is equal to C. What would happen? The value of C gets copied into A. So A has a value of 110 now. So A, the value of C is 110. This gets copied into value of A. So this is how all the things happen in memory when we do programming. So as soon as we create variables, as soon as we modify the values of the variables, what is actually getting changed is the values in the memory. These are just the names that we give to reference to a specific memory location. I thought it would be great for you to understand what's happening in the background so that you can try and visualize what is happening, and this would make understanding the rest of the things that we would discuss much more easier. In this video, we took a background look at how variables are stored in memory. The way you can think about a variable is just like a box which has a name, which has a value, and which has a specific memory location. The other thing that variable also has is a type. In Java, you would need to declare the type of the variable. You cannot change the type of a variable during the execution of the program, and also you cannot store values of other types into this variable. So if this a is an integer variable, you can only store integer numbers. You cannot store floating point numbers, or you cannot store strings into it. Until the next video, bye bye. Welcome back. When you're programming, you'd create a number of variables, and there are a lot of rules around how to name a variable. There are rules which you should strictly follow, and there are recommendations. So the first four rules that you are seeing in here are things which you need to follow strictly. The camel case is kind of a best practice that is followed in Java. So what are the rules related to naming a variable? Thing is, whenever you name a variable, it can only have a combination of letters, numbers. So you can have all the alphabets, you can have numbers from 0 to 9, and you can have a dollar and an underscore sign. So these are the valid characters that you can use to name a variable. So if I say int test minus test, that's not a legal variable because hyphen usually stands for minus. So you cannot use hyphen in a variable name. The only legal characters are letters, numbers, dollar, and underscore. A variable name cannot start with a number. So if I say int to test, it says error. So you cannot have a variable name starting with a number. And the other thing is a variable name cannot be a keyword. If you look at int is one of the keywords because that represents a integer data type. So you cannot call a value as int. You would get an error. So int is not a valid variable name. There are a lot of other keywords, Java keywords, that we would be talking about a little later. You cannot use these keywords as variable names. There is no limit on the length of the identifier. That's basically the name of the variable. Typically in Java, we use the convention of using a camel case. So if I'm saying number of goals, so this is how we would do it. So each word number of goals. Every word starts with a capital letter except for the first one. So the first one we would start always with a lower case. So here number n starts with a lowercase, and after that all the other words start with uppercase. In Java, all the variable names follow this convention. You can actually create variables with a capital letter starting. However, that's not considered to be a good practice. Java compiler will not complain about it, but it's not really considered to be a good practice. In Java, all variable names would start with a small letter. That's the convention which is followed by almost every Java developer. The last but the most important thing about naming variables is it should represent what kind of values it contains. If you are using a variable to track the score, it's better to create it as int score rather than saying int s, because s is not really clear. You don't S can stand for anything, but when I say int score, then I know exactly what the variable is trying to represent. When you are starting off, try and create variables which have good names. Creating variables with good names is one of the important parts of developing great programs. It makes it easy for you as well as people who maintain the code afterwards. So try and give your variables a good name and have that habit over the programming career. In this video, we looked at all the rules related to naming a variable. Until the next video, bye bye. Welcome back. In this video, we would look at the different types of variables which are present in Java. We would start with looking at primitive data types. Until now, we had been using int. So int stands for integer. It is used to store integer numbers. Actually, for storing integer number types, there are 4 different data types in Java. They are byte, short. We have already looked at int, so int and long. Byte, short, int and long. These are the 4 different integer data types that are supported by Java. Byte is 8 bits, that's basically 1 byte, and this is 16 bits, this is 32 bits, and this is 64 bits. So a byte is basically 8 bits, short is 16, int is 32, and long is 64 bits. While choosing the variable type, it's very important to consider the range of the variable into the equation. Right? So if I'm trying to write a program where I'm going to store the number of goals scored in a football match, then most probably 99.999% of the scenario, bytes might be sufficient. But if you really want to be safe, then you would go for a short, because byte can hold only up to 127. With short, you get a much bigger range. So you get a range from 32,768 negative to 32,767 positive, because short uses a little bit more memory. Byte uses only 1 byte, short uses 2 bytes, and int uses 4 bytes. So if you look at the range of integer, it's about minus 2 billion to 2 billion. So if you would want to actually measure, let's say, the GDP of an economy, which might be in trillions, then int might not be the right data type to use. In that case, you might want to use a long. So one of the important things is when you are choosing the type of the variable,
you need to consider what is the range of that specific variable. The next types of variables are floating point numbers, basically your numbers which have decimal values. So for example, float f is equal to 4.0f. So now this has a value of 4.0. You can have a value of 4.5 as well. Float f2 is equal to 4.5. The other floating point variable type is double. So you can say double is equal to 4.5. You can see that I'm using an f when I'm using a floating point value, and I'm not using an f when I'm using a double value, because a literal floating point literal by default. So 4.5 is a constant value, right? So that's a literal. So a floating point constant value is by default a double. That's the reason why when I'm assigning a value, if I try and assign a float f3 is equal to, let's say, 4.5, this would fail because 4.5 is a double value. You cannot take a double value and put it into a float. Why? Because float is 32 bits, whereas double 64 bits. You cannot take a bigger value and put it into a smaller variable. So if the value is big and the variable is small, then Java would throw a compilation error. So float f3 is equal to 4.5 would cause a problem. One interesting thing to note about float and double is both of them are not really accurate. So if you are going to do financial calculations, then probably you should not use them and you would need to go for something called big decimal, which we will talk about a little later. The other two data types which are present in Java are char and boolean. So what we looked at until now are integer data types, floating point data types. This is character data type. So basically, sometimes in programs you would want to store characters. So char, let's say I want to store a character a in ch. This is not the way you need to do that. The way you need to do that is to use single quotes. So char ch is equal to a in single quotes. By character we mean only one letter. So if you try and do AB, that will not be working. So a character can be stored into a char variable type. The last type of variable is boolean. So boolean can store true or false variable. So if I want to find out if a number is prime, so is prime is equal to true, or I can say boolean is prime is equal to false. So boolean is a value which can contain either true or false. So this boolean data type variables can only have two values, true and false. True is called a boolean literal, false is called a boolean literal as well. So if I try to change the case of it, that would be an error. So it's actually false with a small f, and it's case sensitive. So everything in false is small, and same is the case with true. So you cannot say capital T, it should be always small t. This is how you would actually define a boolean literal. So in this video, what we wanted to try to do was to get a quick overview of the different variable types. We looked at the four integer data types, we looked at the two floating point data types, we looked at the character data type and the boolean data type. We would look at the floating point data types, the character data types and the boolean data types in depth a little later in this course. For now, it is very important that you understand them and have a high level big picture of them. When we are talking about them in detail, we would give you a in-depth picture of it. Until the next video, bye-bye. Welcome back. In the previous video, we talked about different variable types, their size in memory, and also the range of values they can store. This kind of information can get a little boring because there are a lot of numbers and some of them are really huge. So you can see here, oh, I don't even know how to call this number. So this is 2 billion. What is this?
Okay, go figure out. I'm not going to try that. One of the interesting aspect about the variable types is whenever you are creating a variable, you need to choose an appropriate variable type to store it. So for example, let's say I would want to store number of goals. So I would want to store the number of goals in a football match. What should I use? Should I use a byte or a short or a int or a long? The first thing is it's a number, right? It can only be 1, 2, 3, 4. So I would need to use an integer data type, right? So I don't need to go for a floating point data type. So that's the first choice. So I should use one among these. And the best choice among them might be either byte or short. Unless world's number one team playing a team maybe formed by people like me, I don't think there will be more than 127 goals in a football match. So byte should be sufficient, but if you want to be really safe, you can declare it as a short. So if you would want to store the number of goals in a football match, you can say short number of goals. That should be good enough variable to store the number of goals, and you can store the goals as they are scored. So if there's a new goal which is scored, all that you need to do is say number of goals plus plus, and if I now print the number of goals, it's 1. So that's cool. Number of goals now becomes 2. You can actually try and create two variables for each of the teams. So you can actually create short number of goals for team 1, number of goals for team 2, or you can give team 1 goals, team 2 goals, a shorter name. Let's say you would want to store the population of the world in a variable. What would you choose? First thing is it's a integer number. So you would choose one among these four. The population of the world, do you want to go Google and find out how much it is? It's around 6 billion to 7 billion. Would integer be sufficient? Nope, because it's 2 billion. So for storing population of the world, I would need to go for at least a long variable. So I would need to say long population of the world. Let's say I am trying to calculate the average of a few numbers. The average of the few numbers might have decimal points. Choosing between float and double would depend on the precision you would need. How accurately do you need to calculate it? We will talk about it a lot when we talk about financial calculations a little later. But one of the most important things is double and float, both of them are not really precise. If you want really precise calculations, for example, for financial calculations and things like that, you have to go for something called big decimal. But among float and double, double is more precise than float. So typically, I would prefer to go with double for all floating point operations. So if I want to do any decimal kind of operations, I would use double. So I'll say double average. Let's say I would want to store the grades of students, and the grades of the students are A, B, C, D. What would I choose? In that kind of situation, I would go for a char. So I can say char ch is equal to A. Is this the way? No, you need to put it within single quotes. So char ch is equal to A. If you want to change it, ch is equal to B. And because we want to actually store the grades in there, I would want to name it more appropriately. You can say char grade is equal to C. Aha, I don't want to give him a C grade. Let's change the grade to A. A. So grade is equal to A. Now, the next variable what I would want to store is whether a number is even or not. What data type should I use? What are the possible values? Is number even? The values are possible are only two values, right? Either it's true or false. These kind of values are called Boolean values. So we would use Boolean. So the way we would name it is even. By default, it has a value of false. If you would want to change the value to true, then you can say is even is equal to true. That's it. One example we already talked about was is prime. Is a number prime? Is it raining today? Are you enjoying the course? Yes or no answer. So in all these kind of situations, you would actually use a boolean. I hope it's not false. I would rather have the value assigned to true. Cool. In this short video, what we wanted to do was to discuss the different situations and what kind of variables you would choose to represent the variables in those kind of situations. Until the next video, bye bye. Welcome back. In this video, we would want to introduce you to how strings and string concatenation works in depth. As we discussed earlier, anything within a double quotes is considered to be a string, right? So this is creating a string variable. If you do $8, it would print test. When I do 1 plus 2, what would be the output? It's 3, right? But when I put 1 in a string and do a plus 2, the output is not 3. The output is a string 12. The fact that it's a string is highlighted by double quotes around the value that is being printed. So when I concatenate 1 to 2, the output is 1, 2. So the plus actually plays double role. When you are putting plus around integers, numbers, then it's doing addition. When you put a plus and one of the which is involved is a string, it does concatenation. So if I do 1 plus 2 plus 3, what do you think will happen? It would do addition, 6. However, if I do 1 plus 2 plus 3, what would be the output? 1, 2, 3. Operations are always executed from left to right. So 1 plus 2 plus 3. If you want to do 2 plus 3 as addition, then you can do this. So what happens is first 2 plus 3 is getting executed, 5, and 1 plus 5 is appended together. Not just with numbers, plus also can be used with strings containing alphabet. So you can say plus ABC plus DEF. It concatenates both of them together. You can also concatenate multiple strings as well. Cool, right? You can also use the concatenation operator in system.out.println. So you can say system.out.println ABC plus DEF plus FHI. Or if you have an int I with a value of 5, then you can use system.out.println to print the value of 5. You can say value of plus I. What does it print? Well, let's put a space in here. It says value of 5. You can say value of I is and plus I, and you can say value of I is 5. In this quick short tip, what we wanted to show you is the string concatenation operator, how it works, and how you can use it in system.out.println to print the values of a few variables quickly. You should always be careful that you are not doing a lot of string concatenation, as we will learn a little later that string concatenation is a very costly operation. Don't worry about it for now. You'll learn about it when we talk about strings in depth. Until the next tip, bye-bye. Welcome back. We are discussing a wide range of topics related to variables, and in this video we would talk about assignment. Assignment is one of the operations that is little confusing when you are starting off with programming, but once you gain a little bit of understanding of it, it becomes very easy thing to understand. Let's create a couple of variables. Int I, I'll have a value of 10, and int j, I'll have a value of 15. And I would want to do I is equal to j. The important thing to understand with assignment is the fact that this is different from mathematics. When I say I is equal to j, it does not mean both of them are equal. When I say I is equal to j, I am telling the programming language to copy the value of j into I. So for primitive values, the value of j is copied into the memory location which is referred by I. So the value of j is copied into I, and you'd see now that the I has a value of 15 and j also has a value of 15. The previous value which was in I is lost. You will not be able to retrieve it again. This is assignment. Assignment is used to copy the value of one variable into another. In an assignment, the value on the left hand side should always be a variable. You cannot say 10 is equal to I. Nope, that would not work, because on the left hand side you should always have a variable. It cannot be a value. On the right hand side you can either have a variable or a value. This is because a variable would have a value as well, right? So when I say I is equal to j, j has a value and that value would be copied into the variable I. So now I has a value of 15. So that's one very important thing for you to understand about assignment. Assignment involves copying the value of the expression on the right hand side to the variable on the left hand side. On the left hand side it should always be a variable. And assignment can be done with expressions as well. So I is equal to j into 2. What would happen? J into 2. J is 15. 15 into 2, 30. So I gets a value of 30. You can also do things like I is equal to I into 2. So what would happen? The value of I is 30. 30 into 2, 60. And the value would be copied into I. So the value of I is 60. So the new value of I is 60. You can say I is equal to I plus I. So what would the value of I become? 120. Value of I plus value of I. 60 plus 60, which is 120. You can say I is equal to I minus I. I minus I. What would be the value? 0. So I is equal to I minus I. So the expression is evaluated and the value is copied into the variable on the left hand side. One of the most popular operations which we do in programming is I is equal to I plus 1. So we are trying to increment the value of I by 1. So I has a value of 0. I'm doing I is equal to I plus 1. What would happen? I will have a value of 1, because I, before executing the statement, I had a value of 0. 0 plus 1, 1. 1 is evaluated and the value is copied into the memory location which is referred to by I. This is how you can increment variables. And the way you can decrement is I is equal to I minus 1, I is equal to I minus 1, I minus 1. So this is how you would decrement the variables. This is called decrementing and the previous one is called incrementing. The idea behind the video was to introduce you to the different things around the assignment operator. In the next video, we will look at a few puzzles related to the assignment operator. Until then, bye-bye. In the previous video, we looked at the basics of assignment operator. In this video, we will take it to the next level and see a few puzzles around it. So let's say I have an int number and I have a value of 5. We saw that if I do a number is equal to number plus 1, what would be the value of number after that? It would have a value of 6. It gets incremented. 5 plus 1 is copied into this. So number has a value of 6. There is a shortcut way to do this as well. So it's called number plus plus. So it increments the value of number. Number has a value of 7. If I do number plus plus again, number has a value of 8. There is another operator to decrement as well. It's number minus minus. This would decrease the value. So if you look at the value of number, it's 7. Let's create the variable again. So number is equal to 5 and we looked at number plus plus. Similar to number plus plus to increment, there is a plus plus number as well. So plus plus number and number plus plus, both of them would increment the variable. There is a minor difference between them which we'll discuss later. But for now, you can almost kind of think of them as number is equal to number plus 1. So number plus plus and plus plus number are both used to increment numbers, and minus minus number or number minus minus are both used to decrement a number. There are other operators called compound assignment operators. The compound assignment operators help you to simplify your code. So if I am doing I is equal to I plus 2, let's say, instead of that, I can say I plus is equal to 2. If I am using the same variable on both sides, then I can do I plus is equal to 2, or I minus is equal to 1, or I star is equal to 5. 4 into 5, 20. If you print the value of I, it's 20. Or you can say I divided by 4. I is equal to I divided by 4. I is equal to I mod 2. Modulus, as we discussed before, 5 mod 2, the remainder when 5 is divided by 2, which is 1. So I becomes 1. So these are all the compound assignment operators. In the last few videos, we tried to understand variables in depth. We tried to understand how variables are stored in memory, what are the different types of variables you can declare, and also we looked at the basic assignment operator as well as the compound assignment operators along with the shortcut increment operators plus plus and minus minus. In the next step, let's continue attacking the challenge at hand. We would want to print the 5 multiplication table, and in the next step we would take a few more steps towards the solution. Until then, bye bye. Welcome back. At In 28 Minutes, we teach a wide variety of courses, web services, RESTful APIs, microservices, and a lot of Java frameworks like Spring and Spring Boot. One of the frequently asked questions is, why don't you really have a Java course? I mean, this was before 2018. Why didn't I have a Java course before 2018? And the answer to that is what you see in the screen right now, JShell. Before JShell, if you had to write a Java program, I mean, let's imagine you are writing your first Java program, right? So you'd want to actually try and play with it and try and have fun. But what you need to typically do when you're writing your first Java program before JShell is you need to create a class, you need to create a method, then write the code in there. But with JShell, all that you need to do is type in the command. So let's say I would want to execute system.out.println, and all that I need to do is type this in and press enter. That's it. You are now able to understand how the system.out.println works. That's immediate feedback, and that's one of the reasons why I love JShell. One of the most important things with anything we do is we would like to have immediate feedback. So if I'm executing a wrong statement, then I would want to know it immediately, and especially at the beginning stages of programming where you make a lot of mistakes, it's better to get the feedback even faster. I love JShell and I hope you are also having a good experience with it. In this video, we will discuss a few tips to make JShell even more awesome. One of the important tips is that JShell supports history. You can use the up arrow and the down arrow to navigate through all the commands that you have executed previously. So you can use the up arrow, down arrow and look through all the commands that you have executed previously. The other useful shortcut is Control A. It takes you to the start of the line. So hold the Control key and press the A alphabet. So Control A takes you to the start of the line and Control E takes you to the end of the line. So if I have to change something at the start of the line, then I would press Control A, go ahead and make the modification. Let's say I want to delete all the spaces here. So I can do that and press enter. If you want to search through all the commands that you have executed already, you can try using Control R. So just press Control R and type in what you want to search. So system, let's say system. And then you'd see all the first matching result. If you'd want to see other results, you can actually try and do a Control R again. So Control R, it takes you through all the system things that you have executed, and let's say now I would want to execute this. I have found the right one. I just need to press enter. It executes that. So it's very simple. Just type in Control R, Control followed by R, and then type in what you want to search. So system, and you can loop through all the system commands by, oops, I made a mistake. Control R, you type in what you want to search, system for example, and then you can actually press Control R again. Control R, you can loop through every statement having system that you executed earlier, and you would be able to find the one which you would want to execute. So if I want to press number 2 now, so I just press enter, it would take that. Now that we looked at a couple of important shortcuts related to JShell, we are ready to look at a few other tips. The thing is, JShell, if you don't type in a complete statement, so I is equal to is not a complete statement, right? So if you don't type in a complete statement, it would ask a multi-line. So it would go to the next line and ask you to type something, and that's what is this. So in the previous videos, you would have seen this happening a few times. This is JShell asking, okay, you have not typed in the complete statement, go ahead, type in the complete statement. So I'm saying 6. Now I is equal to 6 is a complete statement. So it's able to accept things even on multiple lines. JShell also allows 2 statements on the same line. So I is equal to 6, j is equal to 6. So you need to separate them by semicolon, and then you can execute 2 statements on the same line. One of the important things with JShell is you don't really need to end a line with semicolon, right? So until now we were just typing in I is equal to 6. Typically in programming, you need to end every statement, at least in Java programming, you need to end every statement with a semicolon. But in JShell, it gives you an exception. It says, okay, I know you are lazy, so just type in I is equal to 6 and I am fine. Don't worry about the semicolon when you're executing a statement. When you type in multiple statements, you definitely need a semicolon to separate them. So if you type in something like I is equal to 6, j is equal to 6, JShell will not be able to understand it. So you need to put a semicolon here to separate them out. One important thing about JShell is if you do a exit and come back. So let's say I'm doing an exit now and I'm logging back into the JShell, you'd see that all the variables are lost. For example, I is equal to 6. It would say, I don't know what I is, because you would have created I in the previous session, and this session does not know anything about I. If you are exiting a statement and you see something of this kind, then just go ahead and directly declare the variable then and there. The other thing with JShell is if I type in an expression, so we typed in a lot of expressions earlier, right? So 3 into 4, it's 12, and you can see a $2 which is present in here, right? So at the start of this course, I said, okay, don't worry about it. But now you're ready to understand what's happening in the background with this. What is happening in here is when you type in an expression. So when you type in an expression, what happens is JShell would create a variable with the value of that expression. So what's happening is JShell is actually creating a variable with the name $2. So if you type in $2 now, it would print the value of 12. Whatever expression you are creating, it would be assigned to a variable and stored so that you can actually use and refer to it a little later. You can see that it's very simple, similar to this, right? So int I is equal to 6. I is assigned a value of 6. That's what this says. And similar to that, when I say 3 into 4, 12, what it's saying is $2 is created with a value of 12. That's one thing you can actually try and play around and try and understand it, because this is now cool because I can use $2 now in expressions as well. So I can say $2 into 3. So it's $2 is 12, 12 into 3, 36, and it's creating another variable also. So $4 is the new one. Okay, there you go. That's some of the fun stuff with JShell. All the things which we are doing in this video would be really helpful in the course going forward. So try and play around with them, try and get comfortable with JShell, and I'm sure you'd start loving JShell just like I do. Welcome back. From the time we started attacking the multiplication table challenge, we have made a lot of progress. We know how to calculate 5 into 5. We know how to print 5 into 5 is equal to 25 now. And the last thing that is left out is how to do this 10 times. The expression that we have right now is this, right? So system.out.println percentage d into percentage d is equal to percentage d, and this gets replaced in here. So 5 gets here, I gets replaced in here, 5 into I gets replaced here. If we press this, based on the current value of I, a number is printed. So 5 into 5 is equal to 25. If you had quit JShell and come back, then make sure that you are declaring the variable I again. So let's say int I is equal to 6. You can now print 5 into 6 is equal to 30. You can say I is equal to 7 and print 5 into 7 is equal to 35. That's where we are. What we would want to do now is we would want to print this 10 times. Typically in programming languages, we use a loop to do this.
So what we want to do is something of this kind, right? So for I is equal to 1 to 10, do this statement. For a value of I from 1 to 10, execute this statement so that all multiples of 5 from 1 to 10 are printed to the output. Unfortunately, in Java, the syntax for is not this simple. In Java, the for loop syntax looks something of this kind. So if I want to repeat this statement 10 times, then I would need to do something called initialization. I would then need to check a condition, and then I would need to define an update statement, and after that is when I can execute this statement. One of the important parts of the for loop is something called a condition. A condition can either be true or false. If the condition is true, the for loop continues execution. If the condition is false, the for loop stops execution. That's the reason why before we go in depth into the for loop, what we would try and understand are the basic conditions. We would understand a little bit of conditional execution with if statement, and after that we would come back to trying to solve the for loop. Now, what is a condition? Let's say I has a value of 10, right? Now, if I say I less than 5, so is I less than 5? I has a value of 10. Is I less than 5? The answer is false. This is called a condition. Is I greater than 5? Yes, it is true. The other conditional operators which are present are I less than equal to 5. Is I less than equal to 5? I has a value of 10. 10 less than equal to 5 is false. Is I less than equal to 10? True, because it is equal to 10. Similarly, there is a I greater than equal to 10 as well. So is I greater than equal to 10? Is it greater or equal? Yes, it has a value of 10, so it's greater than equal to 10, it returns a value true. Try and define a couple more variables and try and see what would be the output for different conditions around this. The important thing to understand is that a condition returns a Boolean value. So a condition always returns a Boolean value. Once you have a condition defined, you can even control execution of a program using that condition. What does that mean? Let's say I would want to do a simple system.out.println, and it says I is less than 5. So it's printing I is less than 5. What is the current value of I? I is equal to 10, but it's printing I is equal to less than 5. I would want to say this statement should be executed only if I is less than 5. So only if I is less than 5, I would want to print this statement. How do I do that? I would need to use something called if. The syntax for if is very simple. If followed by condition, followed by statement. The statement you would want to execute is down here. If condition followed by statement. Don't worry, this would give you an error because we are not really defining anything called a statement, and there is nothing called condition defined. But it's basically if in between the brackets you would write the condition, and then you would write the statement that you would want to execute. The great thing about JShell is as soon as I type in if open bracket condition close bracket, it is asking me for an additional line of code because it knows that the if statement is not complete, if condition is not complete without this statement. So it's asking for this statement before it would execute it. So for example, I can say if I less than 5, then system.out.println I is less than 5. You'd see that nothing is printed out. Why is nothing printed? Because I value is 10. If I is less than 5, is I less than 5? Is 10 less than 5? Nope, that's why it is not printed. Let's change the value of I. Let's say I value is 4. And let's execute this same statement again. So if I less than 5, print this. Now you would see that this is printed.
This is called conditional execution. That's the magic of the if statement. With the if statement, you can execute this line of code only when this condition is true. If this condition is false, this line will not be executed at all. Let's consider another example. So let's say there are two numbers. Number one is 5 and int number 2 is 7. So number 1 has a value of 5, number 2 has a value of 7. If number 2 greater than number 1, system.out.println number 2 is greater than number 1. What would be the result? Think about it. Is number 2 greater than number 1? Yep, number 2 is greater than number 1. It's printed out here. So if I change the value of number 2 to 3 and execute the same thing, what would happen? Think about it, what would happen? Nothing is printed. So nothing is printed out to the console because number 2 is not greater than number 1. So this condition is false. If this condition is false, this statement is not executed. In this video, we were introduced to the if condition. So we discussed what is a condition and we also looked at what is a if statement. We saw that code or the statement under the if condition is executed only when the condition is true. In the next video, let's look at some of the exercises related to if and also look at a few puzzles. Welcome back. In this video, let's look at all the exercises related to the if statement. The first exercise is create 4 variables A, B and C and D. Assign a few values to them and also create an if statement to print if A plus B is greater than C plus D. So create 4 variables and create an if statement to print if A plus B is greater than C plus D. That's exercise number 1. Exercise number 2 is have the 3 angles of a triangle stored in 3 variables. Angle 1, angle 2, angle 3. For now, assume that they are all integers. So angle 1 is an integer, angle 2 is an integer, angle 3 is an integer. So have all the 3 angles of a triangle stored in these variables and then decide if these 3 angles would form a legal triangle. I am not a great mathematician, but this is what we learn in basic geometry. Angle 1 plus angle 2 plus angle 3 is 180 degrees. The sum of angles in a triangle is 180 degrees. That's how you would find if a triangle is valid or not. So if the angles are right or not. So create an if statement to state if the 3 angles can form a triangle. The third exercise is to have a variable called number and create an if statement to find if it is an even number. Now, how do you find out if it's an even number? There's a hint down here. So I said modulus percentage operator. So think about it, try and solve these exercises. One of the most important things is from now on, the exercises become even more important because we are getting into if statement. Next, we would go into for loop. The exercises become more important and also a lot more fun. So I would recommend you to spend some time to solve these exercises and I'll see you in the next video where we would solve them together. Until the next video, bye-bye. Welcome back. I hope you had fun solving these exercises and let's quickly look at the solutions for each one of them. So have 4 variables A, B, C, D and create an if statement to print if A plus B is greater than C plus D, right? So let's create a variables. Int A is equal to 1, int B is equal to 2, int C is equal to 3 and int D is equal to 1. Now what we want to print is A plus B greater than C plus D. So if A plus B greater than C plus D, is that right? A plus B is greater than C plus D. System.out.println A plus B is greater than C plus D. Aha, it's not getting printed. That means 1 plus 2, 3 is not greater than 3 plus 1. That's why it's not getting printed. Let's change the value of a. I'll make it a is equal to 6. Now, same statements again. Up arrow. If a plus b is greater than c plus d, system.out.println a plus b is greater than c plus d. That's cool, right? So this is working fine. One of the things is it's better to format it well. So in real world programs, you'd want to leave the conditions like this. So this is much more easier to read. And also you'd want to leave a tab at the start. So here in JShell, you'd not be able to put a tab. So I'm using spaces to format it. So this clearly shows that the if condition is true, then this gets executed. And in the current scenario with the values of the variables, it is true because A has a value of 6 and B has a value of, what is it, 2. So 6 plus 2, 8 is greater than 3 plus 1, 4. So that's cool. So that's why it's getting printed. Let's move on to the next exercise. Have 3 angles of a triangle stored in 3 variables. So let's create angle 1 is equal to 20 int angle 2 is equal to 60 int angle 3 is equal to 50. How do I check if it's a valid triangle? Angle 1 plus angle 2 plus angle 3 is equal to, I'm using a single is equal to, be careful about it, is equal to 180. Then system.out.println valid triangle. Nope, it's erroring out. It's saying error, unexpected type, required variable, found value. What is happening in here? Why is it failing? One of the important things is if you want to compare angle 1 plus angle 2 plus angle 3 is equal to 180, you need to use the comparison operator. Here we are trying to use the assignment operator. What the assignment operator does, it tries to take the 180 and put it to here, but on the left hand side there is no variable. What we have is a value, angle 1 plus angle 2 plus angle 3. So it's saying I cannot take 180 and assign it to a value. We need to use the comparison operator. What is the comparison operator? It is double is equal to. So is equal to is equal to. Remember this always. It's double is equal to. So if you want to compare if a value is equal, if two values are equal, then you need to use is equal to is equal to. And now I can print valid triangle. Let's format it better. Now it's not printing it out because angle 1 plus angle 2 plus angle 3, 20, 60, 80, 80 plus 50, 130. It's not 180. So how do I get it to 180? Let's increase angle 3 by 50. So plus is equal to 50. What's the value of angle 3 now? Angle 3, so it's 100. So angle 1, 20. Angle 2 is now 60. So let's execute the statement again. Now it prints it's a valid triangle. That's cool, right? That's the exercise number 2. The last one is to find out if a number is even. Now let's have a number, int number is equal to 10. Now how do I find out if a number is even? The hint which was given is a modulus operator. What would happen when I do a number mod 2? If it's an even number, what would be the remainder? If it's 10, let's say 10 is an even number, right? So if 10 is the even number, number mod 2 would return 0. The same thing if I do with an odd number. So if I say 9 mod 2, it would return a 1 remainder. So if I do it with an even number, mod 2, it returns 0. Otherwise, it returns 1. So you can think of the logic. You can go ahead and try it if you have not already done it now. Pause the video and try it. I would go ahead and code the solution now. So if number mod 2, is it single is equal to or double is equal to? Think about it. Is it single is equal to or double is equal to? It's double is equal to. If number mod 2 is equal to 0, I press the tab and that's the reason why it came up. You don't need to worry about it. So just type in system.out.println number is even. Cool. Now you see number is even. Let's write it again. If number mod 2 is equal to 0, system.out.println number is even. So it's printing number is even. If number has an odd number, number is equal to 9, what happens? It doesn't print it. These are all the exercises that are related to if statement. We solve 3 exercises. In the next video, we'll look at a few puzzles related to the if condition. Until then, bye-bye. Welcome back. In this video, let's look at a few puzzles related to conditions and if condition as well. Let's declare a variable int I is equal to 5. So we already look at it. I greater than 5 is false because it's not greater than 5. Now, what would be the result of this? I is equal to 5. The value of 5 gets assigned to I, right? If I say I is equal to 5, what would be the result of it? Think about it. Pause the video. Think about I is equal to 5. What would be the result of it? It returns true. Is equal to operator is an assignment. So the value of 5 gets copied to I. Is equal to operator, double is equal to operator is a comparison operator. So the value of 5 gets compared with the value of I. Now the value of I is equal to 5, so it returns a value 5. Sorry, it returns a value true. On the other hand, if I had a value of 6, I is equal to 6, it would return false because I has a value 5. 5 is not equal to 6. Now let's consider another example. So let's say if I is equal to 5, I would want to say I is odd, and also I would want to say I is prime. So I would want to print two statements. If I press enter here and say system.out.println and say I is odd and press enter, that's the only statement which gets executed. Now I would want two statements to get executed if I is equal to 5. Can I do something of this kind? System.out.println I is odd and type it in the same thing. System.out.println I is I is prime. So what I'm doing is if I is equal to 5, system.out.println I is odd. Because we would want to type in another statement, I'm having a semicolon here. So one of the important things is typically in programming languages, semicolon is used to end a statement. However, in JShell, you don't really need a semicolon. But when we switch to writing Java programs, you would see that we would use semicolons to end statements. And over here, I would want to type two statements on the same line. So I'm using semicolon to separate them out. Now, let's see what would happen. It's printing I is odd and I is prime. Let's change the value of I to 6. Oops, I used comparison. I would want to do assignment. So I is equal to 6. So now I has a value of 6. Now I execute the same statement again. I is equal to 5. And let's print it. So I now has a value of 6. But this condition is getting executed. So it's saying I is prime. Why is it so? So if I is equal to 5, I is odd and I is prime. But I right now has a value of 6. Why is this statement getting executed? Think about it. One of the most important things that you need to understand is a if statement. The if condition can have only one statement under it. So this statement is the only one which is under the if statement. This one is not falling under the if statement. That's why it gets executed. So if I is equal to 5 is used to check only for this statement. So if I is equal to 5 is false, what happens? This statement is skipped, but this statement is executed. That's what we are saying. I is prime is printed. Even though I does not have a value of 5, this statement gets executed. Now, if I want to have both these statements under the if condition, so I would want both these statements to be printed only if this condition is true. How do I do that? The way I can do that is by using something called a block. In programming, blocks are started with an open brace, and now I can type in multiple statements in here. So let's take the system.out.println I is odd. That's what I'm typing in right now. And you can see that now it's accepting more statements. So now I can say system.out.println I is prime and end it. Now you would see that nothing is printed because I have a value of 6. None of these statements are executed. In an ideal world, actually I would want to give spaces and make sure that this is tabbed out a little bit so that it's very clear that these two statements are inside the block. So typically in programming languages, a block starts with an open brace and ends with a close brace. And if you would want to group a set of statements under the same condition, we would use blocks. So this is a if block, and all this code under the if block is executed only if the condition is true. One of the recommendations for you is always use blocks. So even if you have to execute only one statement, I would recommend to use blocks because it would make it very clear to programmers who come after you. So even if I'm going to have only one statement in the if like this, even then I would actually love to put it in a block, just because at a later point in time somebody might come in and add another line of code below it without having a problem. If I have something like this, if somebody comes and adds another line of code beneath it, assuming it's under the if, it would cause a problem. Okay, there you go. Those are some of the important things that you need to understand about the if statement. Until the next video, bye bye. Welcome back. In the previous video, we talked about the if statement. Actually, there are a lot of wonderful stuff around the if statement, like if else, nested if else, and also combining conditions using logical operators. We'll talk about all of them later. For now, let's focus on the problem at hand. We would want to solve the multiplication table problem, and we discussed about the syntax of the for loop, right? So we said the syntax of the for loop is for you have to have an initialization in here, you can have a condition in here, and you can do an update in here. And in here I can put the system.out.printf statement. So now we need to decide what should be in the initialization, what should be in the condition, and what should be in the update. What do we want to do? We would want to execute the loop from I is equal to 1 to 10. So we would want to execute the statement from I is equal to 1 to I is equal to 10. So we would want to print it from I is equal to 1, I is equal to 2, 3, 4, 5, 6, 7, 8, 9, 10. In nutshell, we would want to start with I is equal to 1, then print this, and after that we would want to increment I, right? So I would want to say I is equal to I plus 1, and then again print the same thing, then again execute this and do this. Until when should we do it? Until I has a value of 10. When I has a value of 10, we would want to stop executing this, so that we would have 5 into 1 is equal to 5, 5 into 2 is equal to 10, and so on, printed up to 5 into 10 is equal to 50. So just to repeat, so we would want to initialize the value of I to 1 and then keep incrementing the value of I. So we would want to keep incrementing the value of I until when? Until the condition I is less than or equal to 10. So until less than or equal to 10, we would want to continue executing this statement. So for the initialization, the initial value of I we would want to give is I is equal to 1, right? So we would want to start with I is equal to 1. So that's what we have put it in here. So int I is equal to 1. If you have not declared I yet, you can actually go ahead and declare it in here as well. So int I is equal to 1, or you can go ahead here and say int I. You can just declare it in here. So I is equal to 1 followed by a semicolon. The condition we would want to check is I less than or equal to 10. So until I less than or equal to 10, we would want to execute the loop. And what is the update that you would want to do? The update that I would want to do is I is equal to I plus 1. So each time increment I is equal to I plus 1. You can actually write I plus plus. And inside this, I would use a block. Using a block is a good practice. So even though there is only going to be one statement under the for loop, I would open brace and close brace, and between that I would type in the statement. One of the things you can do is open up a text editor like a notepad or something to type this in so that you can easily copy and paste it down. Now, the statement we would want to execute, we already have that, right? So this is the statement that we would want to execute. Cool. So this is what we would want to do. For I is equal to 1, until I is less than 10, keep incrementing I and execute this statement. Let's see what would happen. Let's type it in here. For I is equal to 1, I less than equal to 10, I plus plus, there should not be a space in here, and open brace. I would want to do this because this is under the for loop. I would try and give a little bit of space. It does not really matter for now. And close brace. Let's see what would happen. It says semicolon expected. That's because I have not ended this statement with a semicolon. So inside a for loop, you need to use a semicolon to terminate this statement in a block. So let's go ahead and put a semicolon and now execute it. Now you can see the 5 table being printed. So all that we had to do was do a simple thing. For I is equal to 1, I less than equal to 10, I plus plus, do this whole thing. If you did not get the output or there was a problem, then check the syntax again. So it's basically for open bracket, I is equal to 1, this is the initialization, this is the condition check, this is the increment or the update operation. So you can see that each one of these is separated by a semicolon. So initialization, semicolon, condition, semicolon, increment, followed by a bracket, followed by an open brace, and inside that is the statement followed by a semicolon and followed by a close brace. So make sure that you have the case right. So make sure that system.out.printf and the println are in the exact case are there in here, and you should not really have a problem. And you should see the output being printed out in here. Isn't this cool? These 3 lines of code is all that is causing this multiplication table to be printed. Now let's take a step back and look at what happens with the for loop. The way for loop is executed is this statement which is present in here, I is equal to 1. This gets executed only once. That's when the for loop starts executing. So when for loop starts executing, I has a value of 1. I is initialized with a value of 1. And immediately thereafter, the condition gets executed. So I has a value of 1, it would check if I less than equal to 10. So 1 is less than equal to 10, that's cool. And then the statement gets executed. So that's why we would see 5 into 1 is equal to 5. And once the statement gets executed, what is executed? After that, every time the update gets executed. So the first time, only the first time initialization gets executed, and after that, every time update gets executed. So if the loop is executed 10 times, then the initialization is executed once and the update is executed 9 times. However, the important thing to remember is the condition is executed always. Whether you do the initialization or the update, after the initialization or the update, the condition is checked, and only if the condition is checked, this statement is executed. So I has a value of 1 less than equal to 10, executed. I gets incremented, I has a value of 2 less than equal to 10, yes. 3, yes, 4, 5, 6, 7, 8, 9. When the value of I is 9, I plus plus gets executed, I becomes 10, I less than equal to 10 is true. So system.out.printf, this gets executed and we see the output 5 into 10 is equal to 50. Once the statement is printed, I gets incremented again. Now I would have a value of 11 because from 10 it becomes 11 and check the condition check gets executed. I less than equal to 10, is that true? Nope. I less than equal to 2 is not true because I has a value of 11, and that's when we quit the loop and go out. If this sounds a little confusing, don't worry about it at all. We will write a number of for loops in the exercises as well as in the puzzles, and make sure that you understand the for loop very well. Congratulations on getting the output that we wanted, but there are things which are still bad in this program. There are things that can still be improved in the program that we wrote. So let's focus on that and learn a lot more in the subsequent videos. Until then, bye bye. Welcome back. Congratulations on successfully executing a for loop. If this was the first for loop you have executed in your life, this is a major step for you. I'm so happy. Now, let's shift our attention. Let's play even more with for loop with a few exercises. The first exercise we would recommend you to do is to do the whole thing again with 7 table. One of the important things is getting started with programming is a little tough. So there might be few things which you did not understand properly or things like that. I think if you do a second revision through the whole thing, you would learn even more. So if you have little bit of time, do the whole thing, but instead of the 5 table, try and do the 7 table. And also kill JShell, kill everything and start off again fresh and give it a try. Good luck with that. The second exercise is to print 6 table and the 10 tables. Until now we have been printing the 5 table. So try and print the 6 table and the 10 tables. The third exercise is to print numbers from 1 to 10. Fourth one is to print numbers from 10 to 1. Fifth one is to print squares of first 10 numbers. By square I mean number multiplied by itself. So 5 square is 25. 5 into 5 is 25. And print squares of first 10 even numbers and print squares of the first 10 odd numbers. So good luck with all these exercises, and I'll see you in the next video after you complete the exercises. Until then, bye bye. Welcome back. Let's look at the exercises we talked about in the previous video. So the 7 table one, I will really leave it as an exercise. I don't really want to do the whole thing again. So go ahead and do it by yourself. Now print 6 and 10 tables. Let's start with that, right? So we were printing the 5 table until now. So if you want to print the 6 table, all that you need to do is change 6 to 5. Sorry, change 5 to 6. That's it. There's your 6 table, and now let's go for the 7 table as well. Now, is that cool? So now I can see I can print 6 table and 7 table, right? You can make it even cooler, right? If I actually define a variable called table, so table is equal to 7, and let's now use that in the for loop. So for I is equal to 1 to 10, instead of 7, I would say table. And close brace. It's printing the 7 table now. Let's change it. Table is equal to 8, and it prints the 8 table as well. So the same code right now. So previously when we had to change the table, I had to change this from 8 to 7 or 6, whichever table I would want to do it. Now I don't need to. So I can say table is equal to 8, and that's it. I'm ready to execute for the 8 table, or if you would want to do the 9 table, then table is equal to 9 and execute the same statement again. That's it. It's 9 table again. So we are now controlling the table which is being printed by the table variable. That's cool, right? So that's what programming is all about. So step by step, make your program more customizable. So that's what we were doing all through the last few steps. We are trying to make our program more and more generic, so that it is more and more reusable. What we want to do is to print numbers from 1 to 10. So how do we do that? Whenever we do a for loop, what you need to do is we need to decide the initial condition. What is the initial condition? We would want to start with 1. So for int I is equal to 1, or you can just say I is equal to 1, because I is already defined. The condition is I would want to execute until I has a value of 10. That's cool. And I would keep incrementing it. And as usual, let's go for a open brace and type in. I'll take the same statement from previously and let's modify it. So what we want to print is just the numbers, right? So I would need to print I. So system.out.printf %d comma I.println, and that's it. I have numbers from 1 to 10. I guess this should be an easy one to solve. The next one is much more interesting. So I would want to print it from 10 to 1. How do we do that? Think about it. So what is the initial value? The initial value is I is equal to 10. That's right. So we want to print from 10 to 1. So I is equal to 10. That's cool. Now the interesting thing is, what should be the condition that needs to be checked and what should be the update that needs to be performed? What should be those? Because I would want to go from 10 to 1. So when I want to go from 10 to 1, should I increment or should I decrement? The interesting thing is that you should decrement, right? So I would want to decrease at each. So I would want to go from 10 to 9 to so on. So now I would say I, not here. So I would need to put this in the decrement. So I would need to say I is equal to I minus 1, or the shortcut is I minus minus. Now over here, what do I need to check? So until when should I execute the loop? If I say I less than equal to 1, what would happen? When I is 10, let's try this out. System.out.println I. Nothing is printed. Why is nothing printed? Because the initial value of I is 10. The condition is checked, I less than equal to 1. Is 10 less than equal to 1? Nope. That's not right, because 10 is greater than 1. So that's not true. So nothing is executed and it comes out. Now, the way actually it should have been done is by I greater than equal to 1. So we want to keep executing the loop until I is greater than or equal to 1. Let's see what would happen with this. Now numbers are printed from 10 to 1. Let's say I would want to print every alternate number in here. So I would want to print 10, 8, 6, 4 and 2 only. How do I do that? Think about it. What is the easiest change I can do to this statement to print from 10 to 1, but only print the alternate numbers? What I can do is, instead of I minus minus, I can do I is equal to I minus 2. So decrement by 2, and then what would happen? Awesome. 10, 8, 6, 4, 2. Actually, you can look, if you change the initialization, the same program would print the odd numbers as well. I would leave you to think about these. So try and think about these and make sure that you understand what is happening in here. So I has a value of 9. Every time it gets decremented by 2 until the value of I is greater than equal to 1. Once I reaches 1, when it's decremented, I is equal to I minus 2, it goes down to minus 1. This condition would be false and it comes out of the loop. And the same thing in here, when I becomes 2, when you do I minus 2, I becomes 2 minus 2, 0. This condition will not be met and you would get out of the loop. Isn't for loop a lot of fun? I love the for loop and I hope you are loving it too. Now, next, print squares of the first 10 numbers. So what we want to print is not I, but I square. So it's quite an easy thing, right? So we have done much more complex things than that. So let's find the loop. So this was the basic loop, I is equal to 1, I less than equal to 10. I use up arrow, down arrow to navigate between them. So instead of I, what we want to print is I star I, right? So we want to print squares. Cool. So 1, 4, 9, 16, 25, 36, 49. If you're good at mathematics, check if all these values are right. Next one is to print squares of first 10 even numbers. So we would want to print the squares of first 10 even numbers. Let's try it. So instead of, because we would want to print the squares of the even numbers, I can start with 2 and let's say I is equal to I plus 2. Do you think this would work? Think about it. So I'm saying I is equal to 2, I less than equal to 10, I is equal to I plus 2. So this is actually printing the squares of only the first 5 numbers, right? So one way to do it is to say I is equal to 2 to I less than 20 and execute the loop. So now it prints the squares of the first 10 even numbers. Another way you can do that is to continue using the same loop that we used earlier. So I is equal to 1, I less than equal to 10, I plus plus, and you can do some magic in here. So instead of doing I star I, what you can do is 2 star I, oops, let's start again. Instead of doing I star I, what we can do is 2 into I star 2 into I again. So make sure that you have the brackets aligned. So it's 2 into I star 2 into I. Actually, you don't even need the brackets inside. So you can directly type in 2 into I, 2 star I star 2 star I. What I'm doing is, when I is 1, I'm multiplying it by 2. So 2I into 2I, which would print the squares of the first 10 even numbers. The output, if you'd see, is same as exactly what was before. So try and think about it, try and see what you can learn from it. Print squares of the first 10 odd numbers. So let's start with this. So I'll instead of starting from 2, I can start from 1 and I can keep the condition as it is. Think why I'm leaving the condition as it is. Think about it, and this would print the squares of the first 10 odd numbers. There you go. That's a lot of fun that we had with the for loop. There are a lot of programs that we have done with it very quickly. One of the interesting facts is you can see how JShell gives you immediate feedback, right? So if you had previous experience with an IDE or writing a Java program outside JShell, you would know how difficult it was to try different things. JShell makes it very easy, and that's why we are able to experiment so much in this course until now. I'm sure you're having a lot of fun with the course until now, and I'll see you in the next video. Welcome back. In this video, let's look at some of the puzzles related to for loop. So let's say I am declaring a variable, right? Int I is equal to 1, and I'm typing something of this kind. So the initialization, I'm leaving it empty. So I'm just putting a semicolon, and I'm trying to run this. What would happen? It says illegal statement, because in a for loop, you need to have minimum of 2 semicolons. So this is initialization, and this is the condition, and this is the increment. So let's leave the initialization part empty, and let's say I less than equal to 10, I plus plus, and I am following it up with a semicolon. What would be the value of I after this? Think about it. So I'm executing this. What will be the value of I now? The value of I is 11. The important thing is, in a for loop, each of these parts, the initialization part, the condition part, and the increment or the update part, can be empty. So they can all be empty. The only things which are mandatory are the two semicolons. You definitely need to have two semicolons to separate the empty stuff. And the interesting thing that we have done here is we directly put a semicolon after the for loop. When we put a semicolon after the for loop, it's called a empty statement. So basically what the for loop does is it executes the empty statement, which does nothing. So what happens is I starts with 1, the condition gets executed, I less than equal to 10, that's true. So I plus plus will be executed, I less than equal to 10, I plus plus, I less than equal to 10, and so on until this condition fails. This condition fails when I is 10 and gets incremented, that's when I becomes 11, and then this condition fails. So the value of I is 11. The next important thing to understand is that you can even have multiple statements in each of these parts. So in the initialization part, I can have I is equal to 1, I'm initializing the value of I, and also I can use other variables in here. So let's create a variable int j and assign it, let's just define it. So int j, and over here what I'll do is int I is equal to 1, j is equal to 2, and over here I can do j plus plus as well. So at the end of the whole thing, I'm just putting a semicolon, so it's an empty. So what do you think will be the values of I and j? So I is 11, it's the same as before, j is 12, because j starts at 2 and it gets incremented the same number of times as I, it gets a value of 12. You can use a comma and you can include multiple statements in the initialization and multiple statements in the update. The other interesting part is the fact that I less than equal to 10 is the condition, right? So there can only be one condition in here. You can have multiple statements over in the initialization, you can have multiple statements over in the update, but there can be only one condition in the condition. Now the same thing, let's say I'm doing j minus minus. What would be the output? Think about it. I has a value of 11, we didn't change anything. J has a value of minus 8. That's because instead of incrementing, what we are doing is decrementing the value of j. So j gets decremented 10 times, so 2 minus 10 is minus 8. That's the value which is printed in here. You can even have a for loop, something similar to this, and execute it. This is called a for loop infinite loop. So you can see that the statement never returns back because the condition is empty. That means it's true always, and it keeps executing again and again and again and again and again. The only way to terminate it is by pressing Control C. So type in Control C and it would break out of the loop. If you want to have more fun, you can actually add a statement in here. So here you can add a system.out.println and see that the same thing gets repeated until you press Control plus C. So Control and C, press it both together and you would come out of the infinite loop. So this is what is called an infinite loop, where the loop gets executed continuously forever because there is no condition. The last puzzle that we would want to talk about is, let's say I is equal to 1, I less than equal to 10, I plus plus, and I would want to print two statements. How do I do that? Yep, use a block. So now I can actually, I press a tab by mistake, but that's okay. So system.out.println, I can print number 1, statement number 1, and I can print statement number 2 and close the brace. And you'd see that number 1 and number 2 are printed alternatively. So All that we had to do was do a simple for loop with a block. So we had a block with an open brace, and we printed system.out.println number 1 and number 2, and this was the code which we typed in, and this was printing the numbers alternatively. So typically always use blocks with for loop and if statements. That would ensure that your code remains maintainable. In this video, we had a lot of fun with the for loop. We tried to break it as much as possible and tried to discover all the variations around it. I'm sure you had a lot of fun, and until the next video, bye bye. Welcome to the last video of the first section of this course. In this video, we will revise all the terminology that we have learned until now, as well as we would also discuss a few tips that would help you make even better use of this course. Let's start with the basic terminology. The first terminology that we learned was literal. This was a numeric value 7, right? 7 is a literal in here. So 7.5 is a 7 is an integer literal, 7.5 is a decimal literal. The integer literal is of type int and the decimal literal is of type double. Now try and see the other literals on the screen right now. You can see 1 in here, it's a literal, 10 also is a literal. The next thing that we talked about was expressions. If you look at this statement, table into I is an expression. There is an operator being used, star, and two operands, table and I, and we are using star to multiply them, and this whole thing is called an expression. All programs are made up of statements. If you look at this entire thing in here, this is a statement. This declaration over here is also a statement. Each line of code in your programming languages is typically, most of the times, a statement. Statements are sometimes made up of expressions. For example, if I say int a new number is equal to table into 7. Over here, table into 7 is an expression. The whole thing is called a declaration statement. We are declaring a variable. The next thing we talked about was variables, right? So the new number in here is a variable. A variable is something whose value can change during the program. In this program, I is a variable, table is a variable. I can say table is equal to 8. And over here, I value is changing from 1, it's getting incremented here, and it becomes 2, 3, 4, 5, 6, and so on up to 11. We also were introduced to char data types, which you can print in this way. So this is a char data type. So I would want to store a single character, char ch is equal to a. It's using a single quote. This single quote is right below double quote in your keyboard. Typically you would use shift and press the key which has the double quote on top of it. That's the single quote. One of the things we would need to note is the fact that we did not really extensively talk about either char or boolean or the floating point data types. That's something which we would do in the next sections. The next thing which we talked about was the assignment operator. Over here, this is an assignment operator. 8 gets copied into table. So the assignment operator is used to populate a value into a variable. So this can also be an expression, right? So the calculated value of this expression is stored into the table variable. After that, we jumped into conditions. I less than equal to 10, I less than 10, I greater than 5, I less than 5. And we also looked at the comparison operator. So I is equal to 2 is table value 7. If table is equal to 7, that means table has a value of 7. Table is equal to 7 is assignment. Table is equal to 7 is comparison operator. We looked at several inbuilt methods, system.out.printf, system.out.println, and also we looked at math.max, math.random, and math.min. An inbuilt function is something which is already predefined as part of your Java libraries. So the system.out.printf is something which is already defined. All that you need to do to use it is to call it. You don't really need to define what it does. This is already defined and we are making use of it. That's a predefined method or a function. The last thing which we looked at was the for loop. So we looked at the syntax for the for loop: initialization followed by condition followed by the update. So in a for loop, you can execute the same statement multiple times. The first time in the for loop, the initialization gets executed, and for all the subsequent iterations, the increment gets executed. The loop executes until this condition remains true. So initialization, check. Execution of the code. After that, update, check. If check is true, then code is executed. Again update, and then again check, and if check is true, code is executed. So on and so forth until check remains true. Whenever check becomes false, you would flow out of the loop. This is basically how a for loop works. Those are some of the important things that we learned in all the previous videos in the previous section. I'll leave you with a couple of tips. If you think I'm going too fast or too slow, then you can adjust the speed at which the video is played to you. So the default is 1x, but you can actually make it 1.25, 1.5 or 2x. You can make it faster, or you can even make it slower, 0.75x, 0.5x. If there are places where I'm typing too fast, then you can set it to 0.5x so that you can see it in slow motion. And if you think I'm too slow, then you can go ahead and increase it to 2x as well. So you should find it in the interface of your video player. The other important thing is, if you're thinking I'm typing too fast and it will be difficult for you to learn, do not worry about it at all. I'm sure by the end of this course, you'd be typing as fast as I am. It's all matter of practice. It's all matter of keeping at it and focusing on the code, and over a period of time you would also be able to type equally fast. I hope you had a nice time during this section. I hope you have learned a lot, and I'm sure there are a lot of outstanding questions in your mind, and that's common. Whenever we start with programming, it's a challenging thing. It's one of the most difficult things to get started with, and the fact that you have actually come up to here is a big thing. So congratulations, and I will see you in the next section. Until then, bye-bye. Welcome back. In the previous section, we learned how to print the multiplication table. However, executing the multiplication table is not really easy, right? So I had to execute multiple statements, write a lot of code to execute the multiplication table. Now, if I want to give this to a friend, so I would want to share the code for multiplication table with my friend. How do I do that? The solution to that is going to start with a basic concept called method. In this section, we would try and see how to create a method for these lines of code. Method is nothing but a name you give to a set of lines of code. So we'll understand how to create methods, and methods can have inputs, methods can have outputs. We will see how do you give input to a method and how do you get output for a method. If you're excited about learning about methods, I'll see you in the next video. Welcome back. As we discussed in the previous video, executing these lines of code is not really easy. And also, if I want to print a new table, it's not easy as well. So I have to change table value to 8, and I would need to again execute these lines of code, type in the entire thing, and only then I'm going to execute the 8 table. Is there an easier way of doing this? Can I say these 3 lines of code, I would want to give it a name. I would want to be able to say print multiplication table and pass in 8 as the input. So I would want to print multiplication table of 8, and I would want to see this output in here. That's what we would want to do. With that as the long-term aim, in this step, we will start and create a simple method. So what is a method and what is the syntax of a method? Let's take a basic problem, right? So I would want to print hello world twice to the output. So typically how we would do that, if I want to print hello world twice to the output, I will type in system.out.println, and because it's a string, I would need to put it between double quotes, hello world. So that's what I would need to do, right? Semicolon, as far as it's JShell is concerned, semicolon is not really mandatory. So I can say system.out.println hello world and press enter. Oops, I missed a T and that's why it's complaining. So println hello world. And if I want to print it twice, what I can do, so this is how I can do it twice, or the easiest way is system.out.println. I'm executing the same statement twice. So this is what we are doing, right? I would want to create a method to be able to do that. I would want to be able to call a method saying print hello world twice, and it should print hello world twice for me. Let's look at the syntax for a method. What you're looking on your screen right now is the basic syntax of a method. Any method has a name, so you would give a name to the method. One of the methods which we made use of is println, printf. That's basically the name of the method, and the method does something. So when we are talking about our example, it needs to print hello world twice. So the method has some code in it. That code is called body of the method, and methods can also have return types. So if a method does some calculation, it can say I'm returning this calculation back, and return type is the type of that calculation. If I'm returning an integer number back, this type can be int. If I'm returning a true or false, then this type can be a boolean. Let's talk about our specific problem, right? So the thing which we are talking about is we would want to print hello world twice. So in the case of hello world twice, I don't want to really return anything. I am okay if it's printed to the console. So if I don't want to return anything, then the return type is called void. And the name of the method I would want to use is say hello world twice. So that's the name of the method I would want to give it, and follow the exact syntax. And over here is the body of the method, right? So the body of the method, what do we want to do? We would want to do system.out.println, and we would want to print hello world. And I'll copy the same line again and paste it below. And after that, I can type in the closing brace. So it's very simple, right? So this is like a block of code. Earlier we looked at in a if statement, you can type in two statements, right? A block starts with an open brace and ends with a close brace. And before the block, we give it a name. The name is say hello world twice, followed by a open bracket and a close bracket. Before that is the return type, void space. So to make it easy for you to understand this, we'll type this whole thing again. The syntax to create a method is very simple, right? So we looked at it here. Return type, name of the method. So the return type for us is void. Void tells that I'm not going to return anything back. The name of the method that we would want to give is say hello world twice. That's what we would want to do. After the name of the method, you need to follow it with an open bracket. It's not a brace, it's a bracket, open bracket, and a close bracket. And after that is a open brace. And you can press enter now. Because we are doing it in JShell, JShell knows that you are trying to declare a method. Inside that, you can say what you would want to do. You can either copy this and paste it in, Control C, Control V. I'll again do a Control V. So now we are doing it twice, and I'll do a close brace. That's it. The important thing is the output. It's saying I have created a method, say hello world twice. So JShell is telling us, okay, a method called say hello world twice is created. But the important thing you can note in here is hello world is not really printed to the output. What we are doing in here is called defining or declaring a method. So this is declaring a method in the sense that we give it a name, and this is defining a method in the sense that we are actually telling it what to do. Typically declaring means giving a name, and defining means defining what it does. So in this particular statement, we have created a method. To be able to see the output, to be able to execute the method, we need to say hello world twice and open bracket, close bracket. That's it. You can see now that the method is executed. So what we are doing in here is defining a method, and over here we are calling that method. This is also called invoking a method or calling a method or executing a method. There are a wide variety of terminology which is used. So all of them really mean the same. So you are calling a method means you are executing the code inside that particular method. If you had a problem with say hello world twice, then make sure that you have the brackets right. So we have a open bracket, close bracket, and over here is a brace and a close brace. Those are the only things you need to worry about. Other than that, executing is very simple. There is typically a little bit of confusion around methods, functions, what is the difference between them. For now, let's use methods and functions interchangeably. There is a slight difference between them, which we'll talk about later in the course. The last important thing is that the name of a method also follows the same rules as of that of defining a variable. So the name of the method also starts with a lowercase, even though Java allows you to start a method with the uppercase. Typically, we would start the names of all methods with a lowercase. That's what you'd see in the system defined methods as well. So earlier we looked at math.max, m is a small. So after the dot is the name of the method. So p is starting with a small. System is a class name, that's why it's in caps. Even in the math.max, math is a class name and max is the method name. So always the method names in Java start with a small letter, and they would use camel case. That means all the words except for the first one will start with a capital letter. So say hello world twice. Now that we have created our first method, let's turn our attention towards the exercises. Create another method, call it say hello world thrice, and print hello world thrice in that specific method, and also execute it. The second exercise is to create a method which prints these four statements. So it should print these four statements and also at the end execute it. Solve these exercises and I'll see you with the solutions for these exercises and a couple of puzzles in the next video. Until then, bye bye. Welcome back. Let's look at the exercises and a couple of puzzles in this specific video. The method which we wanted to create is say hello world thrice. The way we would create it is very similar to hello world twice, right? So I would need to call it hello world thrice, and after that I can copy this statement from here 3 times, 1, 2, 3, and press enter. Create a close brace, and now we have the method created, and now I can execute it by using exactly the syntax which it shows. So say hello world twice is what I did and pressed enter, and now you have hello world printed thrice. I hope you had fun doing that exercise. The next one is creating a method which prints 4 statements and executes it. These are the 4 statements we wanted to print. I have created my first variable, my method, my first loop, and I am excited to learn Java. So the first thing you need to decide when you're trying to create a method is what should be the name that you need to give to it. We know it's a void method because we are not asking you to return anything back. So it's a void, but what is the name that you need to give to a method? Actually, that's one of the most important decisions that you need to make, because this is actually printing something You need to exactly say what it's printing. If you call it print 4 statements, is that a good name to the method? Is that representing what is done in the method? That's a question you need to keep asking yourself. Great programmers give great names to your variables, great names to your methods, and great names to your classes whenever we come to classes. Right? For now, try and give good names to your methods and variables. Think about what can be a good name for this particular thing. I'll just call this for now print learning experience. So this is printing how your learning experience was. So I'll just give it a name like that. As you can see, giving a name to a method is really difficult. So try and think of good names to your methods. For now, let's use print learning experience, and I'll copy the basic first part of it so that I don't need to type it again and again. System.out.println. I can copy I have created my first variable. I have the advantage in here that I can copy it from the exercise, or you can actually use the up arrow and you can change the text which is present in here. So I've created my first method. Let's copy it out. Next, let's copy the next statement. I've created my first loop. And the last one is to copy I am excited to learn Java. What is the last line of a method? It should always be a closing brace. So the method is created. How do I execute it? I'll copy this and paste it. So it's executed and I see these 4 things printed on the console. So that's cool, right? So we have created 3 methods until now, and now I can call this method as many times as I would want to. Now let's look at a few puzzles related to methods, right? So if I want to say print learning experience, what would happen? If I just press enter right now, what do you think will happen? It says symbol cannot be found, because what's happening is there is a search going on for a variable with a name print learning experience. If I want to execute a method, you need to have the brackets around it. So this is how you would say print learning experience. Let's try to define a method with this name. Void 2 things and close brace. So the method is not doing anything. I just do this. You can see that it gives an error because the name of the method cannot start with 2. The rules for name of the method are exactly the same as the rules for names of variables. The names should be a combination of letters, numbers, dollar, and underscore. The important thing is a name cannot start with a number. So these are only legal things that you can use in a name. The name cannot be a keyword. For example, one of the keywords which we saw is void. So can I try and define a method? Void. Is this allowed? Nope, it's not allowed because void is a keyword. Another keyword is fur. We looked at fur, so that is another keyword. You can see that as soon as I type it in, it is already throwing an exception. Same is the case of if. So you cannot use if, for, and all these kind of keywords as name of a method or name of a variable. The last rule in here, camel case, is more of a convention. So you can actually, if you would want to create a method with a capital case, starting with a capital case, that's allowed. So I can say name of method, void name of method, and it does nothing for now, but you can do that. That's allowed, but that's not something which we typically do in Java. So all Java programmers prefer to follow a camel case. We start the name of the methods with a small letter, and after that every word we would have a capital letter. That's called camel case, and this is a good name of a method. This is a bad name. Okay, there you go. Those are some of the important things around basics of methods. I'll see you in the next video. Welcome back. In the previous video, we typed in and created a few methods. and we created a few methods in the exercises as well. One of the things you would have already noticed is editing methods in JShell is not a very easy thing. In this video, we'll give you a few tips related to editing methods with JShell. So, if you want to display a list of methods which you have already defined, /methods would give you the list of methods which are already defined. We created the method say hello world twice earlier, hello world thrice, print learning experience, and at the end when we were looking at the rules regarding the name of the method, we created these two methods as well. If you see other methods which are present in here, don't worry about them. You can see a clear method in here which was something which I was playing with earlier. For now, the important thing is all the methods which we have defined in here are visible. One of the most important things to remember is if you do a /exit now and come back, these methods will not be visible at all. When you do a /exit and come back, it would refresh everything and all these methods would disappear. What you can do to save all the code is to do a save, first a / then a save. So /save is a command which you can use to save the code down. So you can save the code down and create the methods again. So you can say /save backup.text, and this would save the entire backup to a file called backup.text. This will be created in your present working directory. So that's the directory from which you launched JShell. So whichever directory you launched from JShell from, this would be present. Or you can do a search to find out where this backup.text is. This is what I see when I look at my backup.text. So say hello world thrice, the execution of say hello world thrice, print learning experience, and the print learning experience execution in here, the name of the method, and all this stuff is present in the backup.text. Later in the course, when we actually get into classes, we will see how to put a method in a class and save it as a Java file. The other thing you can do is to see the code of the method. So what you can do is use a /edit and you can say hello world twice. So /edit and the name of the method. What happens is this would launch an editor. Sometimes what happens for me is the editor goes into the background. So go and see in the background if something has launched. So over here you can see this is the edit pad where I can see the code for say hello world twice. The important thing about this editor is I can even edit it. So I can, let's say, remove the space here. So I can remove the space. So hello world is single word, and you can click accept in here if you'd want the method to be saved, and I can exit out. So now I have made the modification to the method and I can again execute say hello world twice. You can see that hello world is getting printed without the spaces. You can try and edit any of the other methods, let's say hello world thrice, and try and play around with it as an exercise. This method of editing is much more easier because you can actually type in multiple lines very easily. So let's say I would want to edit the print learning experience method. It's coming up in the background. And I can actually directly go and change whatever I would want to change. So I'm typing in some random stuff. This is the first random stuff that I'm typing in this course, right? So now I can say accept or exit. Both of them would make sure that that change is reflected. Now when I call print learning experience, you'd see that my random characters are also printed in here. So the change that we did to the method is being picked up. So whenever you're trying to exit the JShell session, take a backup of the important methods for now. And the other way is something called a list. So you can actually use a /list and say print learning experience, and it would print the code inside that in here. So you can take this and copy it out into your editor. For now, to take a backup. Be careful with that in the next few times. If you don't really want to type the entire methods again and again, take a small backup. In this video, we looked at some important tips regarding how you can work with methods in JShell. Until the next video, bye bye. Welcome back. In the previous step, we created methods of this kind. Say hello world twice, I can execute it and it prints hello world thrice. And we also created say hello world twice, which prints it twice. Let's say I would want to print it 4 times. What I would need to do is now I would need to create a method for doing that 4 times. Isn't that a boring thing? I mean, the same method I have to create again and again and again with the same code. Can I do something of this kind? Can I say, instead of say hello world twice, and can I say hello world and pass it how many times I would want to print? Why not say hello world and say 3 or 4 or 5? How easy would the world be when I can do that? That's basically what we would do in this specific video. We would enhance our hello world methods with something called a argument. Earlier, when we looked at the simplified syntax of the method, we saw this return type followed by name of the method followed by open bracket close bracket brace, and between that what do you want to do in the method, that's the body of the method, and the close brace. This is kind of the syntax that we used, right? So you can also have arguments that are passed to a method. So how do you pass an argument? The way you can pass an argument is by declaring it between the brackets. So between the brackets, I would need to say type and argument name. So over here, you can give the type of the argument as well as the argument name. For now, what we want to do is to print hello world as many times as the argument says. So it would look something like this, right? So we would want to actually use a return type of void because it doesn't return anything. We would focus on return types a little later. For now, it's void. Name of the method is say hello world. That's the name of the method. The type that I would want to use, what do we want to send to the say hello world method? 1, 2, 3. So what is the type of that? Let's say it's a integer, right? And I would need to give it a name. So I need to give the argument a name. I'll call it number of times. So say hello world int number of times and followed by a open brace, and over here is the body of the method, right? So whatever logic that we would want to do, we would need to do it in here. We would want to print the hello world or whatever I would want to do and close brace. So that's basically the syntax, right? So let's go ahead and try and create an simple empty method right now. One way you can do it is if you have typed it in the editor, you can do a Control C and Control V and see what would happen. So I'll try that now. I'll remove this and I'll try and paste it in. This is one of the things which I have seen happening with JShell. When you copy code from outside, it's only copying 2 lines at a time. So you can see that the first line is copied, the second line is copied, but the third line is not really copied. And now I can press enter. So this has created the method say hello world. Let's try and call the say hello world method. Will this work? Say hello world. Nope, this does not work because say hello world, we said it needs a parameter that should be passed in. But over here, do we have a parameter in between the brackets? When we are invoking a method, you need to pass in all the parameters it's expecting. Here, we are not passing in the parameter. So how do I need to call it? Say hello world 1. What would happen? Nothing happens because we did not have any code in the body of the method. These slashes in here are comments. So when you put anything starting with slash slash and try to execute it, so slash slash, I am writing something in here. Nothing would happen because slash slash is start of a comment. We programmers are actually not just coders. We would want to also write books, and this allows us to write books. So int, let's say I would want to create a variable int I is equal to 10. I can say here I has a value of 10, and I can say all the stories I would want to tell about I, and that would be ignored. So don't worry about this slash slash for now. It's just a comment. The important things that we would want to focus on is say hello world. So we are able to call say hello world passing a parameter, but we don't have anything in the body of the method. So how do I add the body of the method? Either I can try and define the hello world method in here again. So I can go ahead and try and define it in here. Or the other option that I have is to use the slash edit. We learned it in the tips. So slash edit and give the name of the method, say hello world. It opens up the editor in the background. One of the things about this editor is I cannot really increase the font size. Apologies for that. I've tried a lot to see if I can increase the font size, but you know what? The font size for this is hard coded in the code for EditPad, which I cannot change for now. So what I can do is in here say hello world and number of times, right? So what should be the body be? For now, let's just do a system.out.println number of times. So what I'm trying to do is to print the number of times value that is being passed in, and I'll say exit. So it's modified the method. Let's call it again. Say hello world with 1, and now you can see 1 is printed. If I pass in 2, 2 is printed. If I say slash list say hello world, what is happening here is we are calling system.out.println with 2 as the value, and 2 what we are doing in the method system.out.println number of times 2 is printed out. That's cool, right? But what we want to do is we would want to say hello world 2 times. How can we do that? Think about it. How can we do that? How can I say hello world 2 times? If it's 3, I have to do it 3 times. If it's 4, I have to do it 4 times. 5 times. Does anything that we learned earlier strike you? Think about it. What can I do to print the hello world 5 times, 6 times based on the parameter? Yep, I would need to use the for loop. So let's go ahead and do that. So slash edit, say hello world. I'll go to the editor. If the editor is not working for you, you can also directly type it in directly in the JShell. For now, let's say for int I is equal to 0, I less than, let's start with 1. Let's not worry about 0 for now. For int I is equal to 1, I less than or equal to number of times I plus plus. As usual, even though there is one statement, let's use a brace. So followed by a brace, this is the statement that we would want to execute, and below that is the closing brace. So if you have problem typing this method in, don't worry, I'll show it right now. So I'll click exit so that this hello world is copied in here. It says modified. Let's list it again to see what's the code inside that. So you can see that the code is void say hello world in number of times. This is what we did earlier. All that we needed to do was add a for loop around this system.out.println number of times, right? That's basically what we have done until now. Let's now think about executing this method. Say hello world 2. What is happening here is 2 is printed twice because that's what we are doing. We are printing number of times. So number of times is printed 2 times. So 2 is printed 2 times. Think about it. 4. 4 is printed 4 times. So if I put 6 here, what would happen? 6 would be printed 6 times. That's exactly what would happen. Now, what we would want to do is not to print 6, but we would want to print hello world, right? So let's go ahead and edit that. So I'll say slash edit, say hello world. Let's go here, and instead of number of times, what we would want to print is hello world, and hello world is a string. So I would need to put within double quotes hello world, and I can go ahead and now say exit. Actually, what exit does is it would publish the code, so the method would be updated as well. The same as accept. Accept would also publish the code, but it would not get out of the editor. I would rather want to get out of the editor, so I'll say exit. So it modifies the method, and now I can execute, say hello world 6. Hello world is printed 6 times. Say hello world 3. Hello world is printed 3 times. 2 times. Isn't that cool? So the hello world method is printing as many hello worlds as we would like it to print. And that's really cool, right? So parameters, arguments are really cool. We will talk about the differentiation between parameter and argument a little later. For now, the most important thing is that you have created a method with a parameter. Go and celebrate, and I'll see you in the next video. Welcome back. In this video, let's look at the exercises for passing an argument. The first exercise is to create a small method. Call it print numbers. You need to pass in an argument called n and print the numbers from 1 to n. So print numbers 1, it should just print 1. Print numbers 10, it should print 1 to 10. So on and so forth. And the next method is to print squares of numbers. So I would want to print squares of numbers up to n. So 1 to n, I would want to print the squares of numbers. So go ahead and try and implement them. You can pause the video here and try and implement those methods and come back and play the video again. Now I would go ahead and implement these solutions. So print numbers, how do we do that? It should be easy, right? So all that I need to do is void print numbers. Now I would want to define an argument n. How do I do that? The way I can do that is by putting an open bracket and n. What is the type of numbers? It's what is the type of n? It's n. So n int n close bracket followed by open brace. This is the syntax, right? Return type, method name, type of the argument, name of the argument, and over here between open bracket close bracket ended by a close brace. Sorry, open. This is an open brace. And now in here goes the code for the method. I would want to print the numbers from 1 to n for 1 to n, right? It's a for loop, as simple as that. So for int I is equal to 1, I less than equal to n, I plus plus, again open brace followed by, now I would want to print the number. So system.out.println. What would happen if I print n? It would print the value that is passed. I don't want to print n, but I would want to print I because I would want to print from 1 to n. Try with n as an exercise, see what would happen. And what would happen now? The method is created. So we have created a method called print numbers of int. So you can see that now it's also showing the argument. So it's a print number and it accepts a int argument. And how can we execute the print number? So print numbers, and I can pass in the argument. So let's say I would want to print 10 numbers. How do I do that? Print numbers 10 and it prints 1 to 10. So print numbers 3, 1, 2, 3 and so on. So in this small exercise, we created a simple method. If you want to see the code for print numbers, it's very simple, right? /list print numbers. And you can see the code that we have typed in, or if you want to edit it, you can say /edit print numbers and edit whatever you would want to do. So over here is the code for print numbers. I can go ahead and change whatever I would want to change in here. That's cool. Now let's go on to the next exercise. The next exercise was to create a method print squares of numbers. So we would want to print the squares of numbers from 1 to n. How can we do that? It should be very simple, right? So instead of, let's go ahead. So I use the up arrow to navigate to print numbers. So we would want to print squares of numbers up to n, and the for loop would remain exactly the same, right? So for loop is exactly the same. System.out.println, I would need to change, instead of I, what would I need to put? I need to put I star I, right? I star I Oops, there's a small problem with how I edited it. So let's start again. So print squares of number, that's cool. For loop is cool. So let's try and type in the changed line system.out.println. I would want to print I star I and press and put semicolon. And now I can put an close brace to end the for loop and another close brace to end the method. And this method is created. Let's go ahead and execute it. Print squares of numbers. Let's say I would want to print up to 5. What would be the output? 1 to 25. Squares of numbers up to 3. 1, 4, 9. All these exercises help you to think and how to solve the problem. So I hope these are interesting, and I'll see you in the next video. Welcome back. In the previous step, we created a say hello world accepting a integer parameter. In this video, let's talk about a few puzzles and a tip regarding methods and arguments. So we have created a method called say hello world. So if I don't pass anything to it, what would happen? So I'm just passing empty brackets to it. What do you think will happen? Think about it. Pause the video here, think about it, and come back. What would happen? What it's telling is not sufficient arguments. It's saying actual and formal arguments list differ in length. Okay, it's a very complex statement if you are new to programming. What it's saying is you're passing in 0 arguments, and here there is 1 argument. So here it's 0, here it's 1, it's different. That's what it's saying. So you cannot do that. And let's say I'm trying to pass in, say hello world, and I'm passing in a string. So some string I'm sending it in. So between double quotes, it's a string. So what would happen? It says error, incompatible types. So you are saying I'm going to accept an integer. However, the value which is being sent in is a string. You can't do that. That's what it's telling me. Now let's try sending in a decimal value 4.5. What would happen? Again, error. It says incompatible types. You are sending a double to a int thing. You can't do that. Whenever we are calling a method, we should exactly meet its declaration. This declaration of this method says the name of the method is say hello world, and the next thing it says is it accepts a integer argument. So you have to call this method passing in 1 parameter. You cannot pass in 0. You cannot pass in more than 1. Let's get to the tip of this video. The tip which we would want to leave you with is the difference between a parameter and an argument. This is again some kind of a convention. When it really comes to your code, this distinction is not so important. So when we are looking at a variable in the definition of a method. So here in this declaration, there is a variable called number of times, right? This is called parameter. So in the definition of the method, you make use of the parameter declared in the declaration. However, the important thing is when we call the method, we pass in a 4, right? When I pass in 4, it's actually printing hello world 4 times, right? This 4 in here is called a argument. So we are passing 4 to the hello world. What happens? This 4 is what would come in here. So number of times becomes 4. So a number of times takes the value of 4 and we print hello world 4 times. So in summary, the distinction is that inside the code of the method, you would use parameters. And when you are calling the method, you would pass in arguments. So arguments are related to invocation of a method, calling a method, executing a method, and the parameters are related to defining or declaring a method. Okay, enough theory. Let's get back to the practical stuff. I'll see you in the next video. In the last set of videos, we discussed about how to create a method and how to pass a parameter to this method. We are now able to say hello world 10 and hello world would be printed 10 times. Earlier in the course, we created our code for the multiplication table, right? So all that we had to do was declare a int I and we typed in a loop to print the multiplication table for 5. So I is equal to 1. Think about it. Try and type the whole thing again. We would want to print the multiplication table of 5. So this is what we have done earlier. So for I is equal to 1 to 10, what did we do? We said system.out.printf. Remember it? Percentage %d star percentage %d is equal to percentage %d. And the values we pass for percentage %d, each one of them in order is, first is we would want to print 5. The next one we would want to print is 5 into 1, so I. The next one is the value of 5 into 1 or 5 into 2 and so on. So 5 into I. And we had to do a print ln to print a new line and take the output to the console. So this is what we had done. So that's pretty cool, right? So let me just quickly add in the braces because that's a good practice to follow. Let's do that. So let's add in the braces. We will get the same output. So the focus of this video is how do I create a method for this? So I would want to create a new method called print multiplication table. So I would want to call this method as print multiplication table. And as soon as I call this method, this code here should get executed. How do we do that? That's basically the focus of this video. If you want to give it a try, pause the video here and try doing it by yourself. So let's try and see the syntax for a method. List the code for it. So say hello world. That's the name of the method which we created. So this is basically the syntax of a method, right? So for starting off, let's not have a parameter. So all that I would need to do is to do something like void, give a name to this method. The name to this method would be print multiplication table. We don't really want to pass any parameters, so open bracket, close bracket, followed by open brace to start the method. And here I can put the body of the method. What do we want to do in the body of the method? We want to first have the for loop. So let's do that. Next, what we would want to do? We would want to use the system.out.printf from here. So let's do that. So I'm pasting it down here and close brace to end the for loop and another close brace to end the entire thing. So you can see now that the method is created. If you are finding it difficult to type in here, don't worry. So you can create an empty method. So you can say print multiplication table. You can create an empty method like this. Now this creates an empty method and then you can say /edit print multiplication table. And this would open up the editor in the background. So check for the edit pad and over there you can now actually go and type in your code. So what we want to do is do this for I is equal to 1, I less than equal to 10, I plus plus. One of the important things is all the variables in the method you would want to declare them right here. So I would say int I is equal to 1 and next we would want to do the printf. So printf and we would want to make sure that the formatting is good and now close brace and now this is much better formatted. So you can see the entire method right now. So it's print multiplication table, the for loop and the entire system.out.printf followed by the close brace and the close brace for the method. So be careful with the close braces. This is the open brace for the method. This is the open brace for the for loop. So this is the close brace for the for loop and this is the close brace for the method. And make sure that you have a open bracket, close bracket, because that's how we define a method. That's part of the syntax of the method. And now I can go ahead and say exit. And now you'd see that the method is modified. And now if I execute print multiplication table, what would happen? It would print the multiplication table. Isn't that cool? So now you can print the entire multiplication table just by calling the method. The next thing we want to do is we would want to be able to say print multiplication table of 6, and I would want to be able to print the multiplication table of 6. For now we are using 5 as the default, but going forward I would want to create a method which would be able to have a parameter. I would want to be able to say print multiplication table of 6, and I would want to be able to edit it. How do I do that? You can actually try it as an exercise, and I'll see you in the next video. In the previous video, we created the print multiplication table method. This is the code which we wrote in it, right? The code, the for loop, we moved it into the method. So into the method syntax. That's cool. Now, what we want to do now is we would want to actually be able to call print multiplication table with a parameter, and I would want to use this 6, which is being passed to decide the table. Instead of the 5 table, I would want to print the 6 table. If I'm passing 10, I would want to print the 10 table. So that's basically what we would want to do. So let's go ahead and start creating that method right now. So I'll say /edit print multiplication table. That would open up the editor in the background. So let's go ahead and take that. And to this, we would want to add a argument. So the parameter which we are passing in from the method call, we would want to be able to accept it into an argument. What should I do? I should create an argument in here, right? So int table. So I'm creating the int is the type because I would want to be able to accept 1, 2, 3, 4, 5. So I put int as the data type, and the name I'm giving to that is table. So over here, in here, instead of 5, I would need to put table in. So table instead of 5, table. See how variables make it very easy. I'm replacing a literal with a variable, and what happens now? Whatever input is passed to this method is now used here. So this would be used, and the entire thing becomes very dynamic. Let's now click accept, and you can see that the method is created. You can click exit now. So now we have created the print multiplication table accepting a int. Let's see what would happen if I say print multiplication table with a parameter of 6. Cool, it's now printing 6 table. Let's print 7 table as well. You can see that it's printing the 7 table as well. So whatever concepts we learned earlier, we are now able to bring them and apply it to the multiplication table. One of the important things you can try right now is you can say /edit multiplication table, and if you see the opened up editor, it now contains 2 methods. So we have the method print multiplication table, which does not accept any parameters, and we also have the print multiplication table which accepts 1 parameter. So the result of this is that when I do an exit and I can say print multiplication table, I can call this method without a parameter that by default prints the 5 table, or I can pass a parameter as well. This is called method overloading. What are we doing here is we are creating 2 different methods with the same name with different parameters. For 2 different methods doing very similar kind of thing, what we are doing is we are giving the same names, and the only difference between these 2 is the parameter. This is called method overloading. This is a very important concept in programming in general. Overloaded methods are really good because you can provide defaults. So you can provide a method called print multiplication table in table, and by default somebody might be able to call print multiplication table and it would print the 5 table. Congratulations! Now you have a method which you can go and share with your friend. So you can say, okay, give your friend this code and say, okay, this is my multiplication table. go ahead and use it. Use it to print whichever table that you would want to print. All that you would need to do is to call print multiplication table followed by a parameter indicating what table to call. I'll see you in the next video. Before we end this section on methods, there are a few important concepts that you would need to learn. The two important concepts are multiple parameters and return values. In this video, what we'll focus on is passing multiple parameters to a method. Until now, we have created methods with one parameter or no parameter. So here we used one parameter, and we also created methods having no parameters at all. But in our previous sections, we made use of few methods which accept multiple parameters. Math.max 1, 2. What does that print? It prints 2. So over here, we are passing in two parameters, and it's actually returning a value, and the value is being copied out to a variable. Let's not worry about that part right now. Let's focus on passing multiple parameters to a method. Let's say I would want to create a simple method to find out the sum of two numbers. There are math methods for doing that. There is also a simple operator to do that. I know that, but this kind of is a very simple example to give you the concept of multiple parameters. So I would want to pass in two numbers, and I would want to create a sum method which I should be able to call like this. So I should be able to call sum 1, 2, and it should print 1 plus 2, 3 to the output. You can stop the video in here and you can try to do it as an exercise on your own. The clue is a comma in here, and you are also seeing the syntax of the method in here, right? It should be simple. Think about it. What should be needed to do sum of 1, 2? Try and do it as an exercise. Pause the video here and come back. Okay, I hope you got it right. Let's do it quickly. So void sum. Sum is the name of the method that we would want to give. I'll say int first number, comma int second number. The name of the variables I use are a little longer. I want to be really clear about what we are doing. So I'll keep it longer. You can call it A, B, or number 1, number 2. Now, what we would want to do is we would want to find the sum of these two numbers. So I can create a variable int sum is equal to first number plus second number. This is one of the ways you can do that. And next, I can go ahead and do a system.out.println. What do we want to do? We want to print the sum. Oops, I missed the T in here. So it's system.out.println sum, press enter again, and close brace. Okay, created method sum, which is accepting two parameters, int and int. Now you can go ahead and call this method sum of 1. Will it work? Nope, it will not work because you are passing only one parameter. It's saying I'm expecting two parameters. Why are you passing me only one? Let's call it with two parameters. Sum, 5, 10. What would be the output? 15. Cool. So we are now able to successfully create a method which accepts multiple parameters. I would want to create another method sum which accepts three parameters. So 5, 10, 15. Now, you can do that as an exercise. Pause the video in here. Okay, I would get an error if I execute it right now. So I'll go ahead and now type the syntax for that. So let's start with this. So sum of int first number, int second number. Now to this, now need to add int third number because we would want to add three numbers. And our sum, whichever we created earlier, it's no longer sum of just two numbers, right? It's now third number also needs to be added in. And system.out.println remains exactly the same, and close bracket. Created method sum int, int, int. Cool, right? So now I can execute the thing which I would want to execute. 5 plus 10 plus 15 is 30. Isn't this cool? Creating methods is a lot of fun. I think methods is one of the most important parts of programming, and that's the reason why we are creating a number of methods so that you get used to the syntax, get used to, more importantly, the thinking in methods. So one of the most important things about a programmer is you should not write 1,000 lines of code one below the other. It's more about how do you organize those 1,000 lines into proper methods and proper classes. We'll get to the classes part a little later. For now, we are focused on organizing your code into methods. Good luck, and I'll see you in the next video. Welcome back. In this video, we would start discussing about the return value of a method. When we executed math.max of 4, 5, what is happening here is 5 values returned, and it is actually creating a variable. So if you do $110, it's actually a variable. And actually, I could actually take the value into a variable in here. So I can say int max is equal to math.max 15, 25. What would happen then is the return value of this method, whatever value this method is returning, is copied into the max method. Whatever is the return value for this method is copied into the variable max. Now, we created a method earlier. We called it sum. When we call sum 1, 10, it actually puts 11 out to the console. But the important thing to note is there is no variable that is being created. If I do a list sum, I can see the two sum methods, right? So one with 2 parameters and the other one is 3 parameters. So the one with 2 parameters, let's look at it. You'd see that system.out.println sum. So what we are doing is printing the value of the sum to the output. That's the reason why 11 is printed. So when I call sum 1, 10, it's printing 11. Now if I try and take it to a variable, so here we are taking it to a variable, right? Int max is equal to math.max 15, 25. Let's try to do that with this. Let's say int sum is equal to sum of 1, 10. What is it saying? It's saying incompatible types. Void cannot be converted to int. What is happening in here? What is happening in here is that this method is saying I'm not returning anything back by saying void. So because it's a void method, it's not returning anything back. What we want to do is we would want to return values from the method, right? So let's now focus on how to create methods that return values back. The method to return the computed value of the sum is very similar to the method in here with a small difference. Let's look at the differences first. So here the first thing is we are returning a type void, right? So void means I'm not returning anything, but we would want to return an integer. So sum of two numbers will be an integer. So sum of two integers will be an integer. So we would return an integer back. The second thing is that you would want to return the calculated value of the sum back. So over here we are saying int. That means this sum method would return a value of int. So I have to make this method return the computed value of the sum. So that's the syntax of the return statement. The third important thing is the fact that the name of this method cannot be sum. We will talk about that during the puzzles, because we already have a method with the name sum and accepting these kind of parameters. We cannot create another method which just has the return type different. If this sounds complex to you, don't worry about it. We'll discuss that in depth during the puzzles section. For now, we would want to give it a different name. So let's start with creating the syntax for that. So int, I'll call it sum of two numbers. So in sum of two numbers, let's accept the same parameters, first number, comma, int, second number. Right? That's exactly what we have in here. Except that here I have a int, and let's finish with a open brace. The next line of code is exactly the same. We would want to find the sum of, so int sum is equal to first number plus second number, and followed by a semicolon, because the statement we end it with a semicolon, and followed by, what we want to do here is we don't want to do a system.out.println of sum. We don't want to print the value of sum. We would want to return the value of sum. The way we would do that is return sum and close brace. As simple as that. I can now call this sum of two numbers 1 comma 1. Let's see what would happen. You can see that a variable is being created. That means this is returning a value. I can say int sum is equal to sum of two numbers 1 comma 1. You can see that sum now has a value of 2. That's the sum of 1 and 1. If you want to change it, you can say 15 comma 15. Sum now has a value of 30. So what we are doing in here is we are computing the result of sum of numbers and returning that back. Congratulations, and I'll see you in the next video. Welcome back. In this video, let's look at the exercises for return values of methods. This will help us re-emphasize the return value concept much more. So we'll do two simple exercises. One method to return sum of three numbers. So we already calculated sum of two numbers. Write a method to return the sum of three numbers. The second one is much more interesting. So given two angles in a triangle, so you are given two angles in a triangle, you need to find out what is the third angle in the triangle. The hint is sum of angles in a triangle is 180. We already looked at this in a video before. So sum of angles in a triangle is 180. So given two angles, try and find the third angle. So these are the two simple exercises I would recommend you to do. You can pause the video and try solving the exercises before looking at the solutions. I would start with the solutions now. So method to return sum of three numbers, right? This should be quite a simple one. So sum of three numbers, it again returns a integer. So I'll say int sum of three numbers. I need to have three parameters, right? Int first number, int second number, int third number. As simple as that, followed by a close brace, right? Now, after this, you can type in the next one. What should it be? I have to calculate the sum, right? Int sum is equal to first number plus second number plus third number. And what should I do now? I have to return the sum back. As simple as that. Return sum and close it out, right? Modified method sum of three numbers. Let's now execute it. Sum of three numbers 1 comma 2 comma 3. Awesome. So it prints 6, and you can try with a few other numbers and you would see that it's perfectly returning the value back. That's cool. That's sum of three numbers. The next one is much more interesting, right? Given two angles, write a method to return the third angle. When you have to create a method, always think about three things, right? What are the inputs? What are the outputs? Or what is the output? There should be one output from a method. Multiple outputs are not allowed. So it's one output. And the third one is what is the name of the method, right? So for this method, there are two inputs, right? Angle 1, angle 2. What should be the type of them? For now, let's start with an int. Let's keep things simple for now. You can also use a short, because angles of a triangle are maximum 180, or actually angle in a triangle cannot be 180. It should be less than 180. So a short should usually be sufficient, but let's take a int. And output is also a int, right? You would find the third angle, which is a int. And let's give the name of the method as calculate third angle. So let's get started. Return type is int. Name of the method is calculate third angle. I would want to pass in two parameters, right? So int angle 1, int angle 2, and followed by the open brace. And now I would want to calculate the third angle, right? Angle 3 is what I would want to calculate. How do I do that? Pause the video in here and try to think about it. How can you calculate the angle 3 given the fact that angle 1 plus angle 2 plus angle 3 is 180 degrees, right? So the way I can do that is 180 minus angle 1 plus angle 2. And now I can return the calculated angle 3 back. Now you have created the method calculate third angle. Awesome. Now you can go ahead and say calculate third angle 20 comma 20. It says 140 is the third angle. So 140 plus 20 is 180. Awesome. So that's the method to calculate the third angle in a triangle. I hope you are finding these exercises very interesting. Methods is one of the important concepts that you need to understand in depth. Even further during the course, we'll talk about a lot of different things related to methods. Whenever we are programming, 95% of the time you are writing some code inside a method, and that's the reason why we focus on the methods a lot. We focus on writing great methods. Great methods have great names, the right inputs, and the right output. If you look at any of the methods that we have created until now, all that you need to do is to look at the name of the method. You don't really need to look at the logic of the method. You can look at the name of the method and decide what it's doing. So it's saying calculate third angle. Once you look at the name of this method, you know this method is going to calculate the third angle. So we'll see how to make it even more clearer in the subsequent sections. Until the next video, bye-bye. Welcome back. In the previous set of videos, we discussed a lot of different things about methods. In this video, let's revise some of those important concepts. What we are doing in here is we are defining a method. So what we are saying is the name of the method is this, it accepts parameters, and we say this is what the method does. So this is called the name of the method, this is the return type of the method, and inside the method these are called arguments, and this is the body of the method. So these are things which we learned earlier, as well as when we call the method we pass in something called parameters. So this 20 comes in here to the angle, and this 20 comes in to here to the angle 2, and what we are doing is we are using those values, calculating it and returning it back. So we are using a return statement to return the value back, and that value is what we are seeing, which is printed in here. One important thing is once you create a method, it's not executed. Once you define a method, it only establishes the definition of a method, what it does, how you can call it, what are the different arguments, what is the return value. If you really want to execute the method, you need to call it. So this is called a call. This is called calling a method, invoking a method, or execution of a method. We also discussed that you can have no parameters in a method, so you don't really need to have parameters to a method, or you can have one or multiple parameters. One of the important things is from a method, you can only return one value back. So you cannot say I would want to return angle 1, angle 2, angle 3. You can only return one calculated value back. So here the calculated value that we are returning back is angle 3. Okay, those are all the important things that you need to know regarding methods for now. I hope you had a great time learning about methods and discussing wide variety of things around methods. As an exercise, think of problems around you and think if you can create a useful method. Think about it, try and create a few methods, and I'll see you in the next section. Until then, bye-bye. JShell is an awesome tool to get started with Java programming. You get immediate feedback, so you learn very fast. In this section, let's move out to the Java world outside JShell. To run a program outside JShell involves multiple steps. You need to compile the code, you need to execute it, And you need multiple tools as well. There are concepts like JDK, JRE, and people say Java is platform independent. The focus of this section is on helping you understand what is a class, how do you compile it, how do you execute it, why do you need to compile it. And there are a lot of terms that we use when we talk about Java platform, JDK, JRE, JVM, platform independence. What are all these about? That's basically the focus of this section. I'm sure this section would be as much fun as the previous section. I'll see you in the first video. Welcome back. In this video, let's get an overview of what is involved in compiling and executing any Java code you write, and also getting introduced to an important concept called platform independence. This would be an introduction section, and over the course of this section, we will review the same thing again and again to make sure that you get in-depth knowledge into everything in this picture. Let's start with the basics. What do you think computers understand? All that computers understand are zeros and ones. These are called basic instructions. For people who have worked with assembly language, they would have constructed basic instructions using zeros and ones and written programs using that. That's basically what the operating systems would be able to understand. At the basic level, whether you are running Java program, .NET program, or any other language program, finally what would happen is they would get converted into the instructions for that specific operating system. The zeros and ones for that specific operating system. So the instructions for Windows would be different from the instructions for Unix, which will be different from the instructions for Linux or any other operating system. Now, we are writing some Java code. This Java code that we would write, we would want it to work on all the different operating systems. That is what is called platform independence. Once I write some Java code, I would want it to work on multiple operating systems. However, the problem is that the instructions for each of these operating systems are different. How does Java solve the problem? Java brings in an intermediate representation. So Java says, okay, there are operating system specific instructions, zeros and ones. I would create something on top of it, which is common across all operating systems, and it is called byte code. So this byte code is a format which is common irrespective of the operating system. These operating systems don't understand byte code, they only understand their basic level instructions. Now, how do you convert the bytecode to the instructions? That's where the JVMs come into picture. Java Virtual Machine. Java Virtual Machine is a piece of software which would convert the bytecode into the specific instructions of that operating system. Windows JVM will be different from a Unix JVM, which will be different from a Linux JVM. So these are all JVMs for a specific operating system. What they would be able to do is they would be able to take the bytecode and they would be able to convert them into executable instructions on that specific operating system. So how did Java solve the problem of platform independence? By coming up with a concept of bytecode, which is like an intermediate format, and by creating JVMs which can convert the bytecode into instructions of that specific operating system. When we write Java programs and we would want to execute them, what we would need to first do is something called compilation. During the compilation of Java code, what we would get is bytecode. You can use the bytecode which is generated to run the program on the specific operating system. This is called execution. So there are two phases, compiling and execution. During execution, we will use JVM to convert the bytecode to instructions and run the program on the specific operating system. So in summary, if I would want to run Java code outside JShell, then first thing is I would need to compile it, then I would need to run it. The other important thing is platform independence is achieved in Java through bytecode and JVM, platform specific JVMs. This video is to give a big picture of the whole thing. During this section, we will review this picture multiple times to make sure that you understand it completely. In the next step, we would get started with writing our first Java class. Welcome back. In the previous step, we got a big picture overview of how the Java platform works. Before we would be able to compile any Java code, we need to create something called a class. In this video, we will introduce you to the concept of class and objects and create a very simple class. What is a class? The way you can look at class is like class is a template. So you can use this template to create multiple instances of the class. For example, you can consider country as a class. So you have a class named country and you can have multiple instances of this class, right? So India is a country, United States of America is a country, Netherlands is a country. So country is class, it represents a class, and there are multiple instances of this class. These are what are called objects. The syntax to create a class in Java is very simple. It's class, class name. So we would want to create a class named country. So class, country, and as usual, any of these things, methods, classes, you'd start with an open brace. So you need a block of code. So that's where open brace comes in. And between that, you would actually add in a number of methods. For now, let's not worry about methods, and let's put in a close brace to end the creation of the class country. You can see that now it says created class country. Earlier, when we talked about primitive data types, we said, okay, you can declare a variable using int I, right? Similar to that, a class becomes now something related to int. So int is something called a primitive data type. It's something which is already defined in Java. Now country is something which you are defining. You are defining a type called country. I would want to be able to create instances of this class. How do I create instances of a class? The syntax is very simple. So country, name of the variable, that is India, is equal to new country. So the syntax is name of the class followed by the instance names. Here the instance name I'm giving it is India, is equal to new country. Okay, it says a new instance is created and it says where it's stored in memory. This is something called a two-string representation. We'll talk about it a little later. But for now, the important thing is that you're creating an instance of the country class called India. And this India in here is an object. India is an object of type country. So type or class both refer to country. Let's see how I can create multiple instances, right? So country India is equal to new country. Now I can say country USA is equal to new country. This would create another instance of the country class. What we are doing right now is creating a class. Class is like a template. So using this template, I can create multiple objects. Typically in classes, you will have data, you will have methods, and the methods can be used to perform actions on the data which is present in the class. We'll talk about those concepts a little later. For now, Let's try and make sure that we understand the concept of a class and then object. A class is a template and objects are instances of that template. So we have created two instances of the class country. You can pause the video here and try and create a new class called planet. So create a class called planet and try and create two instances of it. Maybe Earth, Mars, Venus, or if there are other favorite planets of yours, try and create them. Okay, let's go ahead and create the planet class right now. So the syntax is very simple, right? Class, planet, followed by an open brace, followed by a close brace. And now I can create instances of planet by saying planet is equal to new planet. Or actually, I should have created planet Earth is equal to new planet, or I could have named it planet Venus is equal to new planet. The idea behind this video was to give you an high-level picture of class and object. We will really dig deeper into classes and objects in this section related to object-oriented programming. For now, it's important to understand that class is a template and you can use the template to create instances and you can create multiple instances of the same class. I'll see you in the next video. Welcome back. In the previous step, we created a class called planet and we were creating two instances, two objects of the planet class. In this step, let's create a simple method in the planet class. Let's say we would want planet to revolve. So for each of the planets, I would want to give it a feature to revolve. So what do planets do? They revolve around the sun. So I would want to have a method, an action called revolve in the planet class. How do I do that? It's very simple. So class planet, this is basically what we started off with. What we now need to do is define the method inside the class. So we have the class and now we can define the method. For now, I would choose a simple void return type and say revolve and close brace. This is typical syntax of the method. For now, let's not do a lot of logic in here. I'll just say system.out.println and revolve and press enter, close brace, close brace. That's it. You can see that a new definition of the planet is created. However, one of the important things to note is all the existing variables of that class will be reset. So they are all reset and they will not have a value. So what we need to do is recreate the instances of that class. So I'll create Earth again and I'll create Venus again. So we redefine the class now. The class has a method called revolve. Now I would want to call the revolve method. How can I call the revolve method? Think about it. How can I call it? Planet dot revolve. Do you think this would work? Planet dot revolve. It says non-static method revolve cannot be referenced from a static context. This error sounds a little complex. Don't worry about it for now. For now, the most important thing to understand is normal methods, you would not be able to execute them from outside the class just by using a class name. To execute a method inside a class, a normal method inside the class, you would need to use objects. What we would need to do is we would need to use an object that is an instance of the class. Here we created Earth. So now I can say Earth dot revolve. Let's see if this would work. Now it prints revolve. Now I can say Venus dot revolve. Cool. Now what we have done now is we have added a method to the class. You can think of method like the actions that you can perform on instances of that specific class. So what I'm doing is I'm creating two instances and I'm making them revolve. I'm making them perform an action. Methods define actions that can be performed on classes. And to invoke a method which is present inside a class, we would need to use an object. You can pause the video now and you can try and implement a coming soon method which prints coming soon inside the country class. So let's have the country class and take it and add a method. The name of the method should be coming soon and it should print a string coming soon to the output. Create that class and invoke the method on two instances of that class. Let's say India and USA or any favorite countries of yours. Now let's try and solve the exercise right now. So the way I can do it is I can say class country followed by a open brace followed by the definition of the method, right? So I would want to say void coming soon. And what do we want to print? System.out.println. Inside that I would want to print coming soon. This is basically that there are actions that will come soon on those specific classes. So it replaces the country variable and invalidates all the existing variables. Now I would create the variables again. Country India is equal to new country and country Netherlands, one of my favorite countries. I've lived there for a few years, is equal to new country. And you can call India dot coming soon and Netherlands dot coming soon. Cool. Now let's get back to the big picture. What we have done until now is we have defined a class. A class is like a template. Inside the template we defined actions that can be performed on the objects of the class. So we defined a method called coming soon. So we created two instances which are called objects, and on the objects we call the method coming soon. Hope you are having a lot of fun and I'll see you in the next step. Welcome back. In the previous step, we created a couple of classes with methods each, and we also created instances of these classes called objects. What we wanted to really do here in this section is we wanted to take the Java code outside JShell. The thing about JShell is as soon as you write the code for a class, it would compile it. But outside JShell, you need to do all that on your own. The first step for that is to move our Java code into a file. So we would want to actually start moving the Java code into a file and we would want to compile it. So we would want to create the bytecode from the Java code. That's the first step we would want to focus on right now. What we'll do now is we'll create a file. If you do a /list country, then it would show the code that we wrote for the country class. If you do a /list planet, it will show the code that we wrote for the planet class. So what I would want to do is I would want to copy the code from this to any text editor of your choice. So open up Notepad, open up edit text or any text editor of your choice and copy the code in. The formatting is not really important. Make sure that you have the methods perfectly there. So over here we have a class planet. Inside that we have a void revolve method which is printing system.out.println revolve. So we just copied it as it is. There's nothing specifically great about this, and I will save this file. So I'll save this file to a folder on my hard disk. So what I'll do is I'll save it to in 28 minutes, Git, that's where all my code goes. And in here, I have a folder called Java for Beginners. So in Java for Beginners, I would want to save this file as planet.java. It's very important. The class name should match the file name. So planet.java is what your name should be. So save it as planet.java. This folder can be anywhere on your hard disk. It doesn't really matter which folder you are putting this file in. The thing that matters is that you should know which folder you are saving it to. The file is saved out, so planet.java is now created. And now let's see how to compile this. So what we have done now is we created a Java file. So the class is inside a Java file, and now we would want to compile this Java file. Now I would need to exit out of JShell. Before you exit out of JShell, make sure that you take backup of any of the code that you would want to save. You can use /save and give a file name to it and press enter. This would save all the commands that you have executed as part of this session. Make sure that you save it and then go ahead and exit it. So now I'm exiting out of JShell. What I will do now is I'll cd to the folder. So we created it in 28 minutes, Git and Java for Beginners. So make sure that the case is right, and now I'm inside the Java for Beginners folder. So I have cd'd down to the cd's change directory. So I've done a cd to the directory where we created the planet.java file. So if you do a dir or ls on Mac, dir on Windows, you'd see planet.java in here. The important thing to make sure is this planet, the case matches exactly. So planet, right? So that's important. The class names always start with a capital letter. And so your file name also should start with a capital letter. Let's check if I have Java installed in here. So Java-version, that's cool. So we have Java 9.0.1 running in here. And now I would want to compile this planet.java. How do I do that? I just need to type in javac planet.java. Okay, I did not get any error. It just went through fine. Let's now do a ls again. Now, when I do an ls again, you would see a new class that is being created in here. This is called planet.class. So this planet.java is now compiled, and now we have a planet.class. Isn't that cool? This class file is what contains your bytecode. So the bytecode is present in this class file. As an exercise, I would recommend you to try creating a country.java and try compiling it too. If you had problems with compiling the planet.java, make sure that you have the right version of Java installed. Java 9, any version of Java should be fine for compiling, but we would want to use Java 9 in this course. So make sure that you have Java in here, and also make sure that the name of the class, the name of the file matches the name of the class, and also you're using the syntax exactly as it is in here. So it's class with a C small, planet with a capital P, you have an open brace, close brace, and between that is the method. Make sure that you have the exact syntax as it is in here, and you should not really have a problem with compilation. Now that we have compiled this class, in the next step, we would want to run it. Let's see how that would go. Until then, bye-bye. Welcome back. In the previous step, we compiled planet.java. In this step, let's see how to run that program. So I would want to run code in planet.java. How do I do that? Can I type some code at the command prompt or the terminal prompt? Actually, not. That's not something which would be allowed. Let's try running it. How do I run a program? The way you can run a program is by calling Java followed by the name of the class you would want to run. Let's say I want to run planet class. So let's try this, Java followed by planet. The most important thing is Java planet would use the planet.class file. Once we have compiled the planet.java, we got the planet.class, and the Java planet would try to run the planet.class. Now, what does it say? It says main method not found in class planet. Please define main method as public static void main. That's one of the most important things when you are trying to run Java programs outside JShell. You have to follow a lot of rules. We have to compile it, we have to run it, and to be able to run it, we need to have a public static void main. So let's try and copy this. So I'm going to copy this. So I'm going to do a right click copy, right click and copy. So it's public space static space void space main, and it's a string array of arguments. I'm going to go to the text editor. We have the revolve method in here. So just below the closing brace of the revolve method. So I'm just going below the closing brace of the revolve method and pasting in the syntax for the main method. So public static void main. So we know what void is, right? So void, it means this method does not return anything. Main is the name of the method, and these are the arguments. So we know this is string, right? So this brackets here, square brackets, represent the fact that this is an array of arguments. We'll talk about arrays a little later. For now, don't really worry about it, and don't really worry about the public static here as well. We'll talk about public static and array a little later in the course. For now, let's focus on getting this code running. So now we have a main method present. So will this solve our problem? Let's look at it right now. So let's say Java planet. Aha, it says main method not found in class planet. Pause the video here, think why this is coming. There was something I told you before, which is the reason why this error is still coming. Okay, the reason why this error is coming is because, as I said earlier, planet.class is what is run. So planet class, so to get planet.class, we need to compile again. So we need to take the code, we made the change in planet.java, but we did not compile it. So let's compile it again. How do I compile it? Java C planet.java. What would happen now? The new planet.class would be generated, and now I can execute Java planet. Nothing is happening. So you see that it's empty. So when I type in Java planet, nothing has happened. That's because inside the main method, we did not write any code. In the main method, it's empty code. So there is nothing in here. That's the reason why nothing has happened. So in the main method, what we would want to do is to write the code which we usually write in JShell. So in JShell, we created an instance of the planet and called the revolve method. Let's type in planet is equal to new planet. If your IDE is not giving you auto suggestions like this, do not worry about it. We'll be using an awesome IDE called Eclipse. We'll learn about it in the next section. For now, let's go ahead and type it. So I've created a new instance of the planet. Why am I calling it planet? Let's call it Earth. So Earth, and let's go ahead and say Earth dot revolve. So in the main method, you need to write the code which we typically write in JShell to execute something. So when I'm writing a class, I need to put a public static void main with a string array arguments. If I want to run some code, the class which I am running should have this method. And inside that, we can write whatever code that we would want to execute. Here I'm creating an instance of the planet and I'm saying revolve. Let's go ahead and run it. Java planet, will it work? Think. Nope, nothing is coming in. Why? Yep, I did not compile it. So let's compile it and then run it. Now you see revolve being printed out. Awesome, right? So what we are doing here is we are compiling using Javac, and when we do Java and the name of the class, it's running it. So we are using the JVM to run the instructions. In the next video, let's dig deeper into the big picture of running Java programs. Until then, bye-bye. Welcome back. In the previous steps, we learned how to write a separate Java file, how to compile it, and how to run it. In this video, we will take a look at what could go wrong. One of the important things is the syntax of the main method. The syntax of the main method should exactly match what you are seeing in there. So it should be public static void main with a string array as the arguments. Let's say I'm changing the name of the method to main1. What would happen? Let's do a Javac, planet.java. We compile it and then run it. So you can say that it says, okay, I don't find a main method in here. The syntax should exactly match what's in here. So even if you remove, let's say, something like static or public, you would start getting errors. So make sure that the main method is exactly as it is in here. Once you follow this, when you do a Java and execute this, that would work fine. So let's check if it's working fine. Javac and Java. Oops. Let's make sure it's saved. Javac and Java. Okay, it prints revolve. That's cool. Now, let's see what other things can go wrong, right? So these are different statements. In Java, in the Java files especially, you'd need to have semicolons after every statement. Otherwise, you would get a compilation error. This is what is called a compilation error. You can see how the Javac is telling what are wrong. So it's saying, okay, line 8, this is wrong. Line 9, this is wrong. There is a semicolon expected. So that's as specific as it would get. Let's say instead of new planet, I made a spelling mistake and I did new plane. What happens? It again gives me an error. It says plane. What do you mean by a plane? I have no idea. Try and play around with this class, try and make changes to it and see what errors you would get. One of the important things that I suggest to all learners is that the best time to play with something is when it's working. So this code is working, so try and break it and see what error gets generated. That's the best way to learn, in my opinion. Now, if I'm calling a method which does not exist, revolve1, Javac. Okay, it says there is no method called revolve1. Cool, isn't it? So try and play around. So whenever you compile the code, you'll get an error if there is something wrong with this. Another important thing that you need to remember is that if your editor is not showing the colors, that's not a problem. So the void here is highlighted in red and revolve in green. It's a string which is highlighted in green. All the keywords are being highlighted in red. Do not worry about it. We will look at Eclipse a little later. We'll install Eclipse and use it later, and you'd be able to also follow the same thing. The last important thing to note is the difference between JShell and doing it in the typical Javac and Java way. In JShell, as soon as you create your code and type it in, it's compiled. And if you are actually executing a statement, you'd see the output. And you can directly run the method directly there, call the method, run it, and you'd be able to see the output. However, in the case of a Java file, you need to have a main method to be able to run it. Before if you make any change, revolve again. If I'm making a change here, then I have to make sure that I'm compiling it, and only then my change will be effective. So only then the revolve again would be effective. If I change it back to revolve and Java Planet, it says revolve again because I did not compile it. So only when I do a compile, the change will be picked up. This is something you need to remember. I'm repeating this a couple of times because this is one of the common mistakes that beginners to programmers make. The last important thing is the fact that you should be in exactly the same folder where the planet.java is to be able to execute Java C, right? So here if I do a ls on Unix, or if you're doing dir on Windows, directory command dir, then you should be able to see the planet.java. Only then you'd be able to do a Java C planet.java. And after that, you can execute it very easily by using Java Planet. In this video, we discussed a few tips and tricks regarding compiling and executing Java programs. In the next video, let's revise the entire big picture before ending this specific section. I'll see you in the next video. Welcome back. Now that you have compiled and run a Java program, you are ready to understand the differences between JDK versus JRE versus JVM. If you look at this picture, all the JVMs are in here, right? So whatever code we have compiled, the JVM would be able to take it and convert it into the instructions that the operating system understands. So the Windows JVM would convert bytecode to instructions that Windows operating system can understand. So that's the role of the JVM, Java Virtual Machine, converts bytecode into instructions that are understandable by the operating system and executes them. In the previous example, when we were running the program, we were actually using the JVM when we typed in Java and Planet. We were trying to execute the program in here. This is where we are making use of the JVM. So we are taking the planet.class, which contains the bytecode, and executing the program on my machine, which is on Mac, and we are getting the output as revolve. This is because the bytecode here, the JVM is converting it into a thing that the Mac operating system is able to understand and print revolve. That might sound very complex, but very simply, when you run Java and give a class name, what happens is the JVM is executing that code based on the bytecode. And to be able to do that, the JVM converts bytecode to the machine instructions that are understandable by the operating system. So in summary, JVM runs Java bytecode, as simple as that. Nothing more, nothing less. You give it bytecode, it can execute it, as simple as that, right? So now, what is a JRE? JRE stands for Java Runtime Environment. Java Runtime Environment. And Java Runtime Environment is nothing but JVM plus all the libraries related to Java, right? So when we talk about any Java program, it would need a few inbuilt Java classes. In our planet.java class, we are making use of system.out.println. Where is that system.out.println defined? That's in a Java library. Whatever you need, whatever Java libraries, whatever Java classes that you would need are what are part of this in here. So JRE, Java Runtime Environment, is nothing but JVM plus all the inbuilt Java classes. Now, let's look at what JDK is all about. JDK is JRE, so it's JVM plus the Java libraries plus all the compilers and debuggers. So all the stuff that is needed to develop Java programs, compile Java programs, plus the stuff which is needed to run Java programs. So the way you can look at it is JDK is needed to develop and run Java programs, JRE is needed to run Java programs, and all the Java programs run using something called a JVM. Let's look at an example to understand this further, right? So we have two classes in here, planet.class and planet.java. Let's say I'm giving planet.class to my friend and he's using Windows operating system. What does he need to run the planet.class? Once I have a planet.class, all that I need to do is to do Java planet, right? To be able to do this, I don't need a compiler or a debugger. If my friend has the JRE for that specific environment, so JRE for Windows, then he should be able to run the class file. Let's say I don't give him the class file, but I give him the Java file. Will he be able to run it? with a JRE. With a JRE, you'll not be able to run planet.java because you would need to first compile it. You need to do Java C. And compiler is only present in a JDK. So in the Java development kit. So my friend would actually need a JDK. So in this course, we are actually developing Java programs, compiling them, executing them, and all that. So we will use a JDK. And if you have friends who want to run the programs which you have created, then you can give the compiled class files to them and they can run it using a JRE. So if you are an application developer, you need a JDK. If you are an application user, then you would just need a JRE. The JVM is part of both JRE and the JDK. JVM is the fundamental thing that runs a Java program. It converts the bytecode into the instructions that are understandable by your specific operating system. Congratulations! In this section, what we have done is we have written a Java class, we compiled it, executed it, and we understood what is the difference between a JRE, JDK, and JVM, along with understanding the concept of platform independence. We understood that platform independence is a result of an intermediate format called bytecode. We also understood the difference in running instructions on JShell versus without using JShell. Until the next section, bye-bye.
Welcome to this video where we would help you install Eclipse. Eclipse is one of the most popular open source Java IDEs. One of the important things is we would want to use the latest version of Eclipse. So use Eclipse Oxygen, which is 4.7 star or later. The prerequisites to be able to install Eclipse is Java JDK 9. So make sure that you have JDK 9 installed. Installing Eclipse is actually very simple. All that you need to do is type in download Eclipse into Google and you should be able to go in to the first link. Once you launch up that web page, you should be able to see very simple screen like this. By default, based on your operating system, the downloads would already be present in here. Typically, there are two options for downloading Eclipse. One is Java and the other one is Java EE. Java is for pure Java and Java EE is if you'd want to develop Java EE based applications like web services, web applications, JSP servlets, or if you want to develop applications with Spring Framework and Spring Boot, for example, then you would go for the Java EE. So make sure that you have the right operating system which is selected in here. Make sure that you're using an Eclipse version which is at least greater than 4.7. Once you click the link, the download would start, and the important thing is the download would actually download a simple zip file. Once the download completes, extract the zip file to a folder. Once you go to that zip folder, you can execute Eclipse by double clicking it and this should launch up. Make sure that you are using an Eclipse version which is at least Eclipse Oxygen or greater, and it should launch up asking you for a workspace. Once you see the screen, then you should be really happy. You have successfully installed Eclipse and you are ready to move on to the next steps in this course. You can find more details in this link which is present in the PDF. The other thing you can do is if you are having a problem with installing Eclipse and launching it up, sometimes the Windows built-in decompression utility has a problem, so try and use 7-zip to decompress the zip file. The second thing you might be having a problem is if you are unzipping it to a long folder path. So instead of downloading it to C:\program files Eclipse, you can directly unzip to C:. If you still have a problem, then this link in the PDF should help you to troubleshoot any problems with Eclipse. I hope you had fun installing Eclipse. This is kind of a routine thing that you would need to do, but I'm sure Eclipse would be making all the effort that you put in installing it worthwhile. I'll see you in the next video. Until then, bye-bye.
Welcome back. In this video, let's launch up Eclipse and create a new project. When you launch up Eclipse by double clicking the exe or by pressing Command space and typing in Eclipse on Mac, after a little while, you should see a window like this. The first thing Eclipse asks for is the folder where you'd want to store all your code and projects into. It's called a workspace. Eclipse uses the workspace directory to store the preferences and also all the artifacts that we create during development. Typically in this course we would be creating a lot of Java files, and we will be organizing that Java files into different projects, and all these projects will be stored in our workspace. We'll look at the workspace, project and the Java file hierarchy in a little while. For now, choose any folder where you want to store all the code in. So you can use the browse also. You can choose a folder by clicking the browse button. You can choose where you would want to store your Java files and the projects. And once you choose the folder, you can go ahead and click launch. When you launch Eclipse, especially when you are doing it for the first time, it might take a little time, and you'd see a welcome screen. If you want, try and spend some time looking through whatever is present in here. The tutorials, the overview and the samples might be helpful. Spend some time with them and try to get an overview of them. For now, what we want to do is to create a new project. Before we create our first project, let's get an overview of the workspace, project and all the files, right? So these files are all the code you would want to write. So you might want to write a big program, maybe having 50 Java class files, maybe you have XML files and all that. So these are all the files which you would want. And a project might contain multiple files, and you might have multiple projects in a single workspace. So workspace is a way of organizing your different projects. You might be working on a project for work, and you might be working on a project for your own personal learning. So in a single workspace, you can have multiple projects, and each of these projects can have the files related to that specific project. In Eclipse, you cannot have files without having a project. So first what we did was created a workspace. Now let's go ahead and create a project. And there are a wide variety of projects that Eclipse offers. What we would want to do is we would want to learn Java, right? So what we'll do is we'll create something called a Java project. So file, new project, and choose Java project from here and click next. So it's file, new project, and choose Java project from here. Just click next. We'll give the project a name. The name I would give this is first Java project with in 28 minutes. You can give any name that you would want. So I'm giving it a name, first Java projects within 28 minutes. You can say use the default location, that's cool. And we are using Java 9. So I'm choosing the execution environment as Java SE 9. This comes by default because Java 9 is installed. Eclipse picks that up and shows it in here. There is no specific configuration that you would need to do. And you can leave all the other stuff as default and click finish. You can see that Eclipse asks you a question. It says, do you want to use Java perspective? We'll talk about a perspective little later. For now, you can say open perspective. And you would see that your first Java project is created. If you expand it, you will see the JRE system library and a source folder. If your folder structure looks a little different from what you see in here, no problem at all. That's fine. I'll also close down the stuff on the right hand side. All these are called views. We'll talk about them a little later. So what you are seeing in here is a basic Java perspective. So you can navigate through all the files which would be present in here. Right now we don't really have anything in here. And once you open up a file, you'll be able to edit it in here. Now that we have created your first Java project, in the next step, let's look at how to create a Java file and run it. Welcome back. In this video, let's create our first Java class using Eclipse and run it. Now, let's get started. The way you can create a new class is right click on the source folder, right click, new class. So right click, new class, and over here I can type in the name of the class. Let's call this hello world, and I will use a package com dot in 28 minutes dot first Java project. When we talk about projects, they might be containing multiple Java classes. You'd want a way of organizing these classes. You don't want all the classes, or if you have 100 classes, all of them present one below the other in here. You would want to be able to organize them into different groups, and packages offers you a way of doing it. It's very similar to how you group things and put them in your house. You typically have your house really organized. All the things related to cooking and eating would typically be near the kitchen. Your sofa and probably your TV would be in the hall. Similar to that, package offers you a way where you can categorize and store different classes. The other thing you can see in here is I can ask Eclipse to create public static void main. So let's go ahead and do that. Let's ask Eclipse to create public static void main, and I would say finish. You should see a file like this launch up. Typically, we are used to seeing this, right? Class name. Public is an access modifier. It means that we can use this class in all other classes. We will talk about different access modifiers a little later. But for now, this is syntax which is familiar for us. So class name, and we have open brace and we have close brace in here. And between these is our main method. So main method, this is exactly the syntax which we looked at earlier. And here there is a comment. So slash slash, it means that this is a comment. This is not going to be executed. Also, because we are using a package, you would see that there is a structure. So package com dot in 28 minutes dot first Java project. This is what we gave as a package. Before I run this class, let's have a simple sysout typed out. So system dot, and now you'd see Eclipse magic kicking in, right? It's suggesting things. So out dot println, and let's say I would want to print hello world. This is kind of the first Java program a lot of people write. So this is very simple, right? And I can do a right click, run as Java application. You should see a window open up where you would be able to see the output. You can also run the program now by using the button in here. So you can click the arrow button in here and click hello world. This would also run the program and you'd be able to see the output. The other shortcut is to press Control F11, or if you're on Mac, it's Command F11. So press Command Function F11 or Control F11 on Windows. If you press that, it would also execute the last launched thing again. So that's a shortcut to execute it. Do not worry if it does not work for you. We'll talk about shortcuts a little later. For now, the important thing is we wrote our first Java program using Eclipse and we were able to even launch it up. And if we look at the whole thing, we saw that we did not really have to write any code. All that we had to do was to type one line of code and Eclipse was able to generate the whole thing for us. That's the fun behind using an IDE. The other important thing you would have already noticed is I did not really compile it. So who compiled it? Eclipse compiled it for me. So whenever I do a run, it would compile and then run it. So I don't really need to run javac hello world.java and then do java hello world. That is all the magic that the IDE does for us. And that's the reason why here on in this course, we would start focusing on using the IDE and becoming an expert at both the language and also using the IDE. If you are a programmer and you would want to do programming for a living, then IDE is a place where you would be spending a lot of time. So focus on it and try and become an expert at using the IDE. I'll see you in the next video. Welcome back. In the previous step, we wrote our first Java program using Eclipse and executed it. Now, let's create another program, the same program that we did earlier, multiplication table. So we'll now write the multiplication table and see how we can quickly create it using Eclipse. You can start with File, New, Class. Or you can use this shortcut, Command N or Control N. So Control N or Command N based on your operating system, and you'd be able to choose new class. Click next, and I would want to call this table as multiplication table. Sorry, I would want to call this class as multiplication table. I'll use the same package, and now if you press enter, the class gets generated for you. I'm not generating the main method. I did not check the checkbox for the main method because we don't want to have a main method in here. What we'll do now is we would want to print the multiplication table. So 5 into 1 is equal to 5 to 5 into 10 is equal to 50. That's basically what we would want to print, right? So that's what we have done earlier using JShell. So if you remember the code for that, it would look something like this, right? So for int I is equal to 1, I less than equal to 10. So we loop around, and what did we do? We did a system.out.println. You can type in sysout and press control space. So just type in sysout. I'll do it again. So sysout and press control space. It would expand to system.out.println, one of the magics of Eclipse. Press double quote, and as soon as you press double quote, what would happen? The other double quote is also generated. That's cool, right? So we would want to use the formatter. So I cannot use system.out.println. I should use printf, and %d into %d is equal to %d, and comma, we need to pass the 3 values, right? The first value is the table that we would want to generate, so 5, and the second value is I, and the third value is 5 into I, right? This is the code we had, but inside the class you cannot write code like this. This kind of code should be inside a method, and we also created a method earlier, right? So void, we call it print multiplication table. This is already in a class called multiplication table. So what I'll do is I'll remove the multiplication table and just call it print, and open brace and press enter. Now I can move this code inside this. I did a control X, control V, or command X, command V based on the operating system, or you can do a cut and paste. Now what we have done now is we have created a print method. This print method, what does it do? It prints the 5 table. Now I would want to run this code. This method is inside a class, and to be able to run this, you need to create an instance of the multiplication table class. To be able to run this class, what we'll do is we'll create a separate class. So what we'll do is we'll call this multiplication table runner, and over here we will use the main method and click finish. Just press enter, and now multiplication table runner is created. Over here, now I can use the multiplication table that we created earlier. So multiplication table is equal to new multiplication table. We are creating an instance of it, and now I can say table dot print. We can go ahead and execute this. You can do a right click, run as Java application, and you can see that it's getting printed on the same line. That's because we don't have a println. So let's do a dot println. So what we are doing here is we are separating the code from the class which is running it. So if you do a control and click, you'd be able to go to the multiplication table. You can click the different tabs in here, the file names in here to navigate to them, or inside the multiplication table runner, you can click multiplication table and be able to come in here. Let's run the multiplication runner again, and you'd see that the entire program gets executed. One of the mistakes a lot of beginners try to do is try to run the multiplication table class. So right click run as, you'd not be able to see the Java application. You'll not be able to see the run as Java application for multiplication table class because it does not have a main method. You can only see right click run as Java application in classes which have main method. Over here, you can do a right click run as Java application, and you would see that the table gets printed. So 5 into 1 to 5 into 10 is equal to 50. In this video, we created the multiplication table print method using Eclipse. What we'll do in the next video is we'll try and make this multiplication table even more generic and try and see how Eclipse would help us do that. Until then, bye-bye. Welcome back. In the previous step, we created the print method to print the 5 table. But we would also want to make it generic so that it can print any table. How do we do that? We can create a new method for it. So I would create a void print, and what I would want to do is I would want to be able to accept a parameter. There's an error which is coming up. You are having two methods, same name, and having no parameters. That's not really good. That's what Eclipse is telling me. I'll not worry about it for now. For now, what I would want to do is I would want, instead of using 5, I would want it to be passed from whoever is using this method. So whoever is using the print method should be able to tell me which table to print. How do we do that? We would create an argument in here. So we'll say int table and use table instead, right? So that's basically what we can do. And now we have a print accepting which table to print. Let's see if it's working. Let's go to the multiplication table runner, and over here I'll comment this and call table.print 5. What we are doing here is overloading it. So print with no parameters and print with one parameter table. And let's run the multiplication table runner again. And now you can see that 5 table is printed. If I change this to 6, you can see that the 6 table is printed. That's cool, right? So that's very cool. And you can make it even more generic. Here we are printing from 1 to 10. You might want to make even these as arguments. Whoever is calling the method can tell what table to print and also from where to where. How do we do that? I'll copy this method again, Control C or Command C, Command V or Control V, and over here I would want to add in new parameters, right? So int from comma int 2 and from comma 2. That's cool. Now let's go to the runner, and now let's copy this, and I would want to print 6 table from 11 to 20. Let's run this, right click, run as Java application, and you would see it being printed. Oops, it's printing from 6 into 1 to 6 into 20. Look at the screen. Why is it printing from 6 into 1 to 6 into 20? Pause the video in here, try and find out what error that we are making. Okay, you're back. Did you find the error? Why is it printing from 1 to 20 when I'm saying 11 to 20? Because we have table.print before it. So I can comment this now, / and do a right click run as Java application. So now you would see that the commented line is not executed. So we are printing from 6 into 11 to 6 into 20. That's very cool, isn't it? One of the things that we are doing in here is we are trying to generalize the method so that it can meet the needs of different people. If we hard code a lot of things in a method, then it will not be very useful. The more you generalize the method, the more useful it becomes. The idea also is to get you familiar with what you can do with Eclipse, how you can run run different classes with Eclipse and all that kind of stuff. There is one problem with this particular implementation of the multiplication table. I would recommend you to try and think about it as an exercise, and I will see you in the next video.
In this video, we will look at one of the most favorite tips of mine related to Eclipse called Save Actions. I can go to Eclipse Preferences or Window Preferences if you are in Windows and type in Save. This brings up something called Save Actions. Make sure you're choosing Java Editor and Save Actions. You can enable Save Actions by pressing this in here. So you can check this checkbox which is present in here. One of the things that you can do with Save Actions is the fact that as soon as you save, Eclipse can automatically perform a few operations for you. Over here, what I've selected is to organize the import. So as soon as I say save, the imports would be organized. Not just this, you can also get Eclipse to format your source code as well. So you can check format source code and say format edited lines. Or you can also add additional actions. You can configure what additional options are present in here. So if you want to say, I don't want to use trailing white space. You'd want to have a specific code style that you would want to follow. You'd want to make sure that always you want to use blocks. Or you'd want to make sure that all your for loops are converted to enhanced. All this kind of stuff can be configured directly in here. And when you press OK, go ahead and do apply and close. And now, whenever you make a change and do something, let's say I'm making this code unformatted and I'm saying save, you can see that the code is automatically formatted. All the edited lines are automatically formatted. Let's just say I'm importing a star. Star is considered to be a bad practice. So if I do a star and save it, you'd see that it automatically translates to big decimal. All this magic is happening because in Eclipse preferences, we have enabled save actions. This would automatically formatted the edited lines. This would organize the imports according to the settings that we have in here. And this would do a lot of things based on the settings that you have configured in here. I love save actions, especially when you have a few coding standards in your project that you would want to always adhere to. You can go ahead and set them in your save actions, and whenever you save your code, the coding standards are always met. I'll see you in the next tip. Until then, bye-bye.
Welcome back. I hope you had some time to think about this multiplication table and the problem with it. Problem with this multiplication table is duplication of code. You can see that all the methods have very similar kind of code, right? Let's say I would want to change the star. Instead of star, I would want to print X. So what I would need to do, I would need to go to 3 places and now make the change. This is not really cool. So let's run it right now. Right click, run as Java application. This is called duplication. The fact that I'm doing the same thing 3 times in 3 different methods is called duplication, and that's not really a good problem to have. Think about what would be a solution for that. So think about these 3 methods and how you can solve it. You can pause the video now and try and think what you can do to solve this problem. Welcome back. I hope you had some time to think about the solution for this. Now, one of the things that I can do is, if you look at the print table, what is it doing? It's exactly doing the same thing as print table from and to, right? But what is the difference? Here it's doing from 1 to 10, right? Is there any way I can use the print table method in here? Can I call this method from here? Do you get the idea? Do you want to pause the video now and try it? Okay, the way you can do that is print, I would say table, I'll take the table, and I can pass in from, what is the from I would need to pass in? 1. And what is the to? 10. And a semicolon, and we don't need this code anymore, right? And now I can go ahead and I'll uncomment this and I would want to print 6. Run as Java application. What would happen? 6 to 60. 6 into 1 to 6 into 10. Isn't that cool? Now, think about what you can do in here. What can the print method do? Think about it. What can the print method do? Actually, there are two different options that print method can do, avoiding duplication. Take it as an exercise, pause the video here, and see if you can solve it. So all that it needs to do is say print, pass the 5. That's it. The other option is to say print 5, 1, 5, 1, 10, because both of them would do the same thing. I'll choose print 5, and let's see what would happen. So instead of print 6, let's save this, run as Java application. Cool, isn't it? One of the important things that you need to make sure is each time whenever you're making a change to your Java file, you need to ensure that you are saving it. So you can use Control S, or you can say file. If you're making a change, you can use a file save. And now I can go ahead and run as Java application, and you would see the 5 table printed. Isn't that cool? Now you can see now that the multiplication table is much better. If I have to change it back to star, I just need to change at one place, and all the other methods immediately reflect the change. Isn't this cool? Whatever we have done now is called refactoring. Refactoring is basically an exercise where we change the structure of code without changing its functionality. We changed how print is written without changing the functionality of the code. We changed how print table is done without changing this functionality of the print table method. This is called refactoring, and typically great programmers keep refactoring their code to keep improving it. The first time you write code, most of the times you would not write perfect code. As you get more understanding and as you learn more, you would get better ideas to improve your code, and that's what refactoring is all about. Keep improving your code. I'll see you in the next video. Welcome back. In the previous step, we had refactored the multiplication table. Now we have almost no duplication, and we have really clear code. What we'll do in this step is we'll try and use something called a debug mode. One of the things you can do with an IDE is you can try and run the program step by step. So I can start with running from here, starting with here and going inside, going from this method to this method to this method step by step. Not just running the complete program, but also running step by step and see what's happening behind the screens. That is called debug mode. And the way we can trigger debug mode in Eclipse is by doing a right click, debug as Java application. But before you do right click debug as Java application, what you need to do is add a few breakpoints. You need to tell the IDE where it has to pause. The way you can do that is by double clicking. So I can see the number 6 in here, that's the line number. So it's a line number, and if you click on it, so double click on it, double click enables the breakpoint and disables. So right now it's disabled. Again double click it, you can see this small dot which is present in there, and when I go hover over it, you can see that it says that's a breakpoint. It says line breakpoint multiplication table runner line 6. So that's cool. And now I can go ahead and do right click, run as Java application. Oops, I should have done right click, debug as Java application, right? That's how we debug. And one of the important things is based on what you are trying to do. When you are writing code, you would use something called Java perspective. When you are trying to debug, Eclipse says, okay, you are better off using a debug perspective. You are trying to debug, so try and use a debug perspective. Let's say yes and say we want to use a debug perspective. Now you would see that there are a lot of windows which are opening up. All these windows are called views. So here there's a view where I can see the call stack. What is happening here is we are in multiplication table runner and we are in the main method on line 6. This is called a call stack. This is the thread and it's showing the entire information of where we are. Here you can see the active variables. This is where we can see the breakpoints. We enable breakpoints. So this is a variables view. This is breakpoints view. And you can see an outline as well. Outline shows what are the methods which are in this specific class. Inside the multiplication table runner, there is a method called main. And you can also see the console. What I'll do is do something called step over. So if you look at the top part in here, there are two things, step into and step over. So step over would execute the line and go to the next line. It would complete the execution of line 6 and go to this line 7. Step into would try and go inside the code for the multiplication table constructor. So here we are using a constructor. This is called constructor. We'll talk about constructors a little later. It will try and go into the constructor code and see what would happen when you are creating the object table. Let's not worry about it for now. So what we'll do is we'll go step over, and once we do a step over, you can see that the focus switches over to line 7. So you can see that line 7 is highlighted, and you can see that even in this thread it says line 7. That's where the execution is right now. I would want to see what's happening in the print method. How do you do that? Click step into. Now you would see that we are inside the print method, and inside the print method what we are doing is we are calling another method, print 5. So you can see here now the entire chain, right? So main method line number 7 is calling multiplication table print method, and the print method is calling it again. I'll do step into again, and now you can see that we are inside the print table, and over here if you go over to the variables, you would see that there is a table variable. That's an argument, right? So the argument, you can see what value is in there, 5. How did it get the 5? Because over here I'm passing in 5, and this 5 is what is sent over in here. So the 5 is here, and you can also see the stack trace. You can see the entire method chain right now. So line number 7 in math table runner is calling the print method, and the print method is calling the print with one argument method. And now what would happen next? Again I would do a step into. So step into, the shortcut for step into is F5. So if you are on Mac, function F5. If you are on Windows, F5. So you can press F5 as well. I'll keep using these for a little while until you get comfortable. Now I did a function F5, or actually I clicked the button which is present in here, and now you'd see that we are inside the print method, which is accepting 3 parameters. So what is happening in here is we are going in from one method to the other method. This is called the call chain, right? So here you have a main method. From main method we went into the print method without argument, print method with one argument, print method with 3 arguments. And here you can now see that the variables are table with a value 5, from with a value 5, and to with a value 10. One of the exercises I would recommend you to do is you can actually modify the value. So you can say 6, and you can see what would happen in that kind of scenario. But for now, let's focus on whatever we are doing right now. Table, from, and to. You can see the values of these arguments 5, 5, and 10, because that's what we have passed in here. Actually, there's a bug in this code. It should have been actually table 1, 10, but that's okay. We'll print values from 5 to 10. That's cool. Now from to 2, right? So now you can see what's happening inside for loop as well. You can see that I variable is not really created yet. So what I'll do is I will do a step into. So when you do a step into, you'd see that I is initialized with a value of 5. So I is equal to from. So what happens? I gets a value of 5. And what would be printed right now if I do a, I'll not do a step into right now. Be careful not to do a step into. That might be very confusing for you. What you can do is actually do a step over, because system.out.print would do a lot of things. We don't really want to get into that. Let's do a step over, and it executes that. You can see what's printed. 5 into 5 is equal to 25. Now you can focus on the value of I. What would happen now is I++ would get executed. Now I'll do a step over. What is the value of I? I becomes 6, and we are going into the system.out.printf. Step over again. After I'll do a step over, I becomes 7. 5 into 7 is printed, it becomes 8. 5 into 8 is printed, 9. 5 into 8 is printed, sorry, 5 into 9 is printed, 10. 5 into 10 is printed. Now I has a value of 10, so I++ becomes 11, and this condition would fail. So what you'd see is the statement inside the for loop will not be executed, and you'd go over to this line. Let's do that. Step over. You can see that it jumped from for directly to line 16, because this condition is no longer true. The value of I now is 11, right? So I is 11 and 2 has a value of 10. This condition will no longer be true, so it jumps out of the for loop, and now I can continue execution. You can see that it would follow the reverse chain. So it would return back, and we are back in the main and completing the execution, and you'd see in the console the whole thing. Okay, let me fix the error first. Over here in the multiplication table, it should have been 1 to 10. So in this video, what we looked at is how to use debug mode to debug the programs and understand them much further. If the debug mode is a little confusing to you, don't worry. There's a lot of information that it presents, and it can get a little overwhelming for beginners. But it's essential that you spend some time with the debug mode and try and understand it further. Debugging is a very, very, very important skill, whether you're using debugging mode to debug programs. If you are an excellent program reader and you are able to figure out bugs by just reading the code, that's awesome. But for most of the other developers, debuggers are very useful, and try and spend some time with the debugger, try and play around with it, and I'll see you in the next video. Good luck. Welcome back. In this section, we are doing a lot of things with Eclipse. We created our first project, we created a number of classes, we created a number of methods. We tried to debug a program using Eclipse debug mode. And now let's look at a few important tips regarding Eclipse and how you decide how to choose between Eclipse and JShell, right? So one of the important things about Eclipse is Eclipse offers a lot of shortcuts. All that you need to do is press Control Shift L or Command Shift L, and this would bring up a list of host of shortcuts. I mean, learning all these shortcuts will not be possible in one day. What we'll start with is some of the important shortcuts, right? So the first shortcut is Control N or Command N. So press that, and you'd be able to create a new class. So let's try to create a class without using the mouse at all. So let's type in keyboard shortcuts, and you can just press enter. You can see that the class gets created. Over here, you can just type in main and press control space, and you can create the main method, and just press sysout and press control space, and it expands to system.out.println, and you can type in whatever you would want to type in. That's cool, isn't it? So remember these shortcuts. So Control N or Command N to create something new. Over here we wanted to create a Java class, so class is fine. If you want to create a project as well, you can choose it from here and click next, but class is what we wanted to create. So we clicked next and went ahead, and without using a mouse, we were able to get up to this stage with a very few keystrokes. The other useful shortcut when you're trying to do some programming is Control Shift R or Command Shift R. You can search for a class. So I can say multiplication table, or I can type in, I would want hello world, and I can go there. So Control Shift R and type in the name of the class, and you should be able to go there easily. The last thing I would want to leave with is the difference between writing Java programs in a class file versus JShell. In JShell, when I typed an expression in, it finds the value and assigns it to a variable. But in a program, that would not happen. You would actually get a compilation error. So if I enter 3*4 here, you would get a compilation error. In your program, expressions are not accepted. You have to create statements. So I have to say int I is equal to 3 into 4, and then I can print the value of I. That is good, but you cannot just type in an expression and expect to see the value like in JShell. The other important thing is in JShell, once let's say I created a variable I with a value 2, and if I declare it again, I is equal to 3, what it would do is it would override the previous declaration and say, okay, I know this is JShell and you are a starting programmer, so don't worry about it. I know you would want to override the earlier declaration of I with a int, or you can even change the type of I. So instead of int I, you can say long I is equal to 5. JShell will not care about it. It would take whatever is the latest and take it. But inside your code, in a real code, if I say int I, after that, inside that method, I is always an int. You cannot declare it again. You cannot say int I is equal to 5 into 6. You would get a compilation error. It says duplicate local variable I. You cannot do that. And the other thing is you cannot also change the type of I. So I cannot say long I is equal to 5 into 6 as well. It says duplicate local variable I. So once you declare it in a program, it's done and dusted. You cannot declare it again. The third important thing is if I don't assign a value, it is assigned a value of 0. But in a local variable in a method, if you say int I, and if you try to use it, what would happen? It says I may not have been initialized. You have not assigned a value for I. What kind of programmer are you? Go ahead and fix it. So it's on you to assign values to local variables. So these are a few important things that you need to know. JShell is kind of a learning place. You can play around with it whenever you want to. If you want to find out what a method does quickly, JShell is awesome. But when we write programs, you have to adhere to a little bit more set of rules, and that's what we discussed until now. The idea behind this section was to introduce Eclipse to you and make sure that you get a little comfortable with Eclipse. You'd see that as we go on with the course, we will also discuss a number of other Eclipse tips to make you comfortable with Eclipse, to make sure that you're becoming a good Java programmer as well as you're productive with the IDE Eclipse. Until the next video, bye-bye. Welcome back. Welcome to this section on Introduction to Object-Oriented Programming. The way you think in structured or procedural programming is completely different from how you would think in object-oriented programming. In this section, you will be introduced to thinking in terms of objects. We will discuss about what is a class, what is an object, what is state, what is behavior, and also discuss about a few important object-oriented basic concepts, encapsulation and abstraction. We will use a lot of examples to discuss about object-oriented programming and the different terminology which is used with respect to object-oriented programming. I am excited to bring this section to you. I'll see you in the next video where we would start with the basics of object-oriented programming. Until then, bye-bye. Welcome back to this video about Introduction to Object-Oriented Programming. Object-oriented programming is all about thinking in terms of objects. Before we get into depth with this, we will talk a little bit about structured programming. If you have done any programming with languages like C or Pascal, you'd be doing something called procedural or structural programming. Procedural or structured programming involves thinking in terms of procedures These are also called methods or functions. So let's say I have a problem to solve. The first thing I would try and do is to split the problem into multiple functions or multiple procedures. I would start thinking in terms of, okay, what are the functions I would need to write? What are the different steps involved in doing this? For example, let's say I would want to fly. So I would want to fly from one place to another place. Then I would start thinking in terms of the different steps involved. I'll say, okay, travel to airport, find a check-in counter, check in, pass security check. So we are thinking more in terms of what are the important methods that we would need to create and how to combine them to solve the problem at hand. Procedural or structured programming is all about thinking in terms of functions, or these are also called procedures. Object-oriented programming brings a new thought process around this. It says, okay, why don't we talk in terms of the different objects that are involved in the problem and also think about what is the data they would contain and what are the actions you can perform on them. Okay, is this sounding complex? Then you're not alone. That's how I felt when I was introduced to object-oriented programming as well about 15 years back. Let's take an example and try and understand how to think in terms of object-oriented programming. So let's take the example of taking a flight again. The first thing that we would be thinking about is what are the different objects that are involved. An aeroplane, a air hostess, a passenger, a airport, a cab that I would need to take to the airport. Also the different persons that might be involved. So when we are thinking object oriented, we are trying to identify the different things that are involved in our problem. The first thing which we would try and do is to identify the things like airplane, air hostess, passenger, the pilot, and things like that. Once we identify the things that are involved, we identify what data you would want to use about that specific thing. So what is the data that can represent an aeroplane? Maybe which airline, what is the make of the aeroplane, what is the type of an aeroplane, whether it's an Airbus or not, and what is the position, where is it currently. So that's kind of typically the data. And also you'd think in terms of actions. You'd be thinking in terms of the actions that you can perform on an aeroplane. Take off, land, cruise, a lot of things that you can do on an aeroplane. If you look at the air hostess, then probably the name of the air hostess address is the data. And there might be actions like wish, serve, and a number of other actions. When we are thinking about a passenger, his name, maybe his address, and a lot of information can be the data. And probably the actions he can perform is take cab, do a check-in, walk, smile, run, board the aircraft, and a lot of such actions. So when we are thinking object-oriented programming, we are thinking about what are the objects, what is the data they might contain, and what are the actions that can be performed on them. The data that an object might contain is also called state of the object. The state of an object can change over a period of time. The position of an airplane now is different from the position of an airplane maybe after an hour. The actions that can be performed on the object are also called its behavior. In summary, the big picture is this. Structured programming is all about thinking about procedures or methods. That's all we would be thinking about in structured programming. In object-oriented programming, we try and think in terms of objects and what kind of data they might contain and what are the operations or what are the actions that can be performed on these objects. If all this seems a little confusing to you, do not worry about it. We would be using more than 5 examples to discuss this in detail in this specific section. I'll see you in the next video. Welcome back. In this video, let's talk about what are the different terminologies which are associated with object-oriented programming. In the previous video, we learned that object-oriented programming is all about objects, the state of the objects and the behavior. What we are seeing in here is a simple class. This does not really follow the Java syntax. I just created a simple template kind of thing to just represent a class, and I'm creating two instances of the class in here. What is a class? A class is nothing but a template. A class can define what are the data that an object can have and what are the actions that can be performed on an object. A class is like a template. For example, a person is a class. An object is an instance of a class. So when we talk about person class, the instances can be Mahatma Gandhi, Nelson Mandela. So a person class defines the attributes that are related to a person, and each object of that specific class, each instance of that specific class, for example, Nelson Mandela or Mahatma Gandhi, can have different values for the attributes of the class. Let's consider this example, right? So we have a planet class and we are creating two instances, Earth and Venus. You can have other instances as well, Mars, Jupiter. So this is a class which defines that a planet in general will have a name, location, and a distance from the sun. And Earth is a specific instance of that planet, and for Earth, the name is Earth, location is, let's say, specific coordinates of the Earth, and the distance from Sun for Earth would have a different value compared to the other instance of planet, Venus. If you are aware of the solar system, then you would know that Venus, the distance of Venus from Sun is less than that of the Earth from the Sun. So the distance from Sun for Venus would have a different value compared to the distance from Sun for Earth. So a class is a template, an object is an instance of that template, Earth, Venus. The member data, state or fields are the data which are present in every object. So for each of these fields, Earth can have a different value and Venus can have a different value. So this is called member data, or this is also called the state of an object. This is represented by using something called fields, or these are also called member variables. The last terminology which is frequently used in object-oriented programming is related to the methods which are defined in a class. These methods are said to be representing actions that can be performed on a specific object. So you can say earth.revolve, earth.rotate, or you can say Venus rotate. So these are the actions that can be performed on different objects. This is called behavior of a class. Behavior of a class is the actions that can be performed on its objects. The idea behind this video was to give you a quick introduction to all the terminology related to object-oriented programming. So a class is a template, an object is an instance of that template. The member data is what data an object can contain, and behavior or actions are what are the actions, what are the methods that can be called on a specific object. Let's end this video with a few exercises. So think about an online shopping system and try and identify what are the different things that are involved in creating an online shopping system. So try and identify the objects, try and identify what kind of data would be associated with each object, and also what kind of behavior would be associated with each of those objects. And the second one is much simpler exercise. So think about a person class. Think about what can be the data which can be present in that, and also think about what are the actions that can be performed on it. So think about those two things. Those would be an interesting exercise as far as object-oriented programming is concerned. I'll see you in the next video. Welcome back. In this short video, we will discuss about the exercises from the previous video, right? So the first thing which we talked about was the online shopping system. We wanted to identify the different objects that are involved and also the data associated with them and also the actions that can be performed. So here are a few examples. I mean, this is not really a complete master list as such. This is a representation of how you can think about them. I'm sure you would have identified much more than what I have shown in here. So the types I have identified are customer. A customer can have a name, address, and he can perform multiple actions, right? Log in, log out, select a product, check out, and a lot of other stuff, right? And shopping cart can contain a list of items that a customer has already chosen. And the actions you can probably perform on a shopping cart are add an item, remove an item, and things like that. Another thing is a product, right? So a product has a name, it has a price, quantity available. That's all the data, that's the state. And the behavior is what are the methods that can be exposed. Probably order more products, change the price of the product. All those can be the actions that can be exposed. Actually, this is just a small representation. Actually, when you talk about an online shopping system, you can identify a number of other objects and also you can identify what state they might contain and what behavior is possible on them. Now, let's get to the other exercise. The other exercise was to identify things related to a person. So there's a class called person. What is the data that you would want to have there? And what are the actions? What are the methods that you would want to have there, right? So these are a few examples. So name of a person, maybe you can even split it up and say first name, last name, and middle name. Address, you can even split it up again, right? So you can store the zip code, country, state, and all that kind of information as well. What kind of hobbies does this person have? Where does he work? Is he studying? All that is the data about a person, right? And the other thing is the actions that can be performed, right? So walk, run, sleep, eat, drink, travel, move, a lot of things that can be performed on the person. So the idea behind this exercises was to start getting you thinking in terms of object oriented programming, right? So we are trying to identify the different objects that are present, what is the state, that is what is the data they might contain, and what is the behavior, what are the methods or actions that can be performed on them. That's a lot of theory that we talked about until now. I'm itching to get my hands dirty. In the next step, we would start creating a number of classes, creating instances or objects for them, and try and play around with them. I'll see you in the next video. Until then, bye bye. Welcome back. After all the theory about object-oriented programming, let's get hands-on and let's try to apply what we have learned. So what we want to do here is to build a motorbike class. We would want to be able to adjust the speed of the motorbike and also the gears. So let's assume that this motorbike has a few gears, let's say 5 gears, and also you can press the accelerator to adjust the speed. So that's kind of the basic class that we would want to build. We would also want to create a few instances of this motorbike class, and we would want to create a couple of methods to be able to adjust the speed and gears as well. What we would want to do is in this section from here on, whatever theory that we learned about class, object, state, and behavior, we would want to look at it in practice and also look at the basics of encapsulation and abstraction. In this video, let's focus on creating a motorbike class and let's create a few instances and play with it. We'll start off with creating a new project. If you are actually coming from the previous section where we ended it with a debug perspective, right now you can move to a Java perspective. You can do a window perspective, open perspective, Java. Java perspective is the best perspective to be developing things. What I'll do right now is do file, new Java project. I'll call this introduction to object oriented programming. Now you can leave all the rest of this stuff as it is and click finish. This will create a new project, and when you expand it, you should see a source folder in here. That's cool. Now we can create our Java class in here. Do not worry about this readme.md. You will not see that. So Over here, I can create a new Java class. How can I do that? Command N and type in class and choose class plus next. Type in the name of the class, right? So the name of the class I would want to call it is we would want to create what? A motorbike. So let's do that, motorbike. So I'm using camel case, motor, bike, M caps, B caps. That's how we name our classes. Classes start with a capital letter, and except for classes, almost everything else like variables, methods, they would all start with a small letter. I mean, that's kind of the convention that is typically used in Java. Now, the package, I'll say com dot in 28 minutes dot introduction. I'll just call it oops. So com dot in 28 minutes dot oops, and now I'd go ahead and click finish. Okay, cool. Then we have our motorbike class. So you'd see the package in here and you'd see public class motorbike. That's cool. Now let's also create a runner class for it. So I'll say control N, again command N, control N, or you can do file new class and type in motorbike runner. And in the runner classes, we'll create a main method. I'll go ahead and click finish. What we are doing in here is creating a class and its runner. In the runner class, what we'll do is we'll create instances of the motorbike and we will try to make use of it. So let's create a couple of instances of this motorbike. Let's call them Ducati and Honda. So how do we create instances of the class? Do you remember it? Try and pause the video and try creating two instances of the motorbike class. It should be very simple, right? So it's motorbike Ducati is equal to new motorbike. Isn't that cool? And motorbike Honda is equal to new motorbike. Okay, cool. Now you'd see one of the things which Eclipse does, which is to highlight warnings. So it's saying, okay, Honda is a variable which is created in here, but you have never used it. What we'll do now is we'll create a simple method in the motorbike. We would want to start and stop the motorbike. So let's say void start, and over here, what can we do now? I can call the start on both the things, Ducati dot start and Honda dot start. So that's cool, right? So now I can go ahead and run this. How do I run this? Right click, run as Java application. You'd see that nothing really happened. Why did the console did not come up? Because we are not doing anything in the start. So let's go ahead and do that. System.out.println bike started. Okay, cool. Let's go ahead and run this. You can do it as right click, run as Java application. You'd see bike started twice. So one of the things right now is we are not able to distinguish which bike has started. That's something which we'll fix very soon. In this video, what we have done is we have created a motorbike class with a simple start method. And we created a motorbike runner, and we are now able to create instances of it and call the start method. Motorbike is the class, Ducati and Honda are the instances of the class, and the behavior of the class is the start. So you can start the Ducati bike and the Honda bike as well because that's on the class. So whatever methods are on the class can be invoked by all the objects of that specific class. Now let's look at an exercise that you can do based on what we have learned in this specific video. Create a new class called book. So create a class called book, create three instances of it. The three instances of it are Art of Computer Programming, Effective Java, and Clean Code. So these are some of my favorite Java books. Actually, this is a Java book. This is a book on algorithms, and this is a book on how to write great code. So these three are among my favorite books. You need to create a class called book and create three instances with these names. Until next video, bye bye. Welcome back. Let's now work on the exercise problem that we discussed in the previous video. It should be very simple, right? It's very simple to what we did until now. So I'm doing a control N or command N, or you can do a file new, create a class. So I'll call this book and create it, and control N or class. So book runner. I would add a main method in here and click finish. And over here, I can go ahead and create instances of the book, right? So what are the names that we would want to give to the book? Did you remember them? The names that we would want to give are here. So I'll just copy them over here. So this is the names that we would want to give. Art of computer programming. Let me remove the spaces. Art of computer programming. Okay, is this a good variable name? Good instance name? Good object name? Nope. The names of objects should always start with a small letter. So effective Java and clean code. Cool. This is cool. So all that we need to do is equal to new book, and I'll copy paste it here and say book and copy paste it in here. Okay, so those are the 3 instances of the book. Now we can go ahead and create a method in it. I'll leave that as a quick exercise for you. The important thing you need to learn is to be able to create classes very quickly, and how to create a main method very quickly, and also how to create instances and name them. So the convention which is used in Java is to name a class with a capital letter and name a variable starting with a small letter. And after that, it's always camel case. So for each of the words, start of the word, you'd use a capital letter. Until the next video, bye-bye. Welcome back. In the previous step, we created a few instances of the motorbike Ducati and Honda. These are objects, right? We said earlier that objects have state and behavior, right? So we said each object has state and each objects have behavior. Behavior or behavior, whichever way you would want to spell it. State is what is the current situation a specific bike is in. For example, I'm driving a Ducati and currently my speed is 50 kilometers per hour or 50 miles per hour. So what's my state? My state is that I'm going at 50 miles per hour. This state can change. So Ducati, let's say I accelerate further. What does the state become? My state right now is 70 miles per hour. So that's the state of an object. How do we represent state of an object? By creating variables inside the class. So in the class, we can create member variables. Here we would want to have state of motorbike, and the state of motorbike I would want to have is int speed. Actually for speed even short should be sufficient, but let's use it. So int speed, this is the state of the motorbike. What we have done now is we have created an instance variable inside the motorbike class. Once you create an instance variable in the motorbike class, you can set values for it. So now I can say speed. How do I refer to the speed? Speed is a value inside here, right? So inside the class. Can I say motorbike.speed and set the value? What does it say? Error. It says, okay, you cannot do that because speed is an instance variable. Instance variables can only be referred from instances, objects. So I can say Ducati dot speed is equal to, let's say, 100. And now I can also set Honda dot speed is equal to 80. So what we are doing in here is we are changing the state of the object. So we are setting a speed of 100 to Ducati and speed of 80 to Honda. And after that, the state can change as well. So let's say after some time, Ducati has reduced the space. There's a traffic jam, and Honda has completely braked. He's taking a break. So this is basically how your state of an object can change across the duration of the program, right? When we start off, we are starting the bikes, we have set the current speed, and after some time the speed has changed. So similar to this, the state of any object can keep changing. One of the important things is Ducati has its own instance of the speed variable. Once we have defined a variable called speed in here, Ducati has its own instance, Honda has its own instance. If I say Ducati.speed is equal to 100, the speed of the Honda will not be changed. Honda speed will be changed only if I say Honda.speed is equal to and change that specific thing. So these objects are independent of each other, and each of these get a copy of this specific variable. The way you can look at it is like this. So once I created an instance of motorbike called Ducati, a Ducati is created in memory with a space for the value for speed. And similar to that, a Honda is created in memory with a speed. So the motorbike is acting as a template. This template contains a variable called speed. So each of the instances of that template, each of the instances of that class, Ducati and Honda, have their own individual copies of the speed variable. So here what we are doing is we are setting a speed of 100. So we said Ducati.speed is 100. So that's cool. And now we say Honda.speed is 80. Honda.speed becomes 80. Now we are changing Ducati.speed to 20. So what would happen? The state changes 20 and Honda.speed is 0. So this is what is happening. So this is what happens in the memory when we create an instance of a class and change the state of it. In this video, what we have done is we have created an instance variable. So we created an instance variable called speed in the motorbike, and we set different values for it. So we are changing the state of the objects. We saw how this is represented in memory. In this video, we are actually breaking a few good object-oriented programming practices. Don't worry about them. We'll fix all of that by the end of this section. I'll leave you with one exercise. What you can do is go to your book class and you can create a instance variable for storing number of copies of the book. So create an instance variable to store number of copies of the book, and you can use the book runner and set different values for each of the book. So have different instances for Art of Computer Programming, Effective Java, and Clean Code. I hope you're having a lot of fun with this. I'll see you in the next video. Welcome back. The previous exercise was to create an instance called number of copies. We did that and set different values for that. So this was a simple exercise. So I just wrote the code and I just thought I would show it out to you at the start of this video. So there you go. That's the exercise. And let's now continue with the topic for this specific video. One of the problems that we see in the motorbike class is that the motorbike runner class is directly accessing the value of an instance variable of the motorbike. This is not considered to be a good practice because this motorbike runner is a different class. So this is in a different class of its own, and this class is directly accessing internal variables of this class. This breaks something called encapsulation. Encapsulation is the concept that only this class should have access to the data inside the specific class. All the other classes should access data through the behavior of the class, through the methods that the class offers. So the principle is that other classes should not be able to change the data of a specific class directly. If I have to change the state of a class, it should be through the actions, the methods that are performed through that specific class. This is one of the fundamental principles of encapsulation. Encapsulation is data and methods which access the data and set values to it. So all modifications to the data of an object should be through the methods of that specific object. Here what we are doing is we are modifying the data from outside. Let's now fix that. How do we fix that? The way we can fix that is by making this variable private. So when we make a variable private, what would happen is it cannot be accessed from outside this class. So outside the motorbike class, I will not be able to access this speed variable. What is happening here? You can see now that as soon as I put a private in here, it's not allowed to access it. There are a couple of other access modifiers that we will discuss a little later. For now, the important thing is when you put a private on a member variable, only that specific class will be able to access the value of it directly. This is now causing a compilation error. How do we fix it? Think about it. Pause the video here and think about how we can fix this. The way we can fix this is by adding methods which would expose this data out. What we can do now is create a method for setting the value of speed. So how should it look like? What should be the input? So we need to create a method, right? So for the method, what should be the inputs? Whenever we think about method, we should think about what should be the inputs, what should be the outputs, and what should be the name, right? So what should be the inputs, outputs, and the name. So the inputs of this method, what would be the input? The speed, the value of the speed. So it would be int speed. That's the input for this method. The output for that method should be what? What should be the output for that method? We are just setting the value, so we don't really need to do anything. So we'll return void. And the name of the method, because we are setting the speed value, we'll call it set speed. So let's create that method, void set speed and int speed. And what we can do now, we would want to set the value on the speed variable. Whatever is in here is a member variable. Member variables belong to the objects. So member variables are specific to an object. Over here we have another speed variable. This is a local variable of this specific method. So the argument to a method is almost like a local variable inside this method. So whenever we say speed inside a method, what we would be referring to is the local variable. So if you do a system.out.println speed here, let's do that, system.out.println, let's print speed. What we would be printing is the local variable. Now if I do system.out.println, I would want to be able to access this speed. So speed which is present in here, the way I can access that is by doing this dot speed. So whatever value is coming in here is speed, and whatever value is of the variable, it's this dot speed. Now what we want to do is we would want to set the speed of this specific thing. So the way we can do that is this dot speed is equal to speed. So whatever value comes into the method, we would want to set it to this. So what we want to do, when somebody calls dot set speed 100, we would want to take that value and set it to the instance variable. I'll remove this system.println for now. So what we are doing in here is we are creating a method set speed in speed this dot speed. We are accessing the member variable and setting the value from the parameter or the argument. Over here, what should we do to fix this? Dot set speed 100. So we will invoke the method. So instead of directly setting the value, we would set speed 80 dot set speed 20 dot set speed 0. As simple as that. Now you might be asking me, okay, what is the use of this encapsulation? I'm only making the code more complex. So what is really the use of it? I'll leave it as an exercise for you to think about it. What is the use of encapsulation? We'll discuss that in the next video. Another exercise is to update the book class and make sure that it is not breaking encapsulation. I'll see you in the next video. Welcome back. In this video, let's look at the exercise and also the puzzles related to the previous video. The first thing is the exercise, right? So art of computer programming dot set number of copies 100. So that's how we would need to do it. First thing we do is make it private so that other classes will not be able to access it. And over here, we are actually setting number of copies, int number of copies, and we are doing this. This is number of copies is equal to number of copies. And we are able to set the number of copies from here. Now, that's cool. That's your book runner. You can run this and see if it works fine. It should not be any different from what we did for the motorbike runner. Now, let's shift our attention back to the motorbike. What we'll do now is we'll revise the concept which we learned in the previous video about encapsulation and also discuss a few puzzles. What is encapsulation? Encapsulation is basically protecting your object from other objects. You don't want other objects to directly change the data inside your object. What we'll do is we'll create methods around it. So we'll create methods so that other objects, other classes will only be able to use those methods. So if somebody wants to change the speed of a Ducati, they should use the set speed method. They cannot directly go and set the value of something which is private, which is the state of a motorbike. That's number one. This is the basic of encapsulation. There is more to encapsulation. We'll talk about it a little later. But for now, this is one way to properly encapsulate the data inside your class. So you might be having a question. So what we are doing here is we are setting a speed on a Ducati to 100. But let's say I would want to find out what is the speed of the Ducati in here. After this, what is the speed of Ducati? What are this? After this, what is the speed of the Honda? If I would want to find out, how do I do that? The way you can do that is by creating a getter method. So let's go ahead and create a getter method here. So a getter method would get the speed. So the way we can do that is by saying get speed. We don't really need to pass any input because we would want an output. What we would want to do is we would want to get an output. What is the output? Speed. What is the type of speed? Int. So int get speed, and what we would need to do here is say return speed. Return this dot speed. So we are using this to refer to this specific object. Inside the object, return the speed value. Over here, I can do system dot out dot print ln and say Ducati dot get speed. Cool, isn't it? So that's something which I could do. Here I can say Honda dot get speed. Make sure that you get the variable names right. So this is Ducati, this is Honda, and now let's print it. I'll remove the code after this. So set 20, set 0, I'll remove them. So let's have just this and let's run it. So you can see now that bike started, and 180. That's cool, right? So we are getting the speed of Ducati, and that's getting printed as 100, and here the speed of this is getting printed as 80. Now let's get to the cool part right now. So over here, what we did is we manually wrote this, right? So we manually wrote the set speed, manually wrote the get speed. With Eclipse, the great thing is you don't need to do it manually. You can get Eclipse to generate it as well. So what I'll do is I'll delete this code. So I'll press delete. I'll highlight all the code that I would want to delete. So like I don't really need the comments anymore. So I'll remove both the set speed and the get speed methods. Now obviously when I save it, I would get a compilation error because these methods are not there. Now I can get Eclipse to generate it by doing a right click, source, generate getters and setters. So right click, source, generate getters and setters, and if you expand this, you'd see get speed and set speed. So because this is such a standard thing which we keep doing in Java, Eclipse provides an automated way of doing it. So now I can say, okay, cool. You can see that the get speed and the set speed method are automatically generated for you. And the code again compiles. Isn't this cool? You would have seen that earlier to create these methods we needed to spend some time, but now you can see that it's very easy to create these methods as well. So that's a cool feature of Eclipse. That's called code generation, and one of the code generation features is to generate getters and setters. So the way we got it as source, generate getters and setters. Now there are no fields that don't have getters and setters, so it says, okay, buddy, For all the fields, you have getters and setters. So there's nothing I can do about it. So that's cool. That's the second thing that we wanted to talk about in this specific video. In the next video, we will dig deeper. There are a couple of other puzzles that are left out. So let's look at those puzzles as well in the next video. Welcome back. What we'll do now is look at a few puzzles related to whatever we have done until now. I'll comment out these two lines. So we're not printing the Ducati.getSpeed right now. What I'll do is I'll go to the setSpeed method, and in the setSpeed method, I would do a sysout, control space, and print speed and this dot speed. I will also comment out one of the methods in here. So Honda.setSpeed 80, I will comment it out. So now the exercise for you is to figure out what would be the output. So I'm doing a set speed motorbike, and I'm saying speed and this dot speed. What would be the output? Think about it. Pause the video here. Think what would be the output. Once you have decided the output, then play the video. Okay, let's run the program. Run as Java application. So it's printing 100 and 0. Let's see what's happening. This is 100 and this is 0. There are two important things that you need to note, right? So we are trying to set speed. So this method got, so Ducati is created. So over here Ducati is created, and immediately we are calling set speed. So the speed value which we are passing in here is 100. 100 is passed in here, and 100 is the value which is printed out. This dot speed is the default speed which is assigned. So until now we have not really set this speed for this specific thing. That's why it's printing a 0. The default initialization value for an int member variable is 0, and that's what you are seeing in here, and that's why it's printing 0. Now if I do it after this, what would be the output? Think about it. Let's run it again. Motorbike runner, please. Okay, it's 100, 100. So if I do it here, it's 100, 100. Because over here, the speed value is passed in as 100, 100. This 100 is taken and set as the speed for the motorbike. And that's why it's printing 100 and 100. So there are two important lessons that we learned with these two puzzles. The first one is that the initial value, so before this line of code, the Ducati speed is 0, and after this line of code the Ducati speed would be 100. Now what would be the speed for Honda as it is right now? Think about it. What would be the speed for Honda? We have not changed the speed for Honda at all. So the speed for Honda would be 0. Let's do that. So let's try and print that out. So system.out.println honda.getSpeed. What would be the get speed? Run as Java application. It's 0. So if you comment out the honda.setSpeed, the default value which is present is 0. One of the things you can try and do is try and debug this as well. So what you can do is you can say set speed, and I can actually put a breakpoint in here. So you can actually go here, set a breakpoint, and do right click, debug as Java application. So it asks if I would want to start it in debug perspective. Yes, please. So now it starts up in debug perspective, and you can see much more information, right? So let's minimize. So I just need to double click. Again, I can minimize it, and I can see more information around it. So now you can see that I am inside. Where am I? So from the motorbike runner set speed, that's where we are right now, right? So this dot speed is equal to speed. What I'll do is, this might be a little confusing for you, so let's kill this. I'll set one more breakpoint actually to make sure you understand it perfectly. What I'll do is I'll put one more breakpoint down at the start. So at the start of motorbike runner, I have put in a breakpoint. Let's do a debug. So the debug is this one. So debug, which one do we want to debug? motorbike runner. So now if I minimize this, I can see the things in here. Until now, there is no variables here. So now I can do step over, which is function F6. So let's do a step over. What you'd see now is Ducati. A motorbike Ducati is created. And what's the speed of it? 0. That's the initial value which is assigned. So Ducati now has a speed of 0. Now I go and now the next line gets executed. What is this Honda? Speed is 0 again. So now we call the Ducati dot start. So bike started is printed to the console. Honda dot start, again bike started is printed. Now we are calling Ducati dot set speed. What I would want to do here is I would want to go into this code. So what I'll do is step into. So I'm do a step into. So we are inside Ducati right now. So we are inside the code for Ducati object. So there is a variable called this in here. This refers to Ducati object right now. And when I hover in here, you would be able to see that the speed right now is 0. The speed of the variable. So the variable here, the argument which is passed in here has a value of 100. But the speed of the Ducati until now is still 0. What you can do is step over this line of code. This line of code has not been executed until now. This has a speed of 0 and this is 100. So let's go ahead and do a step into. You can see that now this dot speed is also set to 100. So this dot speed is now having a value of 100. That's what the set method is supposed to do. Take the value from here and set it to this dot speed. And now you'd see when I do a step over, you'd go back. And now we can print the get speed of Ducati, right? So the get speed of Ducati, I'll do a step over. You can see that it's printing 100 because I called the set speed 100. The value returned back is 100. We did not call the set speed, it's commented. So what does it do? Step over, it prints 0. That's the default value. And step over again. That's terminating the program. In this video, we'll look at a couple of puzzles related to this and also the initial values for a member variable in the class. Until the next video, bye-bye. Welcome back. In this video, let's look at one of the advantages of encapsulation. Why should you actually have methods and not expose the data directly? The reason why you should not do that is let's consider a situation where set speed is set to minus 100. So what is the speed of Ducati right now? It's minus 100. It's an invalid state, right? Can the speed of a Ducati be minus 100? Nope. If we have methods, what we can do is we can have logic to prevent this from happening. We can say if speed is greater than 0, this dot speed is equal to speed. So what we can do is we can prevent bad code from other classes from putting bad data into your objects. That's one of the most important thing about encapsulation. If you have methods, then you can have validations around what can go into your object and what cannot go into your object as well. What would happen now if I do a right click run as Java application? It has a value, it remains at 0. This value, this change will not get executed. Later, when we talk about exceptions, we can even throw exceptions. Hey, you are trying to do something invalid. You cannot try and set something below 0. So those are the kinds of things that having methods allow us to do. Creating setters is encapsulation level 1. In the next video, we will look at encapsulation level 2. What is that? If you are excited, then I'll see you in the next video. Welcome back. In the previous video, we looked at why encapsulation is needed, right? So we can prevent bad data getting into our objects. So let's fix that. Let's say the speed now is 100. So what is the speed of Honda? At this point, the speed of Ducati is 0. Here it's speed of Honda is 0. Over here, speed of Ducati becomes 100. So at this point, speed of Ducati is 100 and speed of Honda is 0, right? So let's say I'd want to increase the speed of both Ducati and Honda by 100. How do we do that? We'll discuss that, and we'll talk about the next level of encapsulation of how you can encapsulate your business logic even better. Now, let's get to the problem at hand. We would want to increase the speed of Ducati by 100. How I can do it? The first thing I would need to do is get the speed, get current speed, right? So the logic is very simple, right? Get current speed, increase it by 100 and set it to Ducati, right? That's basically the logic. So get Ducati speed, increase it by 100, set it to Ducati. So let's do that quickly. Int Ducati speed, what is it? Ducati dot get speed. Increase it by 100. How do I do the increase it by 100? Ducati speed plus is equal to 100, right? So plus is equal to adds 100 or Ducati speed plus 100. Either of the ways would work. And now we would need to set it to Ducati, right? How do we do that? Ducati dot set speed Ducati speed, right? That's it. Let's now print the speed of Ducati and check what's happening. Okay, it says bike started 200. That's cool, right? Now, if I want to increase the speed of Honda, I can say Honda speed is equal to Honda dot get speed, and I can copy this, paste it in here, and Honda dot set speed. Make sure that you are actually using Honda everywhere, right? I just copied this and changed Ducati to Honda. So everywhere, I mean, this is one of the problems with having a lot of comments. Comments get outdated, right? So let me update the comments as well. Ducati.getSpeed, and let's print Honda.getSpeed as well. Okay, cool. So bike started 200 and 100. So this is printing 200 and this is printing 100. That's cool, right? So now the logic to increase the speed is present in here. But one of the things you can see it in here is the logic is duplicated again and again, right? So if I want to increase this speed by 100, it's becoming complex. This kind of business logic also can be encapsulated inside your object. So what I can do is I can have a method in motorbike to increase the speed. So I'll say public void increase speed. I can say how much. So increase by how much, and I can then take it. I can say this dot speed is equal to this dot speed plus how much, increase by how much. So now what I can do in here is not do all this. So I would need to just say Ducati dot increase speed by how much? 100. And we would want to increase speed for Honda by how much? Increase speed by 100, right? I don't need all these code at all. And now I can run this and I get exactly the same output. And the great thing is we have eliminated duplication in logic, as well as any other class can use this method right now. So this is also the second level of encapsulation, not just creating getters and setters, but going further and thinking about what are the different operations that can be performed on your object. The operation that we are creating in here is increase speed. Let's say you would want to create a method to decrease speed as well. So you'd want to be able to decrease speed as well. So decrease speed int how much? Over here it will be minus. So now we are providing a facility to increase the speed and decrease the speed. Now let's go ahead and say Ducati dot decrease speed by 50, and I'll say Honda dot decrease speed by, let's not do it here, let's do it after the increase speed is done. So Ducati dot decrease speed by 50 and Honda dot decrease speed by 50. So what would happen? What would be the speed which would be printed? Think about it. So 150 and 50. So we were increasing by 100 and decreasing by 50. So it becomes 150. And same is the case in here as well. One of the things you would notice right now is if I actually try and decrease the speed by 250, and here also I decrease the speed by 250. What happens? Aha, speeds become negative again. Why? Think about it, and we'll discuss this more in the exercise solutions video. The other exercise you can try and do is use the book class and add methods to increase the number of copies and decrease the number of copies as well. I'll see you in the next video. Until then, bye bye. Welcome back. In this video, let's look at the exercises that we talked about in the previous video. What is happening in here is increased speed, the decreased speed is decreasing it by 250, and therefore the value is going below 0 and it's becoming minus 150. Why? Because we don't really have a validation in here. Here we were checking the validation, so we were protecting the method from outside, but here we are not checking it at all. So one of the things I can do is add something of this kind, right? So I can say, I can copy this check and say if this dot speed minus how much is greater than, then do this. What would be the output? Let's check this. Okay, that's cool. So 200 and 100. So the decreased speed did not work. But the problem now is the validation is now repeated. So 1 and 2. Can you think of a solution where I don't really need to do the validation again in here? Try to pause the video in here and try to work out how you can try and do the validation without directly coding the validation in here. The way you can do that is by actually calling the set speed. So I can say set speed from here. What would happen? The set speed method would be called. This value is calculated and this is passed to speed, and it would check if its speed is greater than 0, and only if it's greater than 0 it would be setting it to the speed. So this is an awesome thing about encapsulation. Once you start encapsulating all the logic inside your object, you can easily change the logic without making huge amount of changes in the outside code. We can actually do exactly the same thing on the increase as well. So I can say set speed, this dot speed plus how much. This is cool because now we are using the logic. This method is already having the validation and we are making use of it. Now going back to the other exercise, the book one. So we would want to set the number of copies, increase and decrease. So the method should be relatively simple, right? So it should be very simple. Public void increase number of copies int how much. I can say this dot number of copies. I can directly call this set. Let's do that. That's much more easier, right? Set copies, and I can say this dot number of copies plus how much. Right, that's as simple as that. And I'll copy this, Control C, Control V, Command C, Command V, whichever one you like. Decrease number of copies and minus. Over here, you can have a check saying if number of copies greater than 0. Okay, this is the code, right? So as very simple. I'll leave it to you as an exercise to update the book runner class and call these methods and check if they are working fine. In this video, we looked at a couple of exercises related to encapsulation level 2. This is what I call as encapsulation level 2, where in addition to the setters and the getters, we try and get all the business logic related to the object inside the class. I'll see you in the next video. Welcome back. In this quick video, we would want to understand one of the most important concepts behind programming and also object-oriented programming. It's called abstraction. Abstraction is very, very important in our life, right? So when I'm riding a motorbike, for example, I don't really need to understand what's happening inside the motorbike. It's sufficient if I know that this is the key, I would need to put it in and start my bike, and I would be able to use the gears and the accelerator. I don't really need to understand what's happening with the engine and all that kind of stuff. Yep, the engine mechanics would need to understand that, and probably when I get into trouble, maybe I would need that. But for the most part, I would not really need to understand the inner details of the motorbike, right? That's exactly the same concept that comes to programming, right? So what we are doing here is we are writing a Java program. We are not writing machine code. We are not really writing zeros and ones and things like that. All that kind of job is abstracted away. We write Java code behind the screens. The code is compiled, bytecode is generated, and it's run on the JVM. So all that kind of things is abstracted away from us. So that is what is called abstraction. Abstraction plays a key role in our life, in programming as well, and in object oriented programming as well. So what we are doing in here is we are just calling Honda.increase speed. We don't really care how increase speed was implemented, right? So the user of the interface increase speed will not worry about, okay, what is happening inside this. And with object oriented programming, you can actually really provide really good abstractions. Actually, in a way, abstraction is very much related to encapsulation. Encapsulation is related to hiding the data that is belonging to a specific object. We would only allow operations to be performed. We will not allow access to the data. That's encapsulation. And abstraction is a much more generic concept where we try to hide all the complexities. Whoever is using the API, they don't really need to worry about all the complexity. They can just use, they can call the method and assume that it would work. It's very similar to riding a bike and expecting the engine to be working. In this video, we talked a little bit about abstraction and how it compares with encapsulation. Abstraction and encapsulation are some of the fundamentals of object-oriented programming, and we will discuss them further when we get to the level 2 of object-oriented programming. Until the next video, bye-bye. Welcome back. In the previous steps, we understood a little bit about encapsulation and abstraction. In this step, we'll focus on another important concept in object-oriented programming, a constructor. We are actually creating a new motorbike object in here. So we are saying, I would want to create a new motorbike object. And we saw that when we create a new motorbike object, the value of speed was being initialized to 0. Now, let's say I would want to give an initial value directly when I'm creating the motorbike object. I would want to set the speed of this motorbike object to a certain value. How can I do that? So what I would want to do is when I'm creating this motorbike object, I'd want to be able to say, okay, this motorbike Ducati, I would want to have a starting speed of 100. And for this motorbike, I would want to have a starting speed of 200. So how do I do that? What we are doing in here is we are constructing an object. So we would want to be able to construct a motorbike object passing in 100 as a value. I don't want to say dot set speed at a later point in time. That's where constructors come in. Constructor is a special kind of method in the sense that typically when we write a method, we have to specify a return type. However, for a constructor, the return type is not needed at all. So I can actually remove the return type. The name of the method for a constructor is the same as the name of the class. So motorbike, that's the name of the class, and the parameter. So what do we want to use to create this constructor? We would want to pass an integer number, speed in. So I'll say int speed. So now over here in the constructor, what we can do is this dot speed is equal to speed. So we are setting this value to whatever is passed in here. So this dot speed is equal to speed. And when you save it right now, you would see that now motorbike 100, 200, this code compiles. Isn't that cool? So now we are able to actually create a constructor which accepts a initial value. So this is a special method. So constructor is a special method. The difference between other methods and constructor is the fact that you don't really need to have a return type and also the name of the method. So it's exactly the same as the name of the class. You cannot use a different case. So this is not a constructor. You need to use exactly the same case, same name as the class, and this becomes a constructor. Now we can use the constructor to set a initial state for this specific thing. What I'll do now is I'll take this and I'll go to the start over here and say print Ducati.speed and Honda.speed. Let's see what would be the values that are printed. You can see that the initial values are being set to 100 and 200. So 100 and 200, that's the speed that is being set here because we are actually passing in a initial value of the speed. Constructors play a major role in object-oriented programming because when you create an object, you would want to set an initial state for that specific object. The initial state is the values that you would assign to your member variables, and you can assign initial values to the member variables using a constructor. As an exercise, I would recommend you to play around with the book class, create a constructor accepting the number of copies, and let's say when I'm starting to publish a book, I would start with thinking, okay, I would want 1,000 copies of this book. So let's start with 1,000 copies and create a few instances for each of the books in the book runner class. I'll see you in the next video. Welcome back. In this video, let's look at the exercises that we discussed about constructor and also a few simple puzzles about constructor. So the exercise was to create a book constructor. It should be easy, right? So public book int number of copies is equal to number of copies. Don't worry about the public. This code would work even without public. We'll talk about public, private, and all that stuff, which are called access modifiers, a little later. For now, let's see how to use this constructor. So book of 100, book of 50, book of 10. So this is the exercise that we talked about in the previous step. I'm sure this is a simple exercise to complete for you. So let's now move into the puzzles related to constructor. Let's create a simple class. We are in JShell. So let's go ahead and create a simple class called cart. And what I'm doing here is creating instances of the cart, right? So cart1 is equal to new cart. So what would happen? A new instance of the cart is created. But over here, if you look at it, we are calling a cart. This is almost like calling the cart constructor. Whenever you do a new cart, this is almost like calling a constructor method. But there is no constructor method in this class. What is happening in here? What is happening in here is the Java compiler provides you a default constructor. So it's almost as if you are actually creating a constructor by yourself. It's like you're creating a method cart. This is the default constructor which does not do anything. So when you write the class cart like this, it's almost like you are writing this. So you are providing a cart constructor. So now when you say cart1 is equal to new cart, it's the same thing. Now let's write something in the cart constructor and see what would happen. So class cart, and over here let's do a system.out.println and let's print constructor is called. Cool, isn't it? Okay, modified class cart. Now if we create cart1 again, let's see what would happen. Now you can see constructor is called, is printed in here. So when we create a new object, what would be called? The constructor. The code in the constructor would be executed. That's cool, right? Now, the other important thing that you need to understand is the fact that when we add a constructor, so in the motorbike runner, now we have a constructor, new motorbike of 100, right? So let's say I would want to create a third bike, motorbike, something else. I don't really care what it is. You can put in your favorite brand, let's say Suzuki or whichever one you'd like, is equal to new motorbike. And over here, let's say I don't want to initialize anything. What would happen? You can see that there is a compilation error coming up. It's saying, okay, the code does not work. There is no constructor of that kind. What happens is, as soon as you provide a constructor, Java compiler says, okay, you are taking over control, so I will not provide a default constructor. So it will not provide a default constructor when you provide a constructor. So as soon as you provide a constructor, it means Java compiler tells you, okay, you have taken control, so I will not provide you a default constructor. That's the reason why this piece of code does not work anymore. So if you want this to work, then what I can do is go here and you can start creating a motorbike, and this is the default constructor, so I'll not really do anything. As soon as I add this code in, you would see that this piece of code would compile properly. Isn't this cool? And now let's say in the motorbike class I would want to assign a default value. So I would want to be able to assign a default value for speed. So let's say by default, whenever the motorbike is created without specifying a value, I would want to give it a value of 5. How can I do that? One of the ways I can do that is by replicating the code. So I can say this.speed is equal to 5. That's one option. So this would give you a default value of 5. Now, a better option would be to call the other constructor. So I can say this of 5. What would happen? This of 5 would call the motorbike, the other constructor. So the way you can call other constructors from the constructor is by using keyword this followed by the parameter. So this of 5. Now if I do it here, you would see that something else dot get speed. Let's print the output and see what would happen. You can see that the number here is 5. So 5 is getting printed for this because what we have now is from this constructor we are calling this one. There you go. Those are the important things I would want to talk about in this basic version of constructors. We will again return to the topic of constructors at a later point in time when we talk about superclasses and the complexities down there. But for now, the important things that you need to understand is whenever you create an object using new, the constructor is called. If you don't provide a constructor, then Java compiler provides a default constructor, and that's why we are able to do this. And when you provide a constructor, so as soon as you start providing a constructor like this, Java compiler will not provide the constructor anymore. The default constructor will not be available, so you have to provide a no argument constructor. This is called a no argument constructor because this does not have any arguments. The third thing that we learned was this to call other constructor. So from this constructor, I'm calling other constructor by using this. I'll see you in the next video. Until then, bye-bye. Welcome back. In this section, we looked at a few important concepts related to object-oriented programming. We discussed about class, instances of a class, that is objects, how to add data to a class, how to add behavior to a class, and we also got an introduction to two important object-oriented concepts, encapsulation and abstraction. I would recommend you to try and think about a few possible objects. Try and think about a flight. What would be the data you would have? What would be the operations that would be performed on it? Try and think of a shape like a rectangle. What would be the data that would be present? What would be the methods that would be present in that kind of a class? Think about something like a movie. what would be the data you would want to store about it, what would be the operations that you would want to allow on it. So think about a wide variety of objects and think about what would be the data and what would be the behavior. That will help us when we go into the future sections. I'll see you in the next section. Until then, bye bye. Welcome back. Welcome to this section on primitive data types in depth. The idea behind this section is to explore the primitive data types in depth. Until now, in this course, we have already talked about integer data types, floating point data types, Boolean data types, and the character data types. In this section, let's go in depth with them. We'll talk about the different literals. We'll talk about all the operators that you can use on all the primitive data types. And we'll talk about converting between these data types. How do you convert an integer to a float, or float to an integer, or character to floating point? Is it really possible to convert Boolean to integer and things like that? And also, we'll try and use these primitive data types in different classes. In the previous section, we learned about object-oriented programming, how to create a class. So let's use these primitive data types in different classes. I'll see you in the next video where we would get started with the integer data types. Until then, bye-bye. Welcome back. In this video, let's start talking about the integer data type. We already used a number of integer data types. We talked about byte, short, int, and long. So we used int a number of times, long a few times, and we also discussed about the sizes of each of these four. So these four are called the integer data types, right? So these can store values like 1, 2, or -1, -2 up to a certain range. So how do I find the range of each one of these? There are specific classes in Java called wrapper classes. So these wrapper classes contains details about the size of each one of this. So the wrapper class for byte is something called byte. So if I want to find the size of a byte, I can say byte dot size all in caps. So byte dot size. Will this work? Nope, because I'm still in the terminal. Let me log into JShell. So let's log into JShell before I would be able to type in a command. Make sure you are in JShell. That's cool, right? Now I can type in byte dot size. So byte dot size, it returns a value of 8. This is returning the size in bits. So if you really want to find the size in bytes, then you can type in byte dot bytes. A byte data type has a size of 1 byte. I want to find out what is the maximum value that can be stored in a byte. Byte dot max underscore value. Make sure that you are typing in all these in caps. That would return you what is the maximum value that I can store in a max, and also you can find out what is the min value. It's -128. Similar to byte, you have wrapper classes called short, integer, and long. One thing you need to remember is the wrapper class for int is not just int, it's integer. So short, integer, and long. So you can use these wrapper classes to find out the size of each one of them, or number of bytes, or the max value. I'll just quickly type in short.bytes. You can see that its size is 2, and if I do integer.bytes, you would see that it's 4, and if I do long.bytes, you would see that it's 8. So these are all showing the size of the integer primitive variable types. In summary, byte is 1 byte, short is 2 bytes, integer is 4 bytes, and long is 8 bytes in length. Based on your problem at hand, you would choose one of them based on the max values that you would want to store. For example, integer.max value is the max value you can store in an integer. So if you want to store a value greater than this, then you would go for a long. If you want to store a value which is greater than a short, the max value of short is 32,767. If you want to store a value which is greater than the short maxed value, you would go for a int. So that's one of the important decisions that you need to make. So make sure that you understand the max values and make a decision based on the max value, whichever type you would want to choose. Let's now type in a simple line of code. So int I is equal to, let's say 100,000. By default, all integer kind of literals have a type of int. So if you want to create a long literal, then you would need to actually add in a L. So long L is equal to, let's say, I'm creating a big number. If I do this, this would give an error because this is a integer. So by default, all literals are considered to be a integer. If you want to make it a long literal, you need to add an L to it. So now this becomes a long literal. I cannot take a larger value and try and put it in a smaller variable. So here long L, I cannot say int, I cannot say I is equal to L, for example. It says lossy conversion type. So long is a bigger type. I cannot take a bigger type and put it into a smaller type. You can almost kind of think of these as containers. This is a large container because this is 8 bytes and this is only 4 bytes. Int is 4 bytes, long is 8 bytes. So you cannot take a 8 byte value and put it inside a smaller value. So in these kind of situations, if you are sure and you would want to take the risk, then you can do something called casting. So you can say, okay, compiler, don't worry about it. I know L has the right value. You can add a cast. This is called an explicit cast. So what you are doing here is taking a value of I and putting it in L. So now you would see that I has a different value. The important thing is not to worry about the value, what exact value, but the fact that you can actually cast a value which is of larger type into a smaller type by explicitly doing it. However, when you're doing the reverse, so when I say L is equal to I, what would happen? Whatever value is in I will be copied to L automatically. This is called implicit casting because I has a smaller value, it can be stored in a larger container. So larger container in the sense L is container is long 8 bytes, I is int 4. So I can take a value which is 4 bytes and put it into a long value. This would work out fine. So this is called explicit conversion, wherein we are actually doing a explicit cast, and this is implicit conversion where the compiler recognizes the fact that I is a smaller value, I is a int, so it can only have 4 bytes, L is a long, which is long, it can store multiple values, and so it can store. We'll look at a number of puzzles related to casting in the next video with puzzles. Now let's move on to discussing about the operators that are possible on integer numbers. So that's in all the integer types. So it's plus, minus, division, multiplication, modulus. This is the increment operator and this is the decrement operator. There are a few small differences between the increment and decrement operators. Post increment, pre increment, post decrement and pre decrement. We'll discuss them during the puzzles, but in the basic level we have already discussed about all these operators. What we have done in this video is just took a quick look at the different integer types. We talked a little about implicit casting and explicit casting and also about the different integer type operators. What we'll do in the next video is we'll try and play around with this with a number of puzzles. Until the next video, bye bye. Welcome back. In this video, let's look at some of the puzzles related to integer representations. We talked about the basic integer representations being byte, short, int, and long. We talked about their sizes, maximum values, and things like that. Let's start with a very simple puzzle. So let's start with int 8 is equal to 0, 1, 0. So I'm doing this. What would be the value that would be in the variable which we are naming as 8? Think about it. Okay, I executed it. It says 8. Let's do something else. 16 is equal to 0x10. Cool, right? So 16 is now it's showing us 16, right? How is it getting a value of 16? The thing is, in literals, In Java, we also support something called octal and hexadecimal. So in octal representation, 010 is actually 8. So 10 is 8. So anything starting with a 0 is an octal number. Anything starting with a 0x is a hexadecimal number. So if you have heard about number systems, there are wide variety of number systems, right? Binary number system, decimal number system, you have octal number system, and you have hexadecimal number system. The important thing is in Java, we support all of them. The basics of each number system is, for example, let's take an octal number system. It will only have numbers from 0 to 7. The one which we frequently use is the decimal number system, right? In decimal, each of these digits can be 0 to 9. And in hexadecimal, the hexadecimal is 16 values. So hexadecimal, the valid values are 0 to F. So the last digit 0 to 9 followed by A, B, C, D, E, and F. So these are all the valid alphabets in a hexadecimal number. A represents 10, B 11, C 12, D 13, E 14, and F represents 15. So we can give it a try now. So what we'll do is we'll create a hexadecimal number using this. So int, let's say 15 is equal to 0. You can use x caps or x small. Either of them is allowed. 0x and followed by f. You can see that it stores a value of 15. Okay, all these are important more from a certification perspective, more from a puzzles perspective, but do not try and do this in a normal program because you might confuse other programmers who are reading your code. You need to be aware of the fact that multiple number systems are represented. You can convert from one to another, but the most important thing is don't make your code complex by using them unless they are absolutely necessary. Now, let's see a few error kind of a situation. So int, let's say 8 is equal to, let's say I say 0. I'm saying it's octal, but I'm saying 9, 9. What do you think would be the result? Error. Or even if I say 0, 8, it's an error because in octal representation, anything starting 0 is a octal representation. In octal representation, the digits can be only from 0 to 7. You cannot have a digit called 8 or you cannot have a digit called 9. And similarly, you can have variables int big is equal to, I can say 0x BBAACC. This does not look like a number at all, but actually in hexadecimal, this is really a number. So in hexadecimal, as we talked earlier, the valid digits are 0 to 1 and A, B, C, D, E, F. So this is kind of an accepted thing. Now let's try something else. Byte B is equal to 128. Can I store 128 into a byte? No. What would happen? It would say error because by default this is an int and you cannot store an integer value into a byte. The same thing would happen when I try to store a large value into short. So let's say S, it would give us an error. You can store values within that specific range. So you can store values within the range of short, but you cannot exceed that. So we already discussed the max value for short, which is 32767. So you can store a value up to 32767, but not more than that. Let's say I have an integer variable with value 3, 4, 5, 6. Can I take it and put it in a short? Can I say, okay, short can have 32767 and integer has a value of 3, 4, 5, 6. Can I do this? Can I say short s is equal to I? The answer is no. If you're using a variable, I is a variable in here, then Java will actually see the size of them. So size of I is size of int, which is how much? It's 4 bytes. Size of short is 2 bytes. You cannot take a value which is of 4 bytes and put it into something which is of a 2 bytes length. What you can do is do something called explicit casting. You can say, okay, compiler, don't worry about it. I will do a cast myself, and this would, oops, I did a mistake. Actually, it should not be int. So I should say short. I can say compiler, don't worry. I'm using a short, so I know I has less value. I'm okay with it that it's converted to short. And now S is having a value of 3, 4, 5, 6. This is called explicit casting. Now I can actually create another variable I1 is equal to s. So s is short, I is integer, but this is allowed because s is a smaller value and I is a larger value. I1 is a larger value. So I1 is 4 bytes, s is 2 bytes. So this is called implicit conversion. The compiler does that for you. The way you can remember the casting, implicit casting, explicit casting, all that kind of stuff is very simple, right? So you cannot take a larger value and put it into a smaller value. So you cannot take a bigger cup and put it in a smaller cup. So your integer variables are bigger cups, short variables are smaller cups. So whenever you have to take a bigger cup and put it in a smaller cup, then you need to explicitly do a cast. However, if you're taking a smaller cup and putting it into a larger cup, okay, compiler says, don't worry, I'll take care of it. This is called implicit casting. The last thing we want to talk about is increment operators. There are two types of increment operators, right? Post increment and pre increment. So let's quickly see what it is all about. So let's say I'm creating a value I with 10, right? And I'm saying int j is equal to I plus plus. So this is post increment. You can see that j is assigned a value of 10. However, if I type the value of I, it's 11. So the value of I is incremented, but the value of j is the value of I before the increment happened. So j gets the, in a post increment operator, first the operation is executed, first assignment is executed. So I gets, j gets the value of I and then the increment happens. So j gets a value of 10 and I gets a value of 11. However, let's do the same thing. I is equal to 10. Now int j is equal to, I'll do a pre-increment plus plus I. What would happen in this situation? J gets a value of 11 and I also has a value of 11. This is because this is pre-increment. So before the operation, before the assignment happens, the increment happens. So first plus 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 I happens. So I value is 10, 10 becomes 11 and 11 is assigned to j. So this is pre-increment and this is post-increment. And now I would actually let you guess the values for pre-decrement and post-decrement. So int I, so let's take int j is equal to I minus minus. What would the value of j and what would be the value of I? Try and guess it. Yep, you are right. So this is post decrement. So first the operation happens, then the decrement happens. The operation is j is equal to I. So j gets a value of 10 and then I is decremented to 9. Now if I do the reverse, I is equal to 10 and int j is equal to minus minus I. What would happen? Think about it. Yep, you are right. This is pre-decrement operator. So before the operation, the decrement happens, minus minus I gets a value of 9, and then the operation is executed, 9 gets copied into j, so j gets a value of 9, I is equal to 9. Congratulations! In this video, we looked at a wide variety of operations that you can do on the integer data types. We talked about conversions, casting, implicit and explicit. We talked about decrement and increment operators. And also, we took a look at what are the kinds of values you can store inside each of these integer data types. I'll see you in the next video. Welcome back. In this short video, we'll discuss a simple exercise using the integer data type. So we would want to combine the integer data type with the concepts which we learned about objects and methods earlier. So what we would want to do is we would want to create a class called by number. What I have here is the code which should be in the method which uses the class. So what we want here is to create a class called by number. We should be able to pass two parameters to the constructor and we should be able to call the add method, multiply method. The add method should return 2 plus 3, 5. Multiply method should return 2 into 3, 6. And also you need to have a method called double. So numbers.double should actually double the value of each of these inside the by number class. So 2 should become 4, 3 should become 6. And when I do numbers.getNumber1, it should return 4
because 2 into 2 double, so that's 4, and this should be 2 into 3, that's 6. So I would recommend you to pause the video here and try and do the entire exercise on your own, and then we can check the solutions out. Okay, I'll go ahead and now implement the solution for this. So what I do now is I would actually show you a easier way of doing things. So what we'll do is we'll try and get Eclipse to do everything for us. So I'll start with copying this piece of code. In Eclipse, this is a new section. So let's create a new project, Control N, new Java project. I would want to call this Java primitive data types in depth. That's the project name I'm giving it. I don't need to change any of the other stuff which is in here. So I'll go ahead and click finish. Now over here, I would want to create a new source file. So we want to start with creating the main method. So main method, we would typically put it in the runner class. What I'll do is I'll create a new class, Control N, new class, and the package I would want to give it com.in 28 minutes dot primitive data types, and I would want a main method created, and I would want this to be a runner class. So I would call it, the class that we would want to create is by number. I'll call this by number runner. So by number runner, I've copy pasted the code from the exercise. So you can also type this whole thing in. So before you do anything, try and type this in. There'll be a few compiler errors, so don't worry about that. Let's see how to get Eclipse to do the entire magic for us. Now, hope you have got a chance to type everything out. And now what we can do is we can ask Eclipse to fix the compilation errors. Come over here and press Control 1 or Command 1. So press Control 1 if you are on Windows, Command 1 if you are on Mac. Eclipse offers suggestions. It says create class by number. Let's go ahead and do that. Okay, by number, that's fine. I'll not change anything for now. Let's go ahead and say finish. Now the class by number is created for us. So that's cool, right? Now let's go to the by number runner again. When you save the by number runner, you'll have more compilation errors. Let's go line by line. So the first compilation error here is it's saying constructor by number is not defined. By default, only the default constructor is provided, which accepts no arguments. But over here we have two arguments being passed in. So what I would need to do is I would need to now create constructor. So go over here and press Control 1 or Command 1. It would say create constructor by number int. So let's go ahead and do that. So public by number int. I would want to call this number 1. Just I'm tabbing out. So as to tab in, you can type in stuff. So number 1, number 2. Now I would want to create member variables to store them in. So private number, private int number 1, and I would say private int number 2. Now I would want to store the values into this. So from the arguments, I would want to store it into the member variables. So this is what number 1 refers to the member variable. Number 1 is the argument, and same line of code again. This dot number 2 is equal to number 2. That's it. So now we have our constructor ready. Isn't that cool? Now number 1 numbers dot add. I would want to create a numbers dot add method. So let's go ahead and say Control 1 and create method add. Now the thing is, when we try and create the add method, it's trying to generate public char something add. So what I'll do is I would want to return a int back, integer, which is the sum of these two numbers. So let's remove this line. Control D or Command D would remove that line, and now I want to return the sum of these two. So number 1 plus number 2. This would return the sum of these two numbers back. Typically the way we would do that is int sum is equal to number 1 plus number 2, and we can actually return a sum back, right? So instead of that, what we can do is actually, instead of creating another variable, I can directly return number 1 plus number 2. You can try and debug and see what would be the difference between these two options. You would see that actually there is not a lot of difference between them. So return number 1 plus number 2 would return the addition of both.
So that's cool. The next one, multiply should be very easy. Create multiply. I would want to return an int back. So over here, think about it, nothing different from here, right? It should be number 1 into number 2. Let's move on to by number. This gets compiled. That's cool. Now, I want to double both the numbers. One of the things is you cannot use keywords as name of the methods, name of the variables, or name of the class. So this is an error that I have in my problem statement. I wanted you to recognize the fact that this is a double and this cannot be the name of the method. Typically, in situations like this, I would probably add something like numbers.double value. Okay, now let's go ahead and do a double value, create method double value, and control 1 command 1 create method double value. And what I would do is here we would need to double the value of numbers, right? This dot number 1, how can I double the value? Star is equal to 2, and same thing with number 2. So what would happen? The value of number 1 and number 2 gets doubled. That's cool. So now that's good. The last thing that I'm getting an error on are the getters and the setters. Now I can actually get Eclipse to directly generate the getters and setters for us. How do we do that? Right click, source, generate getters and setters, and number 1, number 2. Okay, we have the get number 1, set number 1, get number 2, and the set number 2. So let's save this. That's cool. And now I can actually run this entire program and see how it goes. Alt Shift X, run Java application. 5, 6, 4, 6. So this is 2 plus 3. This is 2 into 3. That's getting printed as 6. And get number 1, we have double the values in here. So this is becoming 2 into 2, 4. 3 into 2 is 6. So this would print 4 and this would print 6. So that's the output of our by number runner program. I hope you had an interesting time running this program. The important shortcut is command 1 or control 1. Whenever you have a compilation error, you can go ahead, put your cursor there and press control 1, command 1. Eclipse offers you options. So you can see that a big chunk of the code for this method was auto-generated. And that's how you can become a productive programmer. So in this step, in addition to creating a class around 2 numbers, we also learned a little bit about how to get more productive with Eclipse. I'm sure this was interesting for you, and I'll see you in the next video. Until then, bye-bye. Welcome back. In this video, we would start discussing about floating point types, right? So we already discussed a little bit about them. 34.5 is a floating point value. That's basically a value with an integer part as well as a decimal part, right? So I can create values like 34.5, 6, 7, 8, 9. So these are all floating point values. There are 2 data types in Java for storing floating point values. We talked about them, double and float. By default, the type of a floating point literal, this is a floating point literal, floating point constant. The type of a floating point literal is actually double. It's not float, it's double. So if I try to do float f is equal to 34.5, it would throw me an error. It says, okay, nope, this is a double, cannot store a double into a float. Why? Because the size of float is 4 bytes, whereas the size of double is 8 bytes. The same rules that we talked about during integer also apply for double and float as well. So the same rules for integer data types applies for floating point data types. You cannot take a big value and put it into a small value. Double is a big value, 8 bytes. Float is a small value, 4 bytes. So you cannot take 34.5 and put it in a float. So the way you need to create that is by saying either 34.5f or 34.5 capital F. Now this is a floating point literal. So that's the basics, right? So when I actually want to create a double value, it's very easy. So double is equal to 34.5678, right? So that's pretty cool. And any floating point operations, the result is always a double. I have a value in double variable and I would want to store it to a float. What can I do? We need to do conversion, right? So let's say I would want to create a float f2
and I would want to put the value of double in it. Error, because this is not allowed. Obviously, you are taking a big value and putting in a small value. That's not allowed. So you have to do a explicit cast. So the explicit cast is to say float. Okay. And now the double value can be stored into a float. Let's talk about the different operators that you can do on float. Actually, you can do all the operators that you can do on integers. You can also do them on double. So I can do something like double plus plus, or you can do double minus minus, or you can also do things like double mod 5. So all the operators that we talked about, plus, minus, division, multiplication, modulus, post increment, pre increment, all that operators which you can do on integers, you can also do on floating point data types. Now let's try and convert a floating point data type to an integer data type. So let's say I would want to create an int I with the value which is in float f2. What would happen? What do you think will happen? Int I is equal to f2. It would throw an error because f is a floating point. You cannot take a floating point value and put it in an integer data type. So when 34.5678 is stored into an integer, integer can only store 34. It cannot store 34.5. So we should give an explicit cast. So now I can say int I is equal to, I'm doing an explicit cast saying I would want to use the integer part of f2. Now 34 gets stored into I. So basically what is happening here is the value of 34.5648 is truncated. Only the integer part is stored in I. Now the reverse on the other hand, so if I say float f is equal to I, so that's allowed. That's not a problem because this is a widening conversion, right? So you are taking a number and putting it into a floating point. That's not a problem. You can always take an integer and put it into a floating point value. Similar situation is with integer and double as well. So the exact same thing that we are doing in here would happen with doubles as well. There you go. Those are some of the important things that you need to understand about the floating point data types. I'll see you in the next video where we would be talking about why you should not use double and float ever. So I'll see you in the next video. Welcome back. One of the most important thing about floating point data types are they are not really accurate. So you cannot really use them in a financial calculation. In this video, let's discuss more about it and understand what are the alternatives you have. So for example, if I'm doing a very big arithmetic operation, plus 34.2234. What is the result? You can try and add them up. So you can try and take this and add this value in here. And this is the value which is coming out. So you can see the 99999s in here, which I don't have anywhere. So where are all these coming from? This is a result of something called how floating point values are represented. So the floating point representation does not allow accurate representations of your decimal values. So it is recommended that you don't use any of the floating point data types, either float or double, in calculations where you would want exact accuracy in terms of the results. When you would want exact accuracy in terms of the results, you need to go for something called a big decimal. So how do I create a big decimal? So I can create a big decimal by saying new big decimal. Big decimal is a class in Java. So in Java, you have a class called big decimal. You can pass a string value to this. So I'm going to pass in a string value 34.7, and this is how you can create a big decimal. So I'll call this big decimal number 1 is equal to new big decimal of string value. We will talk about why we have to pass a string value and not a double value a little later. So number 1 has this value. I can create a number 2 as well, right? So I can create a number 2 with the value we would want to actually have. 34.2234. That's cool. So now I can actually do operations like number 1 dot
add number 2. Now you can see that this result is much more accurate. So you can try and add this in and you would see that the number. One of the important things is in Java, the big decimal class is a immutable class. What does that mean? Big decimal number 3 is equal to number 1 dot add number 2. Let's say I'm doing this. The number 3 has a value of 68.7, which is this sum. That's what we saw earlier, right? So if you look at number 1, the value remains the same. So you cannot change the value of a big decimal object once you create it. You can only create new variable. So over here what we are doing is number 1 dot add number 2. It's creating a new variable called number 3. You cannot change the value of number 1 or number 2 or number 3 once the variables are created. These kind of values are called immutable values. We will talk about immutability in depth when we talk about string and wrapper classes a little later. Don't worry about it. So the way you can remember it is an immutable class, you can only assign it a value once. Once you put a value in an immutable class, you cannot change the value of it. What are the other operations you can do with big decimal classes? You can type in number 1 dot and press tab. So number 1 dot and press tab, and it shows a wide variety of operations that you can do with the big decimal class. This is kind of a shortcut, so if you don't know what methods are there in a specific class, you can press the name of the variable dot and press tab, and then you would be able to see all the different values. Cut, and then you'd be able to see all the different methods that are present in a specific class. Now over here you can see the add method which we made use of. You have a divide method, you have a max method to find the maximum of 2 values, and also you have a lot of other methods like subtract, multiply, find the minimum. I would recommend you to try and explore some of these methods as an exercise. Now let's get back to how we created the big decimal numbers, right? So we said number 1 is equal to big decimal of number 1 and number 2 is equal to big decimal of using a string. So in both of these we used a string. The thing is, if you try and create this number, let's create new numbers. I'll call this number 10 is equal to new big decimal. I'm creating using a, you can see that there are no double quotes. I'm creating using a double. By default it's a double literal, right? So number 10 is this, and let's create a number 11 as well using number 2's value. Oops, we'll use number 1's value, number 11, and we'll create it as a double. So let's see what would happen now. So you can see both of these I'm not using double quotes. So you can see how it's represented, right? So number 10, the value inside that is not really accurate because I'm using a double. And the same thing in number 11 as well. It's not really an accurate representation of what I would want. If you really want an accurate representation, the way we would need to do it is use a string. So use a string, then you would get exactly the same value represented in there. So whenever you're using big decimals, whenever you're getting a value, a hard-coded value into a big decimal, always use this string constructor. Here we are passing in a string to the big decimal constructor. If you pass in a double value to a big decimal constructor, you will definitely not get an accurate result. In summary, whenever you are trying to use float or double in a financial calculation, stop yourself and start using big decimal because that is more accurate. And always when you are hard coding values in a big decimal, use a string. String gives you accurate results. Do not use the floating point constructors of the big decimal. I'll recommend you to play around with other methods which are present in the big decimal class, and I'll see you in the next step. Welcome back. In the previous video, we looked at the basic floating point types and we looked at an important class called big decimal. Typically, when you want to do floating point calculations, which you would want them to be accurate, you would use big decimal. Now, in this small set of puzzles, let's dig deeper into big decimals, we would want to do a few calculations. Let's see how we can do that using a big decimal. Let's say I'll create a big decimal number. So big decimal number is equal to new big decimal of 11.5. We will always use string for big decimal because if you use a double, it's not really accurate. So now I have a number. Now I would want to add another big decimal to this. How can I add that? Let's say big decimal number 2 is equal to new big decimal of 23.45678. We saw that in the previous lecture, right? So number dot add number 2, right? So that's cool. Now if to this I would want to add a integer, so I have an integer value int I is equal to 5. Now to the number I would want to add integer value 5. How do I do that? So number has a value of 11.5. Let's say I would want to add integer. Can I do number dot add I? Nope. It says error. Int cannot be converted to big decimal. You can only add a big decimal with another big decimal. It's saying nope, you are not allowed to do that. If you want to do that, you need to actually create a new big decimal. So for I would want to create a new big decimal. How can I do that? New big decimal of I. So there is an integer constructor. So there is a int constructor for big decimal which accepts that in. And now you can see that I can add number dot add big decimal of 5. 11.5 I'm able to add 5 and now this becomes 16.5. Similarly, if you want to do any other operations, let's say I would want to do a multiply. I would need to actually create a new big decimal value. So only if you have a new big decimal value, you can use that to perform operations on a big decimal, because that's how the methods in big decimal class are defined. Let's say now I would want to divide the number by 100. How do I do that? Can I say number dot divide by 100? Nope, that's not allowed. You actually need to again create a new big decimal of 100. In this short video, the objective was to play a little bit with the big decimal in JShell. Now that we have done that, we are ready to move on to the exercise. I'll see you in the next video. Welcome back. Let's look at the exercise for the floating point data types. We looked at the basic ones, float and double, but we would want to use big decimal because big decimal is the right way to do any floating point calculation. What we want to do in here is to calculate the interest, simple interest. So you're given a loan. So let's say I'm giving a loan to somebody, and let's say the loan is for a specific amount of time, and there would be interest charged on that, right? So let's say the interest is 10% and I'm giving the loan for about 5 years. So the simple interest is what would be the total amount after the entire duration. Simple interest is one of the ways of calculating it. There is something called compound interest, which is much more complex. Let's keep it simple with simple interest. I would want to create a simple interest calculator class. So simple interest calculator class, the constructor of it accepts two string values. I would want to pass the principal as a string, and also I'd want to pass the interest as a string. And what I would want to do is I would want to do a calculate total value. So I would want to calculate total value for and pass the duration as the number of years. So this is the principal over here. So principal is this, interest is 7.5, and number of years is the value which is passed in here. So I would want to calculate the total amount. One of the things that you need to remember is 7.5 here is actually representing 7.5 by 100. So if you look at the 7.5 percentage, so it's 7.5 by 100. So when you take interest, take that into account. So this should be divided by 100 to get the actual interest representation. At the end, we would want to print the total sum. One thing you can note is I'm trying to get the output as a big decimal value. You can actually try and type this code in a simple interest calculator runner and try and do the same method that we followed for the by number class. You can pause the video and give the exercise a try. Now I'll continue with the solution. Let's copy this. I'd want to start with creating a new class, right? So we would want to start with creating the runner class. So this is simple interest calculator runner. And I would want the main method because this is a runner class. And over here, let's remove this and paste the code in. So the simple interest calculator class is not yet there. Go here and press Ctrl 1 and say create class simple interest calculator. Let's use the same package name com in 28 minutes primitive data types. This is not really primitive data type in the sense that we are using big decimal, but that's okay. Go ahead and finish. Now the class is there. I'll go ahead and say again Ctrl 1 or Command 1 on this, and I would say create constructor. So let's create the constructor. This is taking a string. So the first value which is coming in is principal, and the second value which is in here is interest, right? So there is a reason why we sent in string values, because using big decimal is not accurate. That's the reason why we are asking the inputs in terms of strings. And once I get a string input, I would want to actually store it in terms of big decimal, because that's the way we would want to store any floating point value. So big decimal principal is equal to, you are getting a compilation error. That is because of something called a import. So this is a class which is defined in Java, and to be able to use it, we would need to import the package where it is present. So just go ahead and press command 1 or control 1. You would get option import big decimal. Just press enter. It would add in a line import java.math.bigdecimal. So if you want to use any class in Java, you would need to do a import. So I want to make a big decimal class, I would need to do an import of big decimal. There are a few exceptions. There's a package called java.lang which is imported by default. So anything inside java.lang you don't really need to import. Other than java.lang, all other classes you need to import to make use of them. So here we have a big decimal principal, and we would also want to create a big decimal for interest, right? So now I can say this dot principal. Here we have a string value. How can I convert into big decimal? Yep, new big decimal of principal. That's it. And I'll copy this and also do the same thing for interest. So we have now principal and interest set into our class. So we have a constructor defined. That's cool. I'll go ahead and save this. Now you can see that the constructor is working. We are able to create the object. Now we would want to calculate the total value. So let's go ahead and the first thing I will try and do is import the big decimal in here. So I'll press Ctrl 1 here, import big decimal. Now I would go ahead and try to resolve this. Ctrl 1 or Command 1. And I would say create method total value. So you can see that the return type is automatically populated as big decimal. This is being picked up from this. So you know, in the statement that we wrote, we are trying to return a big decimal value. So what it's doing is, when it's creating the method, Eclipse automatically says, okay, you're trying to return a big decimal value. That's cool. Control D, remove this, Command D. Calculate value, calculate total value for, this is I, right? So I is number of years. I would always want to make the variable names very specific, so it's very easy for us to understand them and return it back. So what we would want to do is find the total value. Find the total value, right? So the formula for total value, let's look at it, is total value is equal to principal plus principal into interest into number of years, right? So that's basically the thing. And here we are using big decimal. So we cannot use the direct basic operations. You cannot try big decimal plus big decimal. For example, over here we had created variables number 11, number 10. So you cannot say number 10 plus
number 11. That's not allowed. If you want to add number 10 and number 11, you have to use the method add. So your plus operator is not really defined on Java types like big decimal. So if you want to do that, you need to say number 10 dot add number 11. Or if you want to do a multiplication, you need to do number 10 dot multiply number 11. That's how you'd be able to do the operations. So now let's get back, and over here we would want to do this. So now we have the principal dot add. Now I would need to add the entire thing, right? So the calculated value of this. So principal and dot multiply. Now I would want the interest. So where is the interest? Interest is in the interest. And after that, again, I would want to multiply number of years, right? Number of years here is in a integer. So if I type in number of years, will this be successful? It says, nope. To be able to multiply, you would need a big decimal. That's what it's saying. So I'll create a new big decimal in here. So new big decimal of number of years. So if this is looking complex, do not really worry about it. I'll split it up. So principal dot add dot multiply. So what we are doing in here is we are doing a multiplication of these two. So first thing is to take multiply interest, and after that we would want to multiply number of years, but there is no method which accepts an integer. So we need to convert the integer into a big decimal. The way we can convert the integer into big decimal is by using a constructor, new big decimal of number of years. Or you can even make it much more simpler by creating a variable. So I can say big decimal number of years big decimal is equal to new big decimal of number of years. Now I can use this inside in here. So what we are doing is we are adding to the principles, principal dot multiply of interest dot multiply of number of years big decimal. One of the things which we forgot to do earlier is this interest is like I'm setting 7.5, but actually when I'm using the calculation, I should divide it by 100. So I can say dot divide by new big decimal of 100. So over here, that's the entire thing. So now over here, I would want to actually return this big decimal total value is equal to this and return total value back. Now I'll go to the runner and save it. Hopefully everything's successful. Here actually it should have been total value. I made a mistake. So that's the whole thing. Now you can run this. Run as Java application. Okay, the output is 6187.5. That's the total principal that somebody has to return me back if I lend them 4,500 at a simple interest of 7.5% for 5 years. In this exercise, we started using big decimals to do operations. We tried to create a simple interest calculator with big decimals and tried to calculate the values of a simple interest for a simple loan. A number of conversions typically need floating point values, right? So if you want to convert things like kilograms into pounds, or if you want to convert kilometers into miles, all that kind of stuff need floating point calculations. I would recommend you to try exercises like that and see if you have any problems with them. Until the next video, bye-bye. Welcome back. In this video, let's dig deeper into the Boolean data types. We discussed the integer data types, we talked about the floating point data types, and it's time to get into the Boolean data types. Let's look at what are the valid values for Boolean data types, and also we will look at the various operators which are present with the Boolean data types. Let's get started. For a Boolean data type, this is how you define it, right? Boolean is valid is equal to true, or you can say is valid is equal to
false. Oops, I typed in is value. Let's fix that. Is valid is equal to false. The important thing is it's case sensitive, so you cannot put a f caps or all. These are all invalid values. So this is an invalid value, this is an invalid value. The same thing you can try with true as well. So the most important thing is true and false are case sensitive literals. So the two basic Boolean literals are true and false as you see them in here. You cannot change the case of even one alphabet. As far as the operators on the Booleans are concerned, those are called as logical operators. The Boolean operators are very important because these are what are used in conditions. In our programming, we write a lot of conditions, right? If conditions, else conditions. For loops, also we have conditions. Also, we'll be talking about while and other kind of loops later where we will use conditions. So conditions are very important because in programs you would want to write conditions and branch to different parts of the code. The operators on these kind of conditions are what are called logical operators. The result of a condition is always true or false, and you can combine two Boolean values by using a logical operator. Let's say int I has a value of 7. Earlier, we looked at conditions like I greater than 7. What would the value? Is I greater than 7? False. I greater than equal to 7. True. I less than 7. False. I less than equal to 7. True. These are all relational operators. You are doing a comparison using the relational operators. The result of a relational operation is a Boolean value. The other relational operator that we talked about earlier is equal to is equal to. So I is equal to 6. Is I value 6? No. Is I value 7? Yes. Is I value 8? Nope. Always be cautious. This is not single is equal to. Single is equal to is assignment. So it's actually assigning I a value of 8. Let's assign the value of 7 back. If I want to compare with the value of 7, then I would want to do a I is equal to 7. Now let's look at, now that we looked at the relational operators, let's move on to logical operators. Logical operators can be performed on two Booleans. Let's consider a simple problem, right? So int I, let's say it has a value, some value. Let's say it has a value of 17. Now I would want to find out, I would want to write a condition to find out if I is between 15 and 25. So I want to find out if I is between 15 and 25 and return a true only in that situation. So if I is greater than or equal to 15, so it's inclusive. So 15 is inclusive and 25 is inclusive. So I would want to find out if I is greater than or equal to 15 and I is less than equal to 25. So if both these conditions are true, then I is between 15 and 25, right? So how can I write conditions like that? That's basically where the logical operators come in. I can say I greater than or equal to 15 and I less than equal to 25. So the AND operator is used to combine these two conditions. The AND operator result is true only when both these results are true. So if this is true and this is true, the result of the AND operator will be true. So let's see, this is true, right? So I is now 17, so this is true and this is true. Let's say now I assign a value of 30. Let's see what would be the result of the condition. What would be the result? This will be true because it's greater than or equal to 15, but this is not true because 30 is not less than equal to 25. So the result is false. So when one of the conditions is false or either of them is false, the result of an AND operator is false. For an AND operator to be true, both these conditions must match. Now let's assign a value of I to be 5. So when I is 5, what would happen? This is true because I is less than equal to 25, but this is false because 5 is not greater than equal to 15. So what would be the result of this? Again, false. The way you can try this out is true and true is true. True and false is false. False and true is false. False and false is false. This is like a truth table. So this is something you can try and remember. The easiest way to remember is AND operator is the result of the AND operator is true if both the operands are true. Now the other operation is OR. For of OR is represented like this. This is the pipe kind of a character. So two pipe characters, it's called an OR. OR operation is true if at least one of the operands is true. So false or true? True. True or false? True. True or true? Cool. But false or false is returning a value of false. So an OR operator is false only when both the operands are false. The other logical operator is called XOR, false. In an XOR is true when both the operands are different from each other. So false XOR false is false. False XOR true is true. True XOR false is true, and true XOR true is false. For an XOR to be true, one of the operands should be false and the other one should be true. You cannot have two falses or you cannot have two trues. If both the operands are the same, then the result is a false. Until now, we looked at three operands, right? AND, OR, and XOR. The most important ones to remember are AND and XOR. AND and XOR are very frequently used. The other operand which is typically used is a NOT operator. NOT is the exclamation. So NOT of true is false. It's to reverse the result. And NOT of false is true. The way we would use a NOT is by saying not x greater than 7. Oh, x is not really defined. So let's define x. Int x is equal to, let's say, 6. And say not of x greater than 7. So this returns a value of true. X greater than 7 is false. So not of x greater than 7 is true. So the most important operators that we talked about are OR, AND, XOR, and NOT. These are all called logical operators because both the operands should be Boolean. OR is true when at least one of the operands is true. It is false when both the operands are false. AND is true only if both the operands are true. In all other situations, it's a false. XOR is true when both the operands are not the same as each other. So one should be true, the other one is false. If both the operands are same, then the value of XOR is false. NOT reverses the value. So true becomes false, false becomes true. So those are the ones which we looked at till now. The other interesting Boolean operators are OR and AND. It's single OR, single AND. Until now we tried double AND. There is also an operator called AND, and there is an operator called OR. This we discussed earlier, and there is another operator called OR. So now, what is the difference between these two? We will discuss the difference between this and this in the puzzles section of this specific video. In this video, we discuss the basic Boolean literals which are false and true with all lowercase. Any other types are not really allowed. After that, we looked at a few relational operators used to compare numbers like greater than, equal to, less than, equal to, and we looked at the comparison operator as well. All these relational operators, the result is Boolean. Even though the value which is compared are numbers, the result is Boolean. At the end, we looked at a few logical operators. Logical operators operate on two Boolean values and return a Boolean value. We looked at AND operator, and also we looked at OR operator, we looked at XOR operator, and also at the end we looked at NOT operator. We will look at the difference between a short circuit AND and the normal AND in the the next video when we talk about it in the puzzles. Until then, bye bye. Welcome back. In the earlier video, we looked at AND operators like this, AND, double AND. There is another operator called AND. This double AND operator is actually called a short circuit operator. In this video, let's discuss why and look at a few puzzles around that. Okay, let's get started. So int I is equal to 10, int j is equal to 15. Okay, so let's say I have a condition. So I'm saying if j is greater than 15 and I plus plus is greater than 5. What would be the result? There are two things that are interesting to me. So one is the value of j and I after the operation. The other one is the actual result of the operation. So is j greater than 15? J greater than 15 is false, right? So this is false. What is this? I plus plus is greater than 5. I plus plus is 10. I'm doing a post, so 10 greater than 5 is true. The result is false. Because of I plus plus, we think I should be incremented from 10 to 11. J, we are not changing the value, so J should remain as it is. So now when you execute it, the result is false as per expectation. J, the value has not changed. I remains 10. So the value of I has not really changed. Let's do the same operation with a single AND. So I'm doing the same operation with single AND, and let's now print the value of j. The value of j did not change. The value of I became 11. Okay, that's the basic difference between AND and double AND. This double AND is called a short circuit operator. What does a short circuit operator means? What is the result of AND, right? So AND returns true when both of these are true. What the short circuit AND does is the double AND does is if it knows that the result of this expression is false, then it does not even evaluate this expression, because once it knows that this is false, it knows that the result of the expression is going to be false for sure. So it says, okay, I'll be lazy, right? I know the first operand has a value of false. Why should I go and execute the second operand? I don't need to do that, right? So it says, I take the value of this and return it back. So false, so it returns directly a value of false. So I plus plus does not get executed. So I plus plus I remains with the previous value, which is 10. But over here with the single AND operator, it's not a lazy thing, it's very active thing. What it says is, okay, this is false, but okay, doesn't matter, I'll go ahead and execute this. And it would execute I plus plus, I value becomes, from 10, it becomes 11. So that's the major difference between a short circuit AND and the single AND operator. A similar difference also exists between the short circuit OR and the single OR. One of the things you should try and do is not really depend on short circuiting for your logic to be executed, right? So one of the things that you'd want your program to be is readable. So things like this are not readable because it's somebody who's trying to read this has to put his brain completely into it to understand whatever is happening. So I would recommend not to use the difference between short circuit and the normal AND operator to differentiate logic. The best way for me to be doing this is to do I plus plus first. So do I plus plus first. If you really want to compare the incremented value of I in this specific thing, then I would rather do I plus plus first and then write a condition saying j greater than 15 and I greater than 5, or something of that kind is better code than this kind of code, which is complex to read. It's always good to write very simple code and make sure that this does not have a side effect. Here, the condition, the evaluation of the condition results in a side effect that the I value is incremented. That's not a good programming practice to follow. Good programming practice is to keep things very simple. The result of the expression should be true or false. It should not do increments or decrements of the specific value. In this video, we discussed the difference between a short circuit and a normal AND operator. Until the next video, bye bye. Welcome back. In this video, we would start discussing about one of the most important data types in Java, character data type. Character data type is represented by the first four letters, char. How do I create a character variable? Char ch is equal to a. Can I do this? Nope. What I would need to do is put it within single quotes. Right below the double quote is single quote. So this is how you would create a character in Java between single quotes. You cannot have two characters, right? So it's single character. You cannot type AB. AB is two characters. CH is equal to A. That's how you define characters in Java. There are a wide variety of characters that you would want to be able to represent in your language, right? So there are a huge set of characters with things called Unicode values. So each of the characters that you can write is assigned something called a Unicode value. If you do a Google for Unicode values, there is a list of Unicode characters from Wikipedia that you would get in here. So if you look at this list of Unicode characters, there are a wide variety of characters that are present. Not just the normal English characters, there are there are characters from other languages like Latin, there are Latin punctuation characters, there are wide variety of letters which are present in here as well. Some of the characters which are present in here, they are typically what you can type using your keyboard, right? So this is an exclamation, this is a double quote. So what is the Unicode value for that? Is 0022. So you can also create characters by using their Unicode values. So I can say ch2 is equal to, within quotes, I can type in /u and put its Unicode value. So what is the Unicode value of double quote? It's 0022. 0022. So you can see that the character is assigned a value of double quote. So if you have some special character which you cannot type on the keyboard, then you can try to find out its Unicode value and assign it. So let's say ch3 is equal to, let's pick up a character which is tough to type. Okay, cent. So this is cent sign, right? 0082. So let's type that in. So 0082. It represents cent. So if you want to type in cent, it's very difficult, right? Because the keyboard does not have that. So the way you can get that is by specifying its Unicode value. So /u followed by the Unicode value. So all the Unicode characters are supported by Java. In Java, the character data type has 2 bytes. So 2 bytes is a lot of memory and it can represent a wide variety of characters. The interesting thing is the fact that a number value can also be assigned to a character. So I can say ch is equal to 65. You can see that it's the a. Once I assign 65 to a character, the value is a. Now I can also do operations like an integer. So I can say ch plus plus. What does it become? What's the value in ch? You can see that it's b. So the value of ch from a, it's increased to b. If I do plus plus ch again, you would see that it becomes c. Plus plus ch again, it becomes d. So just like integers, you can also play with operators. So you can say ch plus 5. So the value of ch is uh, as it is here, it's d. The value of d is 68. 68 plus 5 is 73. The result of an operation between a ch and a integer is always an integer. This is because integer is the larger. Integer is 4 bytes, character is 2 bytes. So the result is represented in the larger one. That's why ch is taken as 68. 68 plus 5 is 73. So that's what you see in here. If you just say ch, it prints d. If you say int of ch, I'm typecasting character to int. What would happen? It would print the int value of d, that is 68. This is also the Unicode value as well as the ASCII value for ch. So the way d is internally represented is by using the number 68, and that's why you are able to do operations. So all the operations that you can typically do on integers, you can actually do them on all the characters as well. The other special situation is when you want to put something like a new line character /n. So ch now has a new line character. So if I type in ch, if I type in system.out.println ch, what would happen? It would print two new lines, because this would print a new line, and also this ch which is present in here is also a new line. So it's actually printing two new lines, and that's what you would see in here. Or you can even store a tab. So /t is tab, right? So I actually have to use the other slash. So /t is tab. And if I do a system.out.println ch, actually we are not able to see it because the tab is at the end, but it's actually printing a tab character. There you go. Those are some of the important things that you need to know about how to represent your characters. In the next video, let's look at an exercise related to character and see how to play around with it. Until then, bye-bye. Welcome back. Welcome to this exercise on characters. Now, this is the code which we would want to be able to do by the end of this exercise. We would want to create a class, myChar, which can accept a character as a argument to the constructor. So, and we would want to be able to create methods called isVowel, which checks if a character is any of the vowels, or it can also be the capital A, E, I, O, U. So myChar.isVowel will return true if this character is a vowel. Otherwise, it would return a false. Vowels in English, as we know, are A, E, I, O, and U, and also the capitals of them. And also, we would want to check if myChar.isNumber is true, myChar.isAlphabet is true, and also I would want to be able to print a list of lowercase alphabets and print a list of uppercase alphabets. So this is a very interesting exercise. This would ensure that you would understand everything that there is to be able to understand characters. Pause the video in here, give it a try, and I'll see you back. Let's continue with the solution. As usual, I'll start with copying this piece of code in. So let's go in here and say Control N. I would want to create a new class. It's called myCharRunner. I would want a main method and press enter, finish, create the class, and put this in. And I will start with commenting out all the rest of the lines. Let's start with doing the vowel first, and let's move on to other stuff later. So let's go ahead and create the myChar class first. Control 1, Command 1. Go ahead and create the myChar class. The class is created. That's cool. Now I would want to create the constructor. So I'll say create constructor myChar of char. So public myChar of char. That's cool. Now what I would want to do in here is I would want to store this into the member variable. This.c is equal to c, or I'll say this.ch is equal to ch. Typically, ch is a good name for character. This.ch is equal to ch. Compilation error. Let me press Control 1, Command 1 and say create field ch in type myChar. That's cool. So private char ch. That's perfect, right? So we now have the character inside the myChar class. That's cool. We would want to actually go ahead and create the isVowel method. So I'll go ahead and say isVowel. And isVowel, not char array, it should be boolean, right? So I would want to return whether it's a boolean or not. So initially, I'll just say false. Now we have the complete setup running. So by default, it's not using the character. So if I run the program right now, cool, false. So this is now returning a value of false because over here, I returned the value of false directly. Now, how do I find out if something is a vowel? It should be either A, E, I, O, U or A, E, I, O, U, right? So how can I check whether the CH is equal to any of these characters? How can I write a condition? CH is equal to A, right? So if CH is equal to A, let's implement it for A first, just A. If CH is equal to A, return true, right? So if ch is equal to a, then the return value is true. Otherwise, return false. So right now we only have the logic for a. What I want to do is I would want to add all these characters in. What is the easiest way? We discussed a logical operator earlier, right? I would want to return true if either this condition is true or this condition is true or this condition is true or this condition is true. What is the condition that I can put? Yeah, it's or. So I can say ch is equal to e. I can copy this and paste it 5 times. A E I O U, right? This is what we talked about. Oops, U. Okay, and I'm making a mistake. It should have been double is equal to, right? So what should it be? I would want to compare. So it should be double is equal to, and it's going outside the line. So what I'll do is I'll bring it down. Let's decrease the font size a little bit so that you can see it much more of it. So ch is equal to a or e or I or o or u. I'm saying return true. For all other situations, return false. So now let's see what would happen with c. The result should be false. If I say a, the result will be true. That's cool, right? So now with a is a vowel. So it prints that specific thing out. So that's cool. I'll leave it as an exercise to add in a, e, I, o, u, right? So that's cool as well. Now, the other way you can do that is also by actually, instead of writing or, you can say if ch is equal to a, return true. If ch is equal to e, return true. If ch is equal to I, return true, and so on and so forth. I, O, U. Three things you would need to know before you would move into the next exercise. Number one, a lot of people think that having multiple returns in a method makes it very difficult to understand. I agree. So having multiple returns in a method makes it very difficult to understand if you have a lot of complex logic in the method. But in situations like this where the logic is very simple, I am fine with having multiple returns in a method. Multiple returns makes it very easy to look at and look at what is the situations which are handled. So here, anybody who looks at this code can say, okay, if it's A, E, I, O, U, I would get true back. Otherwise, I would get a false back. So in these kind of simple situations, I like having multiple returns in a single method. That's number one. Number two, you can also extend this to capital letters, right? So A, E, I, O, U and also caps. So A, E, I, O, U. I'll leave that as an exercise for you. So you can try and code for A, E, I, O, U, and also in the mycar runner, you can write a test for it as well. That's cool, right? That's number two. Now let's get to number three. The thing is, this solution which we have in here is not really optimal. When we get to arrays and lists, you can think of better solutions for this specific problem. But that's kind of beyond our boundaries for now. We'll get to it when we talk about arrays and lists. In this video, we started with the mycar and also we printed if it's vowel. In the next videos, let's go ahead and do the other exercises. Until then, bye-bye. Welcome back. In the previous video, we discussed about mycar is vowel method. In this video, let's discuss a few more exercises as well as look at a few variations of what we have done already. Let's get started with the first one. So we already have mycar.isVowel. Now I would want to implement a mycar.isConsonant method. Mycar.isConsonant method. So what is a consonant? Anything that is not a vowel is a consonant, right? So any character which is not a vowel is a consonant. Let's assume that the characters which are in here are alphabets, right? So how can I find if a character is consonant or not? Think about it. and we'll get back to it at the end of this video. Let's go on to the next one. We would want to create a method called isNumber. So mychar.isNumber. So let's go ahead and say I've uncommented it, control 1, create method. I'll change the return type to true because I would want to find out whether it's, oops, actually I should call it boolean, not true. Where's my mind? Okay, boolean isNumber, and now over here I can do something similar to what we have done in here, right? Ch is equal to 1, 2, 3, 4 up to 10. So I can use that to actually find out if it's a number. Actually, a more appropriate way to call this would be, instead of calling it a number, I think it's better to call it a isDigit, because that would be a clear representation that this is a numeric digit, right? For now, return true back. Let's get the entire code to compile. So the entire code compiles. So that's perfect, right? So isDigit now is returning true for everything. The easiest way to do that, as we discussed earlier, is to just compare 1, 2, 3 and all that kind of stuff, right? So that's the easiest way to do that. But think about it. So we discussed about characters being numbers in the previous video. So can we use that kind of a logic to find out what is the ASCII value for 1 and what is the ASCII value for 0 and go on up to 9? Would that be a good thing to do? Think about it, pause the video here, use that hint and see if you can implement that. So when we talked about characters earlier, we said characters have their own integer representations, right? So I'm doing an int of 1. What is it giving me? 49. So if I do an int of 0, it gives me 48, and int of 9 is 57, and you can see that these are increasing values. So 0 is 48, 1 is 49. If I do it for 2, it's 50. So it's increasing values. So the actual internal representation in terms of number for the character is actually that it's starting from 48 and it ends at 57. So can we use this fact in our example? I would want to find out if a ch is greater than, what's the 0? 48. So ch is greater than or equal to 48, or ch is less than or equal to 57. Is this a good condition? Should it be or? Should be and? Think about it. Think about it, pause the video and come back here. Okay, the right approach would be, the character should be between 48 and 57, right? If 48 and 57, if it's between 48 and 57, then it's between 0 and 9, right? So in the comment, I'm trying to actually just give a hint as to what we are trying to do in here. So if ch greater than or equal to 48 and ch less than or equal to 57, return true. Otherwise, return false. Isn't this cool? So now let's run a few tests. So mychar.isDigit, what does it print? A, false, right? So the first one true is coming from isVowel, and this is isDigit is coming as false. Let's put a 6 in here and see what would happen. So my vowel is false, obviously, and this is true. So isDigit is becoming true. That's cool, right? So isDigit is now working as we expected. Now, I would recommend you to pause the video here and try and do the isAlphabet on your own. So isAlphabet, you can think about the logic, right? When is it alphabet? A to Z or A to Z, right? So try and figure out what are the values for it and see if you would be able to do it on your own. Let's go and do it now. Int A is 97, int Z is 122. So let's start with that. So 97, 122. Let's comment this out. I would want to create a method called isAlphabet. I have a method called isDigit. So let's use that. Control C, Control V, isAlphabet. Now the value I would need to check is 97. And the other one is 122. And one of the important things with writing comments is that you make sure that you have them updated, right? I mean, writing a lot of comments is good because it helps you understand, but writing a lot of comments is also bad because you have to keep maintaining them, keep making sure that they are updated with the code you are writing, right? So this is cool. Now, if it's alphabet, if it's between A and Z, the other situation is if it's between A and Z. How do I find out if it's A and Z? A is 65, so let's go ahead and use that, 65. And what's the one for Z? 90. Isn't this cool? The thing is, JShell is helping us so much, right? Earlier, if I wanted to find out the ASCII character for A, I have to write a main method, try and print this out in a system.out.println. But with JShell, nope. I kind of play with JShell and I get the things that I would need, and I would put it in the alphabet. So that's very cool, right? So if it's between A and Z, it returns true. If it's between capital A and capital Z, it returns true. And return false. That's cool. Why did I remove that? We can put it in a comment. Okay, that's cool. Now let's run it. 6, is it an alphabet? False. Now 7, or let's put an A here. Is it an alphabet? Yep, that's true. Cool. That's perfect. So we now have implemented is vowel, is digit, and is alphabet. Let's take a pause in here, and I'll see you in the next video where we would be talking about the printing lowercase and the uppercase alphabets. In between, I'll recommend you to try and think about mychar.isConsonant again. So what we'll do in the next video is we'll start with mychar.consonant. Anything that is not a vowel and it's an alphabet is a consonant. So how can we